Hello, check, check. Hey, can you guys hear me? Well, welcome everybody. Good morning. I'm Ryan Johnson. I'm the 2020 TAP chair, and I'm an architect and computational designer at Clark Nixon. Hello. Need to hold it closer. Okay, sorry. So here's the Wi-Fi password if you don't have it. It's in the back as well if you need it later. And the last housekeeping thing, the bathrooms are through this glass door on the right when you walk out. So why do we have BCC, the Building Connections Congress? The point of TAP is to ask, like, what does the industry need to know about technology, like the bigger industry, the bigger AIA? And we're here to equip the AIA with this knowledge. So I'm going to have like a 15-minute kind of introduction here to kind of provide clarity on what the theme of the conference is, which is computational design. I know that we're all probably at different levels of exposure. There's some people that are like rock stars at using computational design, and then there's probably other people that, have no idea what the definition is. So I'm just going to set a foundation for sort of all the speakers to kind of provide clarity on that. Whenever I talk about technology, this is one of my favorite quotes. And Nietzsche's friend wrote to him and said, hey, I noticed that your writing style changed when you switched from writing with a pencil to writing in a typewriter. And Nietzsche's response was, you're right, our tools impact what we create. Or another analogy is like if you think of a wood shop, if you've got a table saw and a miter saw, you can make a lot of things, but if you add more tools to your toolbox, like a dovetail jig and a router, right, you can make new joinery and open up new possibilities. So there's this relationship of what's created and what's used to create. And why did we get into technology in the first place? Or like a lot of us here, why do we pivot into technology from the traditional roles? And for me, it really wasn't about the technology, it was about the ideas. I wanted to come up with these new ideas and try to use these tools creatively. And why did I get into architecture in the first place? There's probably lots of different reasons for each person. It could have been the environmental reasons, it could be design reasons, it could be societal issues. We're trying to solve these issues, and we're trying to answer these questions, these big issues and questions, and our tools and technology really aren't able to cut it. And this is where computational design comes in. This is sort of a simplified quote from Minges and Alquist's computational design thinking. The definition of computational design: codifying information and interactions between elements for a specific purpose. And it's really about a creative use of computers. And if it doesn't make sense yet, I'm basically going to spend the next 10 minutes explaining. So, I kind of feel like there's this tension between what our tools can do and the issues we're trying to solve. And this is basically like a computational design 101 that I give to my firm. I'm kind of going to sum up here. So you've probably seen this quote before. Architects don't make buildings, they make drawings of buildings. I think we may be shifting away from that, but generally speaking, 99% of what we do as architects is draw drawings. So I think it's a good quote. And if you look back, we started with hand drawing, and it was really about documenting design intent, and I think also is a huge part of our creative process. I don't know about most of you, but even if I'm doing computational things, I still start with like a piece of trash paper and a pen, just because I'm trying to get my ideas down. So there's that connection kind of between doing something in the physical kind of hand-drawn world. And hand drawing had its limits. If you look at Gaudi's hangings, diagrams, basically, he couldn't get his ideas out, so he had to leave paper and go to the physical realm. And There's other examples like Otto's soap bubble experiments where he's using the physical properties of soap to kind of optimize structures because the pen and paper just wasn't cutting it. And as an aside, this is what it looks like now. They've completely switched to 3D printers and, because the tools and technologies have changed. So then we're kind of jumped to CAD. That's the next paradigm shift. And people were kind of saying, hey, how can we make these changes faster and reproduce faster? It was still, in my opinion, really focused on documentation. It was really pragmatic in nature. It's like, how can I document this more efficiently? And the main focus was computerization, which is taking ideas that you already have in your head and putting it into a computer. So the computer is really just a thing where you're putting this information that you already have. It's not helping you design something. And then the next big paradigm is BIM. And people started looking around saying, well, why can't this wall know that it's a wall and this door know that it's a door? Why isn't the computer helping us make better decisions? So it's this shift from dumb to smart. And its impact, though, on creativity, I think, was still pretty limited because it was mainly focused on documentation. That's really its main purpose. And if you look at the firm survey with BIM adoption for mid-sized firms in 2018, in 13 years, it went from 10 to 75%, which is 65% increase. That's basically, in my career, BIM is fully adopted, in my opinion. And here we are, it's 10 years or 10 years since, or 10, 12 years since BIM has come around. And what I really think happened is there's this 10,000 hour rule by Malcolm Gladwell. And it says, it takes 10,000 hours to basically become an expert in something. And what I think happened is you have these super users or these people who are really trying to push technology to solve problems kind of hit that expert level of BIM, and we started looking around and saying, well, what's next? What can we do to kind of keep pushing technology to solve problems? And that's where I think computation comes in. We looked around and said, well, why are none of these other processes, why aren't these computers helping us make better design decisions? We're not abandoning BIM, but we're changing the way we're thinking. It's about evaluating designs instead of documenting designs. It's about questioning and answering questions over like a pragmatic approach. It's about a process more than like a centralized model for information. And yeah, that's the sort of the last paradigm shift. And if you remember, what are we doing here? Why did we get into technology? It was not about technology. It was really about generating ideas. And what is computation? It's using computers creatively. It's codifying this design intent. It's leveraging computers to help us answer questions. And what we're doing is we're trying to shift from this computerization towards computation. And if you remember computerization, that is taking an idea already formulated in our heads and putting it into a computer and actually trying to use computers to help us answer these questions. And again, here's my simplified version. It's not about codifying the outcome. It's codifying these interactions between elements. You're formulating specific things. It's not magic. There's nothing magical happening. This is done by the designer. You're still involved. So it's a specific thing you're putting into the computer. And these are called, basically the way you do this is called algorithms. And algorithms are an unambiguous set of properly defined instructions. And it's a process rather than a single object. And again, we're not removed from this process as designers. And I think when people hear words like algorithms, especially a lot of designer people, they can kind of get overwhelmed or check out when they hear that. And you got to remember, this is a process, and there's levels of understanding and level of interactions that we're all going to be interacting with these algorithms. So when we look at something like this, we don't really know what it means, but we can look at a set of drawings, like we know what a door tag is, we know what a wall tag is, we know what a curtain wall looks like in a door, we know the symbolism that's embedded into our drawing sets, just like an electrical engineer can understand what this is. So I'm from North Carolina, I'm a synth nerd. Moog is from North Carolina, they're all made in North Carolina, so I gotta throw in some Moog references. On the left is the Bob Moog low pass filter, and on the right is Bob Moog. And this is the definition of computation. This diagram is an unambiguous, specific set of interactions between elements for a specific process. There's inputs on the left, like you hit a key, you can turn a knob, and then you get outputs, which in this case is sound. And there's a known thing that's happening through this process because it's this design intent is encoded into this this process. And just like voltage flows through the other diagram, and if you take the way we sort of present computational scripts, we can flow information through a computational design script. So you can input geometry of a window, time and date, cost information, and then you can get outputs of energy usage, geometry, and cost data. So it's the same kind of process, and we're all going to interact with it differently. There's going to be people that are creating these algorithms, and then there's going to be people who are just using it because they understand the connection between the inputs and the outputs. And that's what we're doing. We're designing these interactions and these processes for a specific outcome, which is the definition of computation. In creating these processes and interactions, that's basically thinking computationally, computational thinking. And I like this quote because it's super controversial without the context. There's a bunch of people that would totally disagree, but the context is in Bruce Mau's Manifesto for Growth, which is basically saying, like, how can we create change and grow? So how do you generate that kind of engine? And what he says is, when the outcome drives the process, we're only ever going to go where we've already been. And if we look back to these issues, like why did we get into architecture? What were these big issues and things we're trying to solve? It's trying to use computers and change the process so that we can actually try to answer these really hard questions we're trying to answer. And so what kind of questions? Questions like, I have this design concept, but I'm worried about blank, or I'm trying to understand the relationship between X and Y, and I can't really understand that. It takes a designer saying, hey, I have this design concept for a bridge, and I really want it to have these mirrored panels so that it can reflect the sky and it can reflect the surrounding environment. But I'm worried about glare. Is there any way I can check out glare and heat gain on the surrounding buildings? So that's a tough question, but it's really about the design. Or, hey, what's the correct glass type, window size, fin size to have only one chilled beam in this office? And our speakers are going to give like a gazillion examples of and really unpack all these ways you can kind of ask these questions to try to get these new answers. And ultimately, the goal of all this is to impact the profession. I mean, that's why we're having this conference, is we're trying to move the needle. We're trying to solve these issues that we've laid out at the beginning of the project, and thinking about how we can move past computerization and into computation. And it's this methodology for approaching problems. It's really, like I've mentioned before, it's a design tool. And ultimately, this should sort of work its way throughout everything. And Nick Cameron, who's speaking later, he had said, hopefully it'll go away, right? I mean, we don't talk about doing 3D models anymore. We just do it. We don't talk about doing renderings. They just happen. We don't necessarily talk about using BIM. We just do that. It's all assumed. We don't really talk about it. So, I think in 10 years, we won't necessarily be talking about this because it just sort of is. And the best thing about all this is since we're trying to teach ourselves to think computationally, it's sort of tool agnostic, which helps give me some relief because it sets us up with a good foundation for how to approach problems. And as these tools we start to use are all changing and the half-life is changing, and there's way more tools than we used to have, but they're all kind of approaching things computationally and using computational thinking, we can kind of weather that change, which to me makes me have some relief, like I said, that I can kind of continue to move forward and be innovative, because there's not a huge chunk that's changing for each of these tools. And if we look back to the problems at the beginning, like why did you get into architecture in the first place? At a computational design conference, they basically just said, how can we use computational design to blank? So take what is the issues of now for you, like what are the problems in your firm that you're seeing, or what are the problems in our industry that we're seeing, and it may not be the right tool, but it could potentially give us these answers and new outcomes and things. So throughout the day, I want you to think about your own firm and what's happening, and if you can kind of understand how to apply these things. And there's sources. We'll post these slides later, and you can check the sources. Okay, so shifting to the conference, perspectives is the theme and the structure of the conference. And the thing that I value the most about this conference is that we have these differing perspectives, and it's not just like a whole huge cheerleading session. So the other point of this conference is to equip us to go back to our firms and to lead technological change. So we're tasked with discerning the future and trying to navigate what's hype and what is actually going to be impactful. And one of the interesting parts about being tech leaders is this dichotomy that we have. It's this optimistic champion versus this realistic cynic. And Alyssa, who's going to speak later, she said she puts on a game face when talking about technology. And we're all inherently cynical, but we really can't show it. So this is the place where, I'm hoping we're going to have some constructive conversations where we're having, these difficult conversations, so then we can be able to answer and sort of defend our positions, I guess, when we go back to our firms. And that dichotomy is the structure of the conference. So there's going to be 5 sessions with 2 speakers each, and they're each going to be speaking from 2 different perspectives on the same topic. And these 5 topics were kind of what emerged as we were looking at what do people need to know about computational design and how are people using computational design. So these were sort of, there's a lot more facets to computational design, but these are sort of big themes that emerged. And you should all have this handout. If not, I can pass them around. So what I want you guys to do throughout the day is write down any ideas or themes or topics that jump out with you in as few words as possible, 1 word, 2 words, 3 words. And don't worry about filling out the whole thing. You may only have a few items total throughout the day. And at the end, we're going to have a mini workshop to discuss these themes that may emerge, to try to tie the day together and sort of make some next steps and kind of get some big picture ideas. And again, I would think of this as like something personal. Like what is it that jumps out for you specifically, or an idea you're going to take back to your firm, or sort of your aha moment or your light bulb moment. Okay, so I want to introduce some key people. We're live streaming this for the first time, so miking is important. And if you're seated not at this round thing, I'll be walking around with a microphone if anyone has questions for the people in the chairs over here. And Brad is going to be fielding comments from the live stream, so he may get more airtime, but it's really just so that people in the live stream can contribute. So if you are in the live stream, definitely feel free to write questions when we get to the end, and we do have someone who's going to be reading your questions. So Charlie Williams, he's the 2019 chair, and he'll be leading the first 2 sessions. So if you can come on up and introduce the speakers.
Thank you, Ryan. It's a pleasure to be here, and it's great to see the culmination of all your hard work this year. This does not happen magically, and it actually happens all because of the hard work of Ryan and his leadership in this effort. So if we could actually take a moment and give him a round of applause for that. Thanks again, Ryan. So very exciting day. To kick us off, we're going to be talking with Emily Griffith and Violet Whitney. Emily is with North Carolina State University, and her speech is about, her conversation is about why architects need data scientists. And as I'm listening to Ryan, the one thing that jumped out at me is the question, flowing information through a computational formula, really at the base of that is data. And as each one of us grapples with how important data is to our process, I think the value of a data scientist becomes pretty clear. But with that, please welcome Emily to give us more information. All set?
I think so. All right. Can you guys hear me? Is it working? No. Now? I'm not, I don't think it's close enough to my mouth. Data strategies. Okay, is that better? Can you hear it? No. Is that better? Okay, I'll just hold it. All right. Okay, so hi, everybody. Thanks so much for the introduction. Thanks so much for inviting me to speak. I always love working with architects and designers at NC State. It's such a nice change to have pretty slides and beautifully conceptual ideas, and to spend time thinking about why we think about these things. So my slides are the standard NC State slide deck, but I'm very excited to be here. All right, so I wanted to take a second just to talk about myself very quickly, because I think I do have a very different background from everybody else here. So I'm faculty at NC State University in the Department of Statistics, and my job there is to be a consulting and collaborating statistician. So I spend my time working with practitioners, is sort of our term for you all, in every college in the university, and communicating statistical ideas to them and helping them understand how they can best use their data, what kind of data they need, how to think about statistics for the sorts of work that they do, and to do that in a statistically rigorous but also welcoming approach. The other thing is that I'm currently the deputy director of SAMC, and so this is my little plug for them. SAMC is the Statistical and Applied Mathematical Sciences Institute, which is an NSF-funded initiative. They're currently running a year-long research program on games decisions, risks, and reliability, and a lot of that is actually working. They're starting to work with engineers on city design for self-driving cars, and so that's, I think, kind of related to what you all are working on with this idea of making everything smart and efficient and optimizing and using data that way in training your algorithms. And so if you're interested in that, come talk to me. All right, so I am going to just address the 4 learning objectives that you have from this. So we'll talk about thinking like a statistician, and then designing questions or problems the way a statistician would like you to, and then understanding assumptions and bias, and finally I'll talk briefly about using quantitative results. And so this order, I think, actually flows pretty intuitively from one step to the next. So this is the general plan. All right, so the first thing is that this is a really exciting time, I think, in data, because data are everywhere. And data-based decision-making is increasingly important, and then even more so, it's increasingly possible. And you all are familiar with that as computers have gotten more powerful and our computational ability has grown. We're able to do things that we weren't able to do not that long ago. And so statistics is adapting to that as well. It's a very exciting time for us now that we have these tools. But the main thing is that statistics is the science of turning data into information, but in a way that has strong theoretical underpinnings. And so everything that we do in statistics needs to be grounded in theory. And there are these new methods that are reaching out, but we don't want to get out ahead of where the theory is. And so the more that I work in statistics, the more I appreciate theory. It was not my favorite as a student, but the more I do anything, the more I see the need for that kind of thing. And so we're going to talk a little bit about statistical theory because I think it's really, really important. The other thing that I always tell my students is that data are numbers, but with context. And so that's one thing that we're going to emphasize is that context over and over and keeping that in mind, because that's really what separates us from pure math, right, is that context and that rooting and application. So this is my diagram of statistical inference. And so this is how statisticians see data and think about data. No matter what kind of statistician you're working with, this is what we do. So what we have here is a population, and that's a group that we can't reach. We don't ever know the full population. And it could be because there are too many things in the population, it's too expensive. It could be that the population doesn't all exist at the same point in time. So whatever it is, we don't know much about that population, if anything. And so what we do is we take a sample. And the way that we take that sample is based in probability theory. And there are a lot of assumptions that we make as we pull a sample from the population. And all of that runs kind of underneath and is a little bit invisible. So when you get a data set, your data are a sample from a population. And that might not be explicitly clear. We don't necessarily talk about that all the time, which I think is a problem, actually. But your data are coming from some population, and knowing what that population is really, really, really important. So once you have your sample, then you can do stuff with that, right? So that's when you create a model, you train some algorithm, you do a cool thing, and you have some kind of conclusion from whatever the thing is that you have done. And the fun part is, because of these assumptions that you made when you took your sample, now you can draw your conclusions about the whole population. Because we're not necessarily interested just in our sample, right? We're interested in how these things apply to a bigger group. And so the beauty, I think, of making these assumptions and recognizing what they are and how they work is that it lets us conclude things about the population without actually having to have the whole population, because we assume a structure, we assume a behavior, and we assume a lot of different things, and it's different things depending on what you're doing. So I'm not going to get much more specific than that, but this is the process of statistical inference. And so anytime you're doing any kind of statistics, this is actually what you're doing. But we tend to live in the sample space and not necessarily think about the population space unless that's your job to do. All right, so because of that, when you are going to start working with data, you want to think about what you're doing before you do it. So you want to think about the inferences you want to draw. What are you trying to say? What are you trying to learn? What do you want to be able to conclude? And you want to be very, very specific, and we'll talk more about that in a minute. And you want to have clear and measurable goals. So the measurable is the key there. But before I talk about that, I want you to ask yourself, why are you even using data at all? And I feel like I'm going to get my statistician card pulled for asking you that. But data aren't necessarily the answer to every problem. They don't necessarily solve everything. And so what can you conclude with data that you can't conclude without it? And if you don't have a clear answer to that question, I think your experience with data is going to be just really frustrating and not necessarily get you anywhere. If you do have an answer with that, then that answer can guide your whole process, and then it'll be kind of fun, I think. All right. The other thing is that once you have data, and especially if you have data and then you're trying to use that data to answer a question, they weren't necessarily lined at the beginning, it can be very easy to get lost in your data and just start doing stuff, right? I mean, it happens all the time, right? And then you end up with a bunch of results and no questions that you've answered, and then it's just a mess, right? So you want to really avoid that and think really carefully about what specific thing you're trying to do or things you're trying to do, and then do those in a really methodical way. Okay, so making sure it's measurable. This is something that was kind of a surprise to me when I started working more in practice, is that this idea of measurable is really hard. So how can you measure what you want to find? And can you measure what you want to find? How expensive and time-consuming will it be? And then what value will those measurements add? And the expensive and time-consuming is also really important. I went to a talk recently where the statistician talking didn't ask somebody about the time when she designed an experiment, and it took a master's student 3 years to collect the data for his master's thesis, right? So that's like appalling. And she was like, I'm surprised he still speaks to me because like I led him so far astray. So you want to think about that before you get started. And so just as a quick example, based on like some poking around that I did in design and then some thesis committees that I've been on, if you want to optimize something, that sounds really easy at first, right? Like we're going to optimize this thing. But what does that mean? So I was on a committee where we looked at like the shape of the louvers in windows to optimize daylight. And it turns out highest is not the best for daylight. You know that. I did not. You don't want like sunlight streaming in your window full bore all day long. That's not a good solution. So is it the highest? Is it the lowest? Is it somewhere in the middle? How much of a range is there for your optimal solution? And then is there more than one metric? So are you looking at just one thing? Or are you looking at a combination of things? Do you want all of those to be in a specific range? Do they play off each other? How does everything relate? And it goes on and on and on and on. And so all of these are questions that hopefully you have time to ask yourself before you start computing things. Because if you don't, it doesn't work, and then that's frustrating for everybody. All right, so if your goal is improvement, you want to know how much improvement is worth pursuing. And this is the second part of measurable. So once you have something you can measure, then how big of a difference matters. One of my friends works in a biostatistical setting, and they have decided that the difference that matters is the difference at which they will change hospital policy. And I thought that was really smart. And so now I'm telling everybody that that's what they do because that's really smart. So what difference matters? If there's like a 1% improvement, is that enough improvement to make it worth all the things that you would have to do that or not? If your goal is information or estimation or prediction, you're trying to establish a relationship or something, how accurate do you need to be? And if you're building a model, again, how accurate does it need to be? Do you need to be sure that everything in your model is like a certain level of important? How much will it cost to measure all the things that are going into your model? Are they easy to get? So if something's really expensive, do you really need it, right? Or if it's hard to get? So you want to think about all of this as well. So there's a lot of thinking at the beginning. All right, so once you have a research question and you have measurable pieces and you have a plan for all of your everything, then you want to think about data and your assumptions and your bias. So this goes back to this whole statistical inference cycle. If your sample is not from your population, there's a problem. Right, and I mean, like that seems really obvious, but it's not. It's really hard to get. So there's like the famous example was they did a telephone survey for the election when FDR won, I think, and the telephone survey showed that he was going to lose, but that was because only rich people had telephones, right? So the population that they were reaching with their survey was rich people with telephones, not voting people. right? So those are different groups. And now we have like cell phones. So phone survey stuff is just a nightmare now because people like, who has landlines and answers surveys on the phone? Yeah, old people in rural areas, right? And so, and that's, again, that's not like the population of the United States. And that's people, and you can see people, right? And so if you have some kind of bias in your data set, that bias is going to be transmitted through your inference, and you're going to be misaligned with your population. And so that's a really big problem. And so that's why it's so important to think about your population and what that is, and then how your sample relates to that population. Ideally, you would take like a simple random sample from a list of all of your units in your population. That is largely impossible. And so there's a ton of different methods for dealing with that. But you do want to take a look at, especially if your data are just data that are available, where did they come from? And how did they get to be like in your computer? Because that really, really, really matters in the end. All right, so thinking about assumptions and bias a little bit more, there are 4 types of errors that we have in statistics. The first 2 are the 2 that we talk about a lot, and the second 2 are kind of my favorite. But the first error is a type 1 error, and that's a false positive. So it's saying something is important when it's not. This error most commonly happens when we're testing a bunch of stuff, because your chances of having a false positive are at a certain rate you set at the beginning, but it kind of builds up the more tests you do. So if you're testing like 5,000 things, you're going to find a lot of false positives in that. And so you want to be aware of that. The second type of error is a type 2 error, because we just numbered them, and that's a false negative. So that's failing to find something when it's there. This usually happens when you don't have enough data, or your data are too noisy and it obscures the signal. So you don't have enough information to separate the difference that you want to see. And that's something that we can check for before you get started. So that the kind of, well, I think it's fun, but you guys won't like it. Those 2 differences are related. And so if you make your type 1 error rate low, your type 2 error rate goes up. All the time, every time. And if you make your type 2 error rate low, your type 1 error rate goes up. So you cannot minimize both of them without just getting more and more and more data, which then eventually will increase your type 1 error rate. So you want to balance those is the trick. So you need to think about which mistake matters more and which mistake you would rather make if you're going to make one, because we don't know if we've made one of those. We just know how likely it is that we have. Okay, so the type 3 error, which is sometimes called an error of the third kind, is answering the wrong question. And this is something that we can avoid doing. But if you collect data that are misaligned with your population, or if you misspecify your hypotheses or your model, you can even get a right answer, but you get it for the wrong reason. And if you're interested in figuring out what those reasons are and gauging the impact of them, then that's a big problem. But this one you can eliminate completely with planning. And then the type 4 error is interpreting your results incorrectly. And that's a nice one because, again, that one you can make go away. So type 1 and 2 always are around, but type 3 and 4 you can get rid of with planning and understanding. So my final word of caution for you is to just keep in mind that when you have a statistical or a mathematical model, it is entirely relying on the assumptions that have gone into that. And that makes it valid. And so if you don't know what those are, that can be a little scary for me. And so you want to know what you're assuming and how likely it is to be true. And there are some assumptions that it's okay to violate and others that really matter. So you want to know like which category the assumptions that you're violating fall into. And then you want to think through the impact of each of those assumptions. So if you are violating it, how? And then what does that mean for your algorithm or for your results? But I didn't want to end on kind of a downer. So for positives, I think that expertise plus data is really exciting. And this is the future, and it's how we're going to learn new things and get a lot more knowledge about what's happening in the world. So I think we're at a very exciting time again, and if we can just remember the assumptions and understand the structure of what we're doing, then we'll be great. And that's all. So thank you.
Sit down, whichever you'd prefer. Thank you, Emily. That was a fantastic way to start the morning. Core to our conversation here is this idea of data, and I appreciate you helping us begin to think like a statistician. And one of the things that you defined in that was really kind of confirming for me was this idea that statistics is moving data to information. And I especially admire the work you're doing with your organization. And I think it ties directly into our next speaker here, who is Violet Whitney with Sidewalk Labs. One of the things that you mentioned, Emily, that your efforts are going towards is this working with cities and self-driving vehicles. And I think as you look at what Sidewalk Labs is trying to do, for those of you that may not know this, they're designing a district in Toronto's eastern waterfront. And this isn't just a small little endeavor. This is taking on everything that it takes to develop small cities, from what I can understand, including the infrastructure, the housing, the commercial work, and the transportation that goes along with this. And as you think about Sidewalk Labs and they're collecting data and then moving it to a place of understanding and making decisions on it and using that information to come up with some really creative design solutions, I hope, for Toronto's. So Violet will be speaking on the conversation of filter bubbles, and she had a secondary title for that I'll let her explain.
Great.
Thank you.
Thank you. Can everyone hear me? Great, thank you. Let me just pull up my presentation. Great, thank you. I also just want to start by saying I'm going to bounce back and forth a little bit today between the two worlds that I live in. One is Sidewalk Labs as a product manager, but the other I'm going to speak a lot about is my work from Columbia as a professor there, really thinking about data and data analytics and how we use it in computational design. So just to have a little bit of grounding before we get started, we're going to do a quick meditation. You didn't think it was going to start this way, but this is what's happening. You're here now, and you have to do it. Okay. So I just want you to close your eyes for a little bit. Think about where your phone is. Don't touch your phone. Just think about it. And I want you to draw a white string from inside your brain, down your spine, through your arms, out your fingertips. Imagine it wrapping around your hand and your phone. Pull that string into your phone. Think about what was the last thing you had open on the phone? Were you emailing? Were you texting? Were you in a map? Draw that string through the internet out into physical space. Connect it to the person you were talking to, or down the road where you were trying to find in that map. All right, that's it. I just want us to think what I think is really interesting about data and data-driven methods is we're actually living in a very different time where data is ubiquitous. We are connected to things everywhere all the time. And I also just want to get a little sound check on the room on where everyone was last, like in these digital spaces. So first we need to calibrate the room to just benchmark and understand what the room sounds like. So before we do anything, I'm just going to ask everyone on the count of 3 to stomp, and then on the count of 3 to clap, and on the count of 3 to snap, okay? And then we're going to do something else. Okay, so on the count of 3, stomp. 1, 2, 3, stomp. Okay. And now we're going to clap. 1, 2, 3. Okay, and then we're going to stop. 1, 2, 3. Okay. So whatever you had open last, on the count of 3, you're going to either stomp, clap, or snap. Does everyone remember what they had open? Okay. 1, 2, 3. So it's just nice to know, you know. Just like to understand. Okay, so I'm going to talk about 3 data-driven methods that I use both at Columbia and at Sidewalk Labs. And hopefully this helps us understand different ways that I think architects and designers can be thinking about data. So we'll talk about society-scale agent-based models, interdisciplinary models that we're using at Sidewalk Labs using generative design, and then human-scale prototyping that we also do at Columbia. Okay. So the computerization of every aspect of life has created a platform society. Today, most of our social and economic relations take place through platforms like Facebook and Venmo. Tinder's matching algorithm leads to an increasing number of matches and marriages each year. Ultimately, its algorithm will shape the genetic makeup of the human race. As swipes are made, humans are matched, and babies are born. The filters of StreetEasy dictate what someone sees. They literally filter the makeup of who lives in what neighborhoods, reprogramming entire city zones. Yelp reviews choreograph people through siloed canals across the city. When recommendation engines reinforce a user's preference, they generate spatialized filter bubbles. So the invisible code that powers the city's use may have more drastic influence than any physical invention in the last century. And so I don't think, you know, a programmed city isn't entirely new. Even a phone book started to direct people to places that started with the letter A, right? And even the physical layout of spaces have always had an affordance that defines how we behave in physical space. And Louis Kahn knew about this in the way he drew program diagrams. Even Robin Evans talked about how the networked bubble diagrams of physical space dictated who we would talk to, what we would do. Frank and Lillian Gilbreth, through time motion studies, tried to understand how human behavior could be optimized based on physical space. So at my class at Columbia, we try not just to think about the physical aspects of space, the walls, the infrastructure, but behavior, time, movement, policy, growth. How do we behave in physical spaces? How do we start to measure that? So this is work from the class. Students are thinking about things like not just how people move through a road network, but what happens based on road closures. How does autonomous vehicle fleet size impact congestion? If we change waiting times on Uber, how does that impact an individual's waiting time based on a street grid? Can we think about Google's routing algorithm actually changing based on individuals' preferences, walking past more nature, or maybe you want to walk on a street that's not as loud, or thinking about evacuation based on various street grids. So now I want to talk about some work at Sidewalk Labs, and we're going to jump back. So one of the methods we're really interested in is understanding the interdisciplinary impacts of various simulations. So I work on a product called Generative Urban Design, really trying to understand how do we understand impacts in a planning process that has many different types of experts. Someone's working in a financial model in a spreadsheet, another one a daylighting model, someone else might be working on a wind model. So how do we put those into a centralized location so that we can see the trade-offs between those various simulations to understand how a street grid impacts routing or shadows, or even how something like the shape of a building will ultimately impact cost or the height, how that impacts the shadow. And so we pull these all together really to try and help bridge those conversations across various disciplines so we can talk to one another and see these problems much more statistically, not think about one scenario, but think about how they impact various objectives. So each one of these dots is actually a possible master plan scenario. Then the final I'm going to talk about is the human scale. So now we're back at Columbia, another class that I teach with a woman named Gabby Brainerd called Measuring the Great Indoors. This is my Amazon Echo. I put an eye on it because I thought it was funny. But the class is really focused on this new moment in time. All of these smart home devices actually change our behavior in physical space. They are an element of how we experience space. And where architects usually design models, even the simulations that I do in my other class, are to predict what will happen decades later once the building is built. After that, we might get data or an understanding of how people actually flow. But what's really interesting about smart home products is they can be deployed instantly, and that has a much more short-time feedback loop about how quickly behavior responds to that change. But design a smart home product, you need a certain level of expertise. I put zeros and ones as in, you need to know how to program some pretty low-level stuff. Probably not zeros and ones, but you get the idea. Arduinos might make that a little bit easier, but even still, you still need to learn some programming. In our class, we're focusing on microservices using if this then that. And what that means is I can write really simple, almost language-like bits of code to prototype something. So if the temperature rises 3 degrees, turn the fan on. And what that means is that all of a sudden designers have the ability to have user-written code rather than writing a whole monolith application that an engineer might write. You just write this tiny little bit that talks to all these different services. And that allows us to think much more about how a design impacts the actual experience of a space in a much shorter feedback loop. So in the class, students think a lot about these kinds of simple systems that talk to one another. If this happens, then something else should occur in the space. We like to have fun with the different names of what these things could be. So, FOMO talk, speech detected, play live feed of outside. We do stuff like that. One of the students was making a design for changing the lighting in a space based on where they were in the room. So if they go to bed, the light should turn to a red color. And what's really fun about these different systems we're prototyping, these big markers are what's actually tracking where he is in the room. They're actually, all the prototypes we make are really hacky and bad. So you'll have weird things where the light takes a little while before it actually triggers. In my bathroom, I tried to make this thing that would turn the light on when I went into the bathroom when I shut the door, but it would always turn off as soon as I was in there. It was just very awkward. And then my partner was like, we gotta do something about this. This student was looking at how buildings could actually have personalities, and this was trying to get someone to open a window if it was nice outside, and the building would actually talk back to you. Another student's thinking about how you could actually vote on what you wanted an environment to be like just based on your face. So based on people's faces in this room, could the room adjust to what we wanted? So if you take anything away from this whole talk, I think what's really important is that there are many different methods for us as designers to engage in understanding the actual end behavior of how what we design is impacted. And I think we do that through different methods of using data. Because without that data, it's all speculation. And of course, each one of these methods has assumptions and speculation within it. But it's a way for us to start to kind of understand what we're ultimately trying to get to. Okay, that's it. Thank you very much.
Welcome back. If you two could join us up here at the lectern. I think this next part of the conversation for me is one of the more interesting aspects of what I think makes up the Building Connections Congress. So many conferences you go to, it's a 30, 45-minute lecture on what somebody else has to say, but this is really your opportunity to solicit feedback from our two speakers. It is always tough being the first two to get the morning started, so thank you very much. Inspired by both of you. So with that. Lost my mic there for a second. All right, we're back. So with that, I'd like to open it up to the floor for any questions for Emily or Violet. Don't everybody rush up. Gentlemen here in the back, if you could introduce yourself and a little bit of housekeeping. The microphones that are in front of you, please make sure those are turned on. I believe a red circle means that that speaker is speaking so that we can pick it up for our audience who's online.
Good deal. Hey, my name is Greg Seaton. I'm with CSI, the Construction Specifications Institute. I wanted to ask specifically for Wendy. Oh, is that your name? I'm sorry. Now I've lost. Emily. That's what I was thinking. I said Wendy, but I meant Emily. A couple things there that really struck me, and I think you covered some of them in your talk, but the notion of extending a sample to a population, or taking a sample because a population may not exist, for example, right? This had a real immediate resonance for me in the built environment, because we have a bunch of buildings with smart sensors and can collect a lot of data about energy performance and things like that from those buildings. And extrapolating it, though, then to the rest of the building stock that doesn't have those types of sensors, where the measurement becomes dramatically more expensive, right? Collecting that data and measuring it. And that instantly, for me, carried with it the potential for a lot of biases, right? Because those smart buildings may be newer, they may be better designed, whatever. So your thoughts on any of that? I have one other after that that's very short, but.
Yeah, so that's exactly, that's the whole point and the problem, right?
Right.
Is you can't necessarily measure everything, but if you can say, like, well, these are the things, like when we look at our smart sensors and we have all these measurements, these are the relationships that hold. Do they hold for the older buildings, or what's the impact of that? And then you can adjust your estimates to match the older building if you can understand that. And then I was also thinking with the kitchen work triangle, like that's something that we assume holds for everybody in every kitchen, right? And I think it does. My kitchen is not like that, and it's awful. But that was based on some people, apparently. I had no idea. That was really interesting. But it's used to apply to the future, too. So then, based on your sensors also, in a future building, you could extrapolate to that. And so a population not existing can also be just in time, like it's in the future. But yeah, I think if you look at what the differences are between the buildings and what you think would impact things, then you can start modeling for that and get some estimate. It'll be more variable, so it might not be as specific or as accurate, but it would give you an idea of what's going on.
Okay, that makes a lot of sense. And then just the one other question was, you talked about how towards your end, which you said is negative, I don't think it was negative, where quantitation or quantization, something like that, quantification was not the only answer. And my concern is sort of the opposite direction, where a lot of times, because of the persuasiveness of data, hard numbers, right, and the specific nature of data, it's often demanded to satisfy bosses and decision makers, even when it may not be the best tool for making the decision. And any thoughts on that? Because it seems like that's going to affect your information gathering and everything else.
Yeah, I would agree that that's really frustrating. And I don't know that I have a great solution. I will say the statistics department led an effort to not rank people based on their teaching evaluation scores at NC State, which everybody was like, what? But you guys are the data people. We're like, but it's bad data, right? And so, yeah, I hope that there's room for both, because you can't, like, in architecture, like, obviously there's a design process, right? And you learn, like, your slides were gorgeous. You learn how to make things work in a way that is also attractive and functional. And that's not what we do in statistics. And so I think that I like to see that argument. And I think if you have data people, they will see the value of that argument, but it is hard to sell that up. Yeah.
Okay.
Great, thank you. Brad, do we have any questions online? Not yet, okay, great. For those of you online, please feel free to instant message and we'll get those represented for you. While we wait for others to, oh, here we go. If you could, again, introduce yourself and please use the microphone.
Hi, I'm Roger Grant with the National Institute of Building Sciences. I was just, this kind of trying to work with data and answer questions is something we're trying to do all the time to help owners. And I'm just wondering about how we, there's always this trade-off between trying to make things structured in advance and trying to learn from what's there in some way, so you don't have to do that to minimize the cost of making things structured. I don't know if you have any thoughts or comments, either of you, on, that there's all this information, how do we get it in a form we can use it? Question?
Yeah, sure. I feel like sometimes just having a kind of back of the envelope type of calculation, that's somewhat data-driven is useful in gauging. I think you talked about something that was really interesting, which was how valuable is this having a data-driven, or understanding this question through data going to be. And so one thing we always have to weigh as a product manager when we're trying to decide if we're going to build some feature in this generative design product is trying to understand, okay, well, we want to understand how the outdoor comfort, that the exterior environment is going to be impacted based on something like the building heights, whatever. In order to do that and to do it really well, what level of accuracy do we need to do it? That's going to take us, it's going to take us 2 to 3 months to build that or something. But then how valuable is that? And how valuable is it to who? And that's when it gets kind of tricky. So I think sometimes what we try and do is first the kind of back of the envelope calculation to just understand how useful something's going to be. Like, I don't think we always need to go all the way. But there are certain aspects that probably are really worth that extra level of information or accuracy. Yeah.
Yeah, I would agree. I think.
I appreciate what both of you are saying, and I think it's something when we think about the entire membership of the AIA is that this doesn't necessarily require that you have an expert in-house, whether the size of your firm doesn't facilitate that or the resources that you have in your community. But I think what you've both said it in different ways, but begin thinking like a statistician, begin thinking like a coder, even at the basic level. If you're a single person firm to the largest firm, you have to perpetuate that thinking throughout the organization to, I think, move some of these big ideas forward and embrace a lot of the technology that's in front of us.
Try and think about it like a crappy word problem, you know, just like in general, how do we turn this into some sort of measurable thing?
Those were always so intimidating in school, I realize. We have a question over here.
Yeah, Z. Smith, SQ Dumas, Ripple, New Orleans. Perhaps more question for Violet, but I'm interested in the Sidewalk Labs initiative where, in some sense, you're trying to build a whole thing all at once, and yet we all know that the most loved, interesting neighborhoods have grown over time with replacement experiments that then got taken down and replaced with other things and so on. And versus the kind of out-of-whole-cloth planned communities that have ended up being a little bit sterile. And so I'm curious how the teams that are working on Sidewalk Labs are anticipating and kind of holding some things back so that things can evolve over time and you can learn from it versus we've solved it all, it's here, it's done.
Totally. Yeah, I think actually one of the things that's really important about what we're doing, sometimes when you see a generative design product, there's, I think that there's a very real and warranted fear that it is a kind of click a button, hit print, the city is there. There's no kind of iteration or evolution. But really, I think with all of these tools, it's much more about iterative feedback. It's about the emergent behavior through the design process. Like actually, I don't know what a plan is going to look like until I draw it, and then I see it and I make adjustments. So in the same way, that's how we think about the product that we're developing. So I might see many master plans automatically generated, but I might adjust those and iterate. I might filter through some of those. I might adjust them and then create more. So I think it is still iterative and it still has that kind of feedback loop, but it encodes various structures that help us maybe have those kind of conversations a little earlier. And I think it allows us to explore kind of more things faster, sooner, so that we can get further. Sorry if that was a bit too abstract, but.
Thank you. There was another question here.
Good morning. Ed Gavreau, Army Corps of Engineers. First of all, Violet, I would love to take your class. Second of all, and this is for both Emily and Violet to come to me, a lot of the talking here is sort of ringing true with some issues we're having right now. We're in the process of trying to develop some new facilities. We sort of want what capability, but of course right now is a case of we may have some data from past ones, but in some cases we're doing something new. It's not, we don't have data. So I just want to take in terms of how would you all approach that particular issue? And I'll let either one of you start on that.
Okay, I have a question. So you have some data on like historical stuff, but you're doing a completely new thing?
There is some historical data on that. In some cases, we will probably adapt one capability that would be transferred to a new capability, but at the same point, it's going to be a different set of protocols. I mean, we're basically, but of course, as you said, we're taking assumptions, but they're not necessarily how it's going to turn out. So So it's a case of, you start looking at, all right, as we generate how the building is going to be used at this point. So, and I guess that's pretty, would that be other assumptions? We would have to really start looking at assumptions very hard and be able to do different generative designs based on other assumptions as you change your assumptions.
Yes. Yeah. So if you're trying to predict into like a new space, you can try to draw parallels to what's existing. And then you can also, a lot of times, like it's a process of trial and error, right? So you do a thing and then you measure it and then you see like, and so if you can figure out a cheap way of doing the thing to measure it before you are like 20 steps deep. So I think I would suggest designing some evaluation points into the process as you go, and maybe casting a wider net for similar features. But I mean, as a statistician, like we can only work with the data that we can get, right? And you can predict in that within limits. And so if it's entirely new, there's nothing, right? And so then you have to start from scratch. And how do you do that in a thoughtful way, which is kind of fun, because then you can think about what data would you want to collect? How would you want to measure? What are your concerns with the new thing? And then how would you measure those to see if those concerns are real for a future project?
And that's exactly what we're starting to work on at this point. And we had a phone call Friday afternoon and saying, oh, well, we need to, and we say, okay, what data do we really need to be able to produce this planning document to start the process at this point? So we're wrestling with that in real time right now. So, but maybe we should get you back into the government and help us out a little bit.
My parents just retired to Raleigh. They would kill me if I moved.
Oh, got it.
That's great. Natasha?
Good morning, all. I'm Natasha Luthra with Jacobs and part of the TAP leadership group as well. In the spirit of the theme of the day, sort of the cynic versus optimism, Emily, I think you did a fantastic job of telling us what, bad data can look like. I guess my question to you, Violet, was do you have any examples of where data led us far, far down the wrong path or astray, I guess?
Yeah, definitely. I mean, I think it happens all the time in designing these systems up front, right? Like you might have an assumption that a design a certain way will behave a certain way, and then you actually develop it and it looks very different. That's, I think, a lot of what the kind of outcomes from the filter bubble that I was talking about, where we assumed something would happen, but then in reality, in aggregate, when all of society starts behaving a certain way, it creates congestion in areas. It changes the way we interact with each other. We couldn't have foreseen that. I think in designing in our assumptions and biases, that always produces many unintended consequences. So I think one thing we really try and do is be very explicit about where assumptions lie. So, even in our tools right now as architects, a daylighting model or a cost model has a set of assumptions. We assume the sun behaves this way, we sample it this often, and it's about that accurate. We assume people move this way. How accurate is that really? Probably not very. There are so many. So I think we have to be really transparent about what assumptions, and I actually think that there's some benefit to being forced to codify and more explicitly say what those assumptions are, because many times we make those same assumptions as designers without codifying them. And I don't know why a decision was made. Why was this building built this way? It could be the rendering looked nice. Someone was loud in a meeting and said, yes, that one. You don't know. But the more we are explicit about how something is measured, what objectives we thought were important and how accurate they were, I think that there's real potential for those to be actually auditable? Like, could we actually allow other people to say, hey, you said that your model was going to behave this way, and you said these were your assumptions, but actually it's wrong because this reason. And the point isn't to like point our fingers at everyone and say, like, you did it wrong. It's to have the kind of collective community effort of improving the metrics by which we hold ourselves to, and that we can be very explicit about what our assumptions are.
Hi, I'm Nicholas Desbians from KPF in New York, and I really love the conversation, Emily, the approach and the focus on populations, and then Violet, your conversation about generative design. And it just occurred to me that I feel like we as designers are in an interesting place, and again, I appreciate the kind of pragmatism, the fact that, Emily, you work with people in all sorts of different fields, but it occurs to me as people engage in generative design, we are in a unique position to, maybe it's not entirely unique, to be actually creating populations. And so looking at the idea of bias, it seems like a kind of doubly compounded, trap we're in, where there's all sorts of biases that could be integrated into this act of creating populations of urban designs and then on top of that, we're then evaluating them and sampling, essentially these populations we're creating. So I wonder if you could speak to that also in light of other disciplines and how they may be dealing with this. Because also when you talked about, very often taking a step back early on and really think about the questions you're trying to answer. The problem we have as designers is the beginning is when we know the least about the problems we're trying to solve. So maybe I would love to hear both of you comment a little bit about how architecture design fits within a kind of a broader spectrum in its approach to data.
Yeah, so I think you're in a really fun place because you are generating your whole population. So like when you iterate across and you have all your different like building shapes or whatever, you've got the whole population, but then you're overwhelmed with data, right? And you don't know like how real it is, and you have to pick, and that is kind of more of a mathematical modeling issue. But I will say, like, I do a lot of work with agriculture and like veterinary medicine, and their populations exist, right? And so the challenges are different, but the idea of being able to collect good data on what's happening, and maybe that's through like looking at what other places are like and the problems that they have and seeing how you can solve them, it's closer to what we see maybe in engineering, because they're again like building a thing. But I don't know, I think it's kind of a cool problem to have, but everybody knows nothing at the beginning of their research project, right? Because if you knew like if your new hybrid corn would grow, you wouldn't have to try it. And so you have to just sort of see what happens, like do a couple things and try to minimize the cost or the impact, like put up some designs and see how bad are they, right?
Yeah, I think,
and where do you go from there and build that in to the process?
I think that question of like we're creating our whole population, I think that's the tricky one, because very often what we're doing is pruning the tree very, very, very quickly early on, because we're able to then create a population quickly. So a lot of times in these generative design studies, you see a lot of stacked shoeboxes because computationally that's an easy thing to do. But you've already trimmed the tree of design possibilities so close to the trunk that you may be actually pulling back what's possible, even from the later metrics that you could apply to the problem.
Yeah, we do deal with that kind of in any study design at the beginning. If you get too locked in too quickly, and we do a lot of simulation studies to try to figure out like how often will my test detect this difference if this is the difference, where you generate the population, you sample from it, you test it, and if you constrain your parameters too much, it's predestined almost, right? And so it's hard to know how wide to be, and maybe you can talk about that, because actually design things. But I think that's something that we talk about a lot when we're meeting with people is like, what is the range of possibilities that you could see, like the full range, not just, so you want to, you don't want to get stuck at like a local maxima, right? Like you want to be able to take a step down and then find the global maxima, which is sort of a tortured analogy sometimes, but that's important to allow to not focus in too quickly. And if you're generating it in the computer, I mean, that's cheap comparatively to building it, right? And so then you do have more flexibility to try to have a wider set of parameters.
Yeah, we always struggle with this same problem. Like the stacked boxes is such a good example. I think we have to find ways to produce more variety and actually allow more iterations. So when you create new iterations, it needs to be actually designing completely new building scenarios or typologies. You know, we always put this, the Larry Page question on our product. So like, what would his response be to something? And he'll ask questions like, well, if you always assume that buildings have to have an elevator, you're always going to design solutions that solve for buildings with elevators. We're not going to have moving walkways. What happens if we take the streets out completely and they're scooters and pedestrian only? Like, so I think simulations can help us actually investigate those more provocative ideas, but how do we make the inputs of exploration much easier so we can actually test those? Because every time, I mean, I think Revit and BIM and CAD even codified a certain way of working. You know, we have very orthogonal rectilinear buildings. We're not building in Adobe, you know, kind of this shape, whatever that is. And so the tools always end up encoding those things, but how do we, I think we have to find ways to build tools that allow for more varied exploration, more ambiguous, like I want to be able to put into my design, what happens if we take elevators out? What happens if they are this shape?
So
Just gonna keep doing that.
one of the ideas that we use in statistics when we're trying to follow an algorithm and have it converge is you start multiple chains. So you start multiple optimizations at very different, you like at the highest and the lowest and then a few in the middle and sort of spread out, and you try to break it. And if all of your chains end up converging, then it's good. That's how you know they're mixed or whatever. And so I think it's a really similar idea. Like you push the boundaries at that beginning stage, and then you see if it all comes together to the same thing. Statistically, that's a good bet. But if things start getting hung up on the edges, then there's something you need to look at more closely.
I think we have time for about one more question. There was a gentleman right behind. Yes, you.
Thank you. Gordon White, HDR. I had a question about the samples you're pulling from population, because we talked a lot about the bias that you can have, everything from, you know, smart devices only measuring certain things to even the ubiquitous phone call having the problem with now elderly in rural areas being the primary people who respond to that. And so my question was, do you have an example of a good way of getting a sample size, either from the general population, or is there like a specific, unique event that happened with you where you thought the sample size was chosen in a unique manner?
So that's a really hard question. Yeah, I mean, it's always easier to like pick things apart, right? But if you, if you pick, so what I have had some success working with people on is when we're designing their sample, and if you're going to do a survey or you're going to try a new medical technique or you want to grow a new crop in some different farms or whatever, and you, in a way, you have to use what you have available, right? But if you can randomly select from what you have available, that's sort of the best option. If, when I tell you to randomly select, you don't want to because of a reason, that reason is something that you need to look into, right? So if you're like, oh, like I can't randomly select just smartphones because I don't know why that would be a problem. Like people turn them off when they're here or whatever. Or I had somebody who didn't randomize because they were worried, like they wanted to be sure they got measurements close to the water and then measurements like far away from the water. And I was like, yeah, we can control for that, right? Like you have to tell me. So anytime that, like if you're trying to design a sample and it's making your stomach hurt, then you need to like take that information into account. So don't ignore that. I guess that would be when things are successful, it's when like that gut check, you're like, oh no, wait, something, I'm like nervous about this randomization and I'm hoping for a good randomization. Then the design is bad and you need to stop and rethink how you're sampling. Does that help? Okay.
All right, we have a 10 o'clock stop, so I think we could take maybe one more question, and then I might have some closing thoughts for you. So the gentleman here in the front.
Hi, how are you? Gustavo Rodriguez from FX Collaborative. Both of you talked a lot about data and how data is growing. And I guess the question from the design point of view and for the practice point of view is how do you see firms evolving to be able to handle all this data? Do we need to hire statisticians? Do we need to hire data analysts? Or is there a product out there that can help us as architects deal with all this data? And from the design point of view, what does the design team of the future look like? How does Design Lab, what is the design team of Design Lab? Does it have designers, architects, and statisticians? And I guess if both of you can just help us with a bit of that.
Yeah, I think if you even look around the amount of computational design programs that are emerging, computational design has been, it's already happening within architecture schools and within firms and engineering companies. It's very much already a thing, but we're just learning how to employ it in a design process. So I think that the future architecture firms, engineering practices like today will have computational designers within their firms, but on project teams. Like you will have your computational designer will not be on a team to make the sweet diagrams that sell the client. They will also be the ones that help vet the project, that can test things very early on. And I think they'll be the ones, I think, hopefully working more with statisticians. I do think we need more data-driven. I think architects always have a bit of a, what I've been told is a physics envy, which is, you're always trying to math up or science up where you don't know. And I think it's okay that, we're learning to program and we're doing computational things, but we don't have to be, I'm not going to get, I can't be expected to have a statistics and mathematics degree on top of all the other things. We should work with statisticians and data analysts, and I think, larger firms can afford, hopefully, to have those kind of people on staff. And I also think that there's a lot of emerging products out there that can help us. I know a range of various companies have their own proprietary software. Of course, we're developing one. Reach out, please. We're very happy to talk to you. And so I think the future will look much more like a multidisciplinary team using more of these types of products and tools, and maybe even developing those tools.
You should definitely hire statisticians. No, so it was funny when you said like physics up. So I have a coworker who always complains about how people think that physics is really hard because he's like, everything is known. Like, how hard can it be? Like, it's all known and accurate. And I always sort of treasure that because physics it's really hard, right? But yeah, I think working together, I think one of the things that's sort of profoundly unfair in this data-driven age is that people are expected to be able to do their own statistics, and it's its own field, and we have tons of classes. We're a very coursework-intensive doctoral program because there's so much, and it doesn't even cover nearly everything. And so I think it's nice to be able to work together, and especially if it's like a cool problem and it can have some research with it, then that's always something that gets people really excited to work interdisciplinarily.
All right, we do have one question online. I would like to give them an opportunity to voice their question. So Brad?
Great, thank you. So this question comes from Robert. He asks, in Sidewalk Labs, there is pushback on the data collection due to privacy concerns. Violet, do you see this example as symbiotic or symbolic of data collection problems to come?
Yeah, actually, I think in many ways that's one of the aspects architects and designers have to deal with. And we're entering a much different conversation than we were 10 years ago when we said, oh, this is what a building will do when it's built. We didn't really have that same level of accountability where we had, we have certain building codes or thresholds we have to pass to say we're abiding by certain standards. But I think now more than ever, understanding what data you're using to understand the predictions you're making about a building or place have a lot more weight. I think in terms of just the questions of data governance and data privacy, Sidewalk Labs has in many ways gotten out in front of this because this particular moment in time. And I think it's really important that designers and architects really lean into the responsibility of building simulations and understanding all of these biases that we encode and being very explicit about what assumptions we're making, because we will impact people so profoundly when we build those simulations and a district gets built. So I think it's very front and center about what we have to think about on the team, even if a lot of those simulations that we're talking about have to do with environmental models or fire exit routing. Those should abide by the same kind of data standards.
All right, great, thank you. So in closing, to make sure we're all keeping up with our homework here, maybe you could each close with a comment from your bingo card there. The idea of keep, toss, create, or reimagine. Did each of you have one of those you'd like to share?
I wrote down the hacky first ideas because I think that's such a great, a lot of times you spend so much time trying to get to an elegant solution, but cobbling together a new thing is how you get to new cool places.
So that's a keep?
That's a keep.
Okay, Violet?
On keep, let's see. I wrote down a little too much in bad handwriting. I think one of the things that really stuck out to me was figuring out the right question is so important. The type 3 error is the error we're always trying to grapple with. What is the actual right question we're trying to answer, and actually having that at the get-go is really important.
Great, thank you. All right, so that wraps up session 1. We do have a short break. We have some refreshments in the hallway there. We will be back here at 10:30. So Emily, Violet, thank you very much. All right, welcome back. Thank you for joining us again. So the second set of presentations that we'll be speaking to today is the topic of augmentation. And speaking on those two subject, or on that subject, excuse me, are two presenters, Matt Goldsberry from HDR and Nicholas Cameron from Perkins and Will. To start us off, Matt will be speaking to, and I think he's in a competition here to win the longest title for presentations, use of data to derive generation of healthcare lab planning options to augment the design team. He is responsible for research and implementation of computational design at HDR and has contributed to some publications in both Architecture Magazine and Healthcare. So please join me in welcoming Matt Goldsberry.
Thanks for having me here. It's great to be here. I'm not sure. I don't know where that. I'm not sure if that title reflects my presentation. But I do remember in one of the original descriptions of the augmentation section was this word optioneering. I'm a little uncomfortable with that word, but maybe that's just because it's two words combined into one. But I kind of want to look at this kind of this history of optioneering. So when I think of optioneering and this kind of iterative design process, I have two things in my mind. I have the project, The Embryological House by Greg Lynn. And to me, it represents one of the first projects that kind of has this, I don't know, I guess that we all think of like this one button, generate 50,000 options. And, that project came out of, recent developments in animation software, which were recent developments in, rendering algorithms. And that's really before, that project represents, a body of work really, which sort of becomes some of the parametric projects. But that was before any of, the Rhino, the Grasshopper, the Dynamo, all that stuff. So I guess there's kind of two things that I have in my mind. There's this project, and then the evolutionary solver genetic algorithm project. And to me, I feel like the project that comes up the most when talking about this is the partition project. So I guess I'm not taking sides from one project to the other. I guess other than the evolutionary solver being a very discrete set of problems to solve, which is why the partition project made sense as one of the first I guess most popular projects, because it's really tough to solve or to have a problem where you have a set of variables that contradict and then that solve that particular problem. So in engineering and in the partition project, it's a perfect project because you're solving for weight and you're solving for density of material. So the evolution of getting to that project goes back to, I guess you could go all the way back to CATIA in the 70s, being developed for engineering problems, which then led to AutoCAD in the 80s, and then eventually we kind of get to the split here at the top. I don't know if I have an arrow. At the top where we have the BIM in 2000, and then Patrick Schumacher's parametricism. And I guess I'd only say that those are two sort of contradictory things, but I think they also lead to, this, that similar zeitgeist at the time, which was there's this plethora of tools of Grasshopper, Galapagos, Dynamo, which kind of led to, access to the architecture community to do these sort of generative problems, where else, without these visual scripting interfaces, without people developing these plugins, more than likely, generative design probably I guess it wouldn't necessarily be part of the conversation, but it wouldn't be as widely accessible to everyone. So I'm going to go through some more projects, but I kind of want to come back to this idea of this split between the, these sort of like 50,000 options of the animation software and the evolutionary solver problem. So I think a better word than optioneering is data platforms. And I think that's how I think of the work that we're doing in HDR. So I'm part of a team that we call D3, and we have people like myself, architecture, computation background. We have data scientists, data engineers. We also have people that specialize in machine learning and deep learning and operations. So I just want to pull out a couple projects that talk about kind of assembling these different data platforms. First being this PennFirst PennMed Tower in Philadelphia. So I think people can probably relate to this problem, which is you have a huge team, and you have everyone's in their different corner. You have planners, you have the design team, you have the contractors, all kinds of specialists. And early on in the project, it's really hard to make decisions on the project because ultimately it's going to be over budget or you don't have enough rooms or departments or whatever. But the goal to me in these types of projects is you want all these specialists to stand around a screen or just be in a room and point at a model and be able to change the model and get feedback. So you look at the model and you say, we're over budget. Okay, let's take the top floor off, or let's take the parking garage off. And you need data in that model to get that feedback instantly. So for us, this process led to, this is our version of the 50,000 options. So we could go through hundreds of options in a day quickly, and we don't worry about keeping track of them. You just iterate, and everyone has a crazy different idea. So you might say, let's make the facade cheaper. And then you do that and you realize, oh, that cut out 1 million and we're trying to cut out 50 million. So, we're not even at the right scale. So to me, this, what this is getting at is we're trying to create the system that's between, just designing the model, but getting that feedback of information. So, we can just drill down into any aspect of the project very quickly from a blocking and massing standpoint and get all this immediate feedback on the model. So this is as a result of that PennMed project, we developed this model or this plugin called Data Wrangler with Proving Ground, and this has kind of been an ongoing project for us in the last 5 years since that first project with PennMed. We've developed a number of plugins in-house that kind of, I think, participate in this idea between the two, where we're trying to create a set of tools that allow planners, allow designers to quickly iterate and get this feedback of information. So a second project, a little bit different. This is more a project, like I said, our team makes up of designers and data scientists. So this is a project where we teamed up with our data scientists for a project. So there was a massive data collection on this. So keycard access data, student schedule, all kinds of data. And it's a huge amount of data. And ultimately what we were able to create as a result of all that data is travel paths. But I guess that would be the simple part. The complex part would be the fact that we can do cluster analysis. We can do all kinds of analysis on this to just drill down into this information in a lot of different ways. So on one hand, you're getting a travel path, but you're getting, it's kind of like, I don't know, I guess extreme version of it, because every time you plug in a new building, you can run all these different analysis. So I guess the other component of, when you're generating these 50,000 options is how you're able to drill down into that. So I guess that's where our machine learning expert comes into, and using machine learning for cluster analysis. So this work, I think, I guess I call these sort of these mega dashboards. I think I hit play on this one. That's all right. But this, we create these mega dashboards where, you have this huge amount of data on the back end, but, as a result of this dashboard, you can, generate these options in the dashboard. So I guess that reflects like, another category of work, which is all the work that we do with our data scientists. There's another huge amount of work we do with these like large scale campus projects and master planning projects. And if anyone's kind of worked on like this scale, where it's even, clients want you to work at like a room level, but yet they have, 20,000 rooms. It's really difficult to, just figure out what, all the nuances of the project, but at the same time offer like strategies. So in this case, we had people like we had an economist, we have master planners, we have people that are running all the financial models, and this model here basically allowed us to run these scenarios where, as we were running the phasing options, we were being able to generate tax revenue and start to, show, you need to build this out first in order to have enough money, or, all these different scenarios. So, like I said, we do a lot of master planning. This is one where we're using an evolutionary solver for placement of the spaces, so less so the generation of the, design or size of the building, but just placing, so you can imagine in a large campus, when people have classrooms everywhere, it's sort of a puzzle to figure out how everyone's going to fit. So you might have a couple extra rooms based on a schedule, and ultimately you want to figure out, maybe a more optimized way of placing that. So in this case, that's how we were using this evolutionary solver to kind of place rooms. This is ongoing work. This is, I guess, just really difficult to do and use as a tool. But it's, I guess, as in the idea of this data platform, it's one component of many in this master planning process. So one of the things I want to get at, kind of looking at that work, I know it's I don't know, I guess a lot of different examples of work with a lot of different people involved. But I guess one of the other two things I have in my mind too is that like where this work is going and like what's at stake with this optioneering. Because historically we've gotten able to increase speed and complexity as a result of these tools, even going back to Greg Lynn's embryological house. But going forward, that's a huge like span of time. I mean, that's going back to utilizing technology from like the 80s and then getting to that house in 2001. But I think what's at stake going forward is a lot higher because we have a lot higher access to convolutional nets, AI algorithms, and these two are, I think, probably my favorite example to think about in combination. One is, I don't know if you guys have seen what DeepMind has done with their deep reinforcement learning, but this is just the idea that, so there's two types of learning, one which is supervised and one that's unsupervised. And in the last couple of years, we've gotten a lot more sophisticated with the unsupervised learning. So this idea that we could beat video games without having to provide it, having to like tag it and figure out why. So it's just learning on its own. So first it might like jump around randomly, and it's going to learn, based on its point score, if it's getting better or not. So this is a very different idea than if you think about when Deep Blue beat Gary Kasparov in chess back in, I think, was that the 80s? I don't know, maybe someone can correct me, but that was a very like, finite number of solutions, and the computer had enough capacity to beat it. So this, I think people are probably familiar too with maybe the AlphaGo DeepMind algorithm when DeepMind beat AlphaGo, And what's interesting in that scenario is just that made AlphaGo, better as a game than it ever was previously, because it produced strategies that no human has ever thought of. So if I think about the context of recent research papers and recent algorithms that are being developed in artificial intelligence, and then some of the things that are going on currently in architecture, this is Blockhood by Jose Sanchez, and he's a architect and game developer. But I think about Blockhood as a methodology for how we might be designing buildings in the future, and so I like to think about how these might operate together. Where if you use this AI algorithm to play Blockhood, creating building solutions that we might not have ever thought about as I guess as humans, but then how that might influence our thinking going forward. And lastly, I'll just finish on this one, which is just thinking about, right now, I guess, in the first slide when I was or the second slide when I was talking about the evolutionary solver project, a lot of that stemmed from, AutoCAD, Revit, Rhino, Grasshopper. But I think going forward, there's going to be a lot more tools and software coming online, and less so at like a huge platform level, and more so at a smaller scale. Like, this is Monolith using voxels. So thinking about these like smaller tools and how that's going to influence architecture. So, I think it's completely unknown. I mean, a lot of this stuff is been happening in the last 5 years. So I think the trajectory for what this is going to produce aesthetically is still up in the air. So that's it. Thanks.
Thank you, Matt.
Thanks.
Well done. All right. One of the things that's quickly becoming apparent to me as I listen to Matt and follow up on the two previous presentations, this idea of a multidisciplinary firm is becoming much broader for me. I think anymore it's not so much about defining yourself as multidisciplinary to have architects, interior designers, engineers, landscape architects. I think this is having to expand some of the expertise that you talked about, and Emily mentioned as well, data scientists, computer scientists, statisticians, economists, anthropologists are probably things that all need to make their way into our profession and our firms, or at least, to quote Violet and Emily again, to the idea of at least thinking like those types of people. So our next presenter is Nicholas Cameron. He is the associate principal of Perkins & Will, and his work is really focused. What struck me about his work and his biography there was that he talks about how digital practice is not only affecting the design process, but it's impacting the business process and how they conduct business there. Nick has also had some of his thoughts about the future of technology shared with Architect Magazine. So next he's going to talk to us about, do we really need those 1,000 options, as the little bit of a contrarian view. So please welcome Nicholas Cameron.
All right, let me see here. Is this on? Okay, so I'm Nick Cameron. Thank you for that introduction. I'm a dad. I'm an architect. I lead the digital practice at Perkins & Will, and I kind of like cars. And believe it or not, I'm going to talk a little bit about all of those things today. So Perkins & Will, we're a firm of about 2,600 folks. We have multiple offices around the globe. And the reason I bring this up and why it's important is we can test ideas pretty quick, but I like to think that we can test bigger ideas with you folks even faster. The first thing I'll talk a little bit about is digital practice at Perkins & Will. I think that it's really interesting for us in that as designers, we work between the analog and the digital. The quickest way we can get ideas is onto paper, and then we quickly pull those into the machine, and we run simulations and analyze those things. And then we start to create physical models at scale, and I think those scales are going to change over time because of the types of machines that we're able to use and produce our work now. But really, at the end of the day, what as an architect has always got me excited, why I went to school, why I got licensed and all that other good stuff, is that what we do is really important. You know, we build places where our children learn, where our families heal, and where communities grow. And it's all based in gravity, and it's kind of a big deal. You know, something that gets me out of bed all the time. All this doesn't happen on its own. We have an amazing team at Perkins & Will. There's no one person or group that knows everything about what's happening in design technology. It really does take a village of people focused on marketing and legal issues and coding and visualization, and you kind of name it. And we're spread out and make this human network that I think really propels how we're changing the built environment. And I'd like to think that this network extends out to the people in this room and really other groups like this in our industry and beyond. So it's a little bit about Perkins & Will and how we work and how we like to think about things. Next, I'm going to talk about being a dad and why this became an important thing, or how I got into this thinking of why we don't need 1,000 options. So I was lucky enough this summer to take a little bit, I'd call it a mini sabbatical, and combine a few of my favorite things, which is travel, looking at architecture, spending time with friends and family that I hadn't seen, and show our kids kind of some sites that they hadn't gotten to see yet. And in doing so, I was able to unplug and really take stock on, I think, you know, where I thought we were heading in 2020 and beyond in this decade. And something I heard over the weekend that was maybe a little sad was that if Marty McFly got in his time machine today, he would go to 1980. Is that right? So when Matt's talking about, you know, this technology, that doesn't seem that far away. If you look at the reverse side of that, 2050 is just as close as 1990 at this point, I think. So on this trip, I got to unplug, got to think, got to stand back and look at, you know, how a lot of this amazing architecture is built and really, you know, how we're working back and forth. And in one of the kind of discussions I had with someone I hadn't seen in a really long time, we started talking about some cars. And I don't know if anyone's ever had this experience of being able to drive a Ferrari. Yes, thank you, Ryan. Around a racetrack, it is amazing. Your adrenaline is going, you're driving something that you really can't afford. You can't figure out why they're letting you do this. But it's just you and the machine, and it's really, really fun. And I guess, in a sense, we're kind of good at it. There's so many things happening, and we're able to control these things. And in talking about cars, how can we not talk about Tesla and autopilot? Which again is pretty amazing at this time that a car is semi-autonomous and can do some mundane things like taking care of your commute. So you can spend some time thinking about or listening to podcasts or kind of just staring out the window. Seems all pretty safe at this point. But there's these two forces here. One is the Ferrari. Don't ever automate that. The commute, automate it all the time. We don't want to be doing that. We have better things to do. And it was at this point where I started thinking about the tools that are out there, and maybe not even so much the tools, but the marketing, right? We can have 1,000 options. We can have 10,000 options. We can design these spaces based off of rough programs and have, you know, maybe 4 ways of measuring that. But I think as designers, we're way better at that front-end work. I think that when I was working as a designer in the first half of my career, I never woke up in the morning and said to myself, oh, you know what I have to do today? This is horrible. I have to do massing options. I would do that tomorrow if someone told me to. And it's just such a great exercise in a way to think through and synthesize what you're learning from your client, what you're hearing from your client, what your team knows about zoning code, about air rights, all these things that are happening that we've tried to program into scripts to generate space or urban design plans. There's always one more parameter that the designer needs. It's never, this was it. It's always, yeah, but we need to do something else. But it's not like this can't be fun. We're using kind of advanced tools. A little shout out to our robotic arm here, Armando, about how we can process massing studies, which is always kind of fun. When I was designing buildings, I would wake up in the morning and say, you know what I got to do today? This is the worst. I got to annotate 20 sheets or use this tool to dimension things. Why? Remember, Ferrari, commuting. And the thing is that we're going to be producing sets of documents for a pretty long time, I'm pretty sure, at least this next decade. And those documents, to produce those documents, construction documents, is about 40% of our fee. And we produce them on every one of our jobs. Why are we not focused on this and automating this process? Because we can make the argument that we should have design or models as a deliverable. But I would say that we can actually do more within the fee structure we have, and that we need to start automating that process so we can build better models and in a sense, build better buildings for our communities and the people that are out there that we work for. So, again, what does this have to do with Ferraris? I don't think that we can create an autonomous vehicle just this year. I think we have to start a little bit smaller and maybe focus on things that are even more mundane, like parking, which if you watch this video, it's in real time. I'm pretty sure I would take over for this thing. But it's cool, it's getting there. Has to be safe. But I feel like in this year, as we move forward at Perkins and Will, we will be focused on automating documentation because it's going to save us a ton more time and help us produce better buildings. And we'll do that internally, working on apps and scripts. And we'll do it with our partners who are out there that everyone should be supporting. Testfit.io is an amazing tool that I think everyone would have access to. And I think this is a way of being able to, as Violet said, draw and iterate. You're in control. Proving Ground, Nate Miller, Conveyor, this amazing tool to connect Rhino and Revit. This is where we're designing things, and then we need to be able to document them. Amazing tool, shout out to Nate. Hypar, we plan to partner with Hypar this year. We've had some great discussions and workshops in the past about how do we generate toilet rooms. Every project has toilet rooms. There's no reason we shouldn't have a tool that just documents those. And then some other small startup, AI Prentice, that you may not have heard of. It's very interesting. And what they're looking to do right now is automate dimensioning, which is a huge time saver. Can you do it 100%? Probably not. And everyone has a little bit various ways of doing it. I think you can get it 80% there. Maybe that's where you get 3 options. You pick one, you're 80% there, you're good to go. And then finally, as I began, this is about building stuff. This is a project that we just recently completed. It's the world's largest Starbucks in Chicago with wrapping escalator. It's all very cool. But what's really cool is that model on the left, which was the panelization of the interior, where we worked with the fabricator to produce those panels. And what I didn't have time to put into this presentation was the drawings that had to go with that model to produce the work and get the pricing done. So like I said, you're going to have a model that you're delivering. You're still going to have sheets. You're still going to have some documentation that needs produced. Thanks.
Thank you, Nick. Well done. If you two gentlemen could join us up here for some Q&A. A little bit on my thoughts. You know, Nicholas, thinking back on what you've just shared there, a couple of things resonated with me. Not only do we need to become multidisciplinary to include things beyond the traditional disciplines and into things that are non-traditional, but leveraging the computer and automation in a way that augments us as professionals. And one of the things that inspired my kind of journey into technology was a coffee table book by Frank Gehry, and his perspective was that the computer was really leveraged most when it was trying to capture the curve, but actually defining what that curve looked like was a very analog, very human process. And I appreciate how some of your ideas have reflected that as well. So thank you for sharing that. So from here, again, the more interactive part of the presentation, we'll go ahead and open up with questions. I believe, Charles, is that your name there? Yes, please.
Hi, Charlie Portelli, Thornton Tomasetti. I had a question, a slight comment, slight question. So you talked about the topic of automation, and I want to bring up the phrase of augmentation. And then to kind of couple onto one of the comments that Matt mentioned, when Kasparov lost to Deep Blue, everyone thought it was devastating and, you know, robots are going to rule the world and so on. But what happened shortly after that was that Kasparov played with Deep Blue as a teammate, and then his insight, one of his comments was that his insight towards chess, even though this was a chess master, were enlightened because he was able to play, you know, with someone or something of kind of like an equalish knowledge. So this concept of automation versus augmentation, and kind of where do you see that kind of happening in our industry, near term or far term?
What do you think, Nick?
I think that was addressed to you.
Yeah, I mean, I think I'm trying to think of, you know, when Gary lost that that match, it was actually at a point where he could. It wasn't a losing battle. Like, he could have won, but because of human error, like, he knew he made certain errors when he lost, which is why, like, he was so mad at playing. But then you know, like you mentioned, ultimately teaming up with them made it better. And that's also what I think with, like, the AlphaGo example too, is like, that's a huge team that's playing that. It's not just the machine itself. So I mean, I feel like that's completely where I'm at, is with the augmentation, which is the split between. And I think the marketing tells us we should be at automation, but the reality is it is augmentation. Even at some of these other, you know, massive scale automation projects like the AlphaGo, and like that they are augmentation. They're not automation problem. I do think when I was watching Nick's presentation, I do see this, like, point of, I don't know, I guess maybe the point that we perhaps agree on is that when you are, like, sitting down at, like, a blank piece of paper, like, I would still think that there's not a way to just, there's not a place for just hitting a button and then getting the options, which again I think is what maybe what have been sold that could happen. I guess the augmentation would be that like beyond that initial concept, which might be, day one, you're going to need a whole set of tools to like push that design further and test those options.
Yeah, I think as we discuss this presentation and reflect on the last 5 years of how does that actually work, and as Violet was talking about earlier, the iterative process and how can you play back and forth and have the augmentation and capture those results and continuously make it better. I think the tough part though is chess and AlphaGo have a definite set of rules, and the machine can just keep playing it over and over and over and over again, just like the Super Mario example that you showed. Whereas I've had client meetings, and the client might say that they, really love the color blue, but when we present something that's blue, for whatever reason, they don't like it. And it's about reading them, right? Reading their facial expression, their body language, and putting that inside and changing the next scheme. And I don't know how we would put that into an algorithm just yet.
Anthony Hauk, Hypar. Thanks for the shout out, Nick. Really impressive work from both firms. Speaking of augmentation, I'm wondering how much are these tools that you guys are showing are kind of general distribution to designers, and how much are the designers being augmented by a team of specialists who are making these things happen for them? I'm just curious on how easy you guys have found it to soak this approach, which is, as I say, very impressive, into practice.
Yeah, to me, what I find is that, historically, we've wanted to have, a set of tools and process to say, this is what we do on every project. I mean, for as long as I've been working, that's always been a topic of discussion. And I think it probably came out of like, I blame like AutoCAD for this, because it was like, we did hand drafting and then we had AutoCAD or MicroStation. And it was like that became the process, and in a lot of ways that automated a lot of stuff. And I think what's tough now is that we perceive that, so say we have Rhino or we have Revit now, and that we're going to implement, these scripts in Dynamo or Grasshopper, and that's now like the process that we can then, if that's the magic formula, we can do that on every single project. But I think it's so much more complex than that, because every project has a completely different set of problems and constraints, and it's almost like every project has to be you have to rethink the whole process and what tools are being involved. And it kind of reminds me of the way like the entertainment industry works when they do like special effects films. It's like they're not saving scripts. It's like every single thing is completely custom on every single project. So sorry, I was reading a note. Lost my space, but oh yeah, I guess speak louder. Thought it was on. No, my mic's out. But so yeah, I mean, I guess I think of it as it's the stakes are higher, and it's so much harder to create the magic set of tools and processes for this. And there's no, I've never worked on a single project where I can say, let's use those same tools and custom tools on this next project, because we're going to use the standard ones that we buy. We're going to use the scripts that we have, and then we're also going to build stuff on top of it to make it work too.
I think we're still in the space where we do need that specialist. And what we try to do is have that person mentor someone else on the team. So I think from 5 or 10 years ago to today, every student coming into the firm has had some experience or some scripting class and may understand the basics, and hopefully, we find the next set of experts that can be inside of a project. And as the tools do get better and easier to use and more customizable, we see that kind of taking off and becoming part of the standard process. But there's no one-size-fits-all. It needs to have various ways to adapt to the client's needs, the site, et cetera, program.
Quick question. Ryan Cameron, DLR Group. Hey, guys. So we're all really dying to know, Nick, what was your track time in the Ferrari, right? No. So quick question. It kind of plays off what Anthony was saying. You've got all these people making design decisions, algorithms for you. I asked this question at AU, I think it was 2 years ago. But is there a potential risk, and this is really for everybody in the room, but I want to get your guys' take. Is there a potential risk for a problem or an error in the programming that creates social inequality, an increase in homelessness, a reduction of multi-generational housing due to an error in programming? And how do we combat that as design professionals?
I feel like I'm going to switch to this mic here because my other one isn't working. But I feel like this question is maybe asked too much because, I don't know, I guess it seems like too far in the future to me, because I don't think any of us are arguing that we would create a system and then we would hit a button. I mean, again, this goes back to my, I feel like this is the hype, is that, we're going to create a system and we're going to hit a button and there's going to be bias in it and we're going to be completely unaware. We're going to be completely unaware of it until it's actually built. But I think in reality is I think the actual, the use of the genetic algorithm is a very small component of the overall design process. So like I was mentioning with the partition project, that worked out really well because we're trying to solve for, cost and weight. But any architecture problem, there's thousands of contradicting variables, and you can never put all that into a system and hit a button and say, this is the best one because it ranks the highest. It just wouldn't be possible.
That's great. Thanks for the feedback. Those mics are much better, especially for the people over there in the hallway. So if you could make use of those, that'd be helpful. This gentleman here has a question.
I have a question for Nick. So drawings are things that are really meant for human consumption. The machines would be just as happy dealing with models directly and not dealing with drawings. They're not very good at drawings, really. Mm-hmm. So we could say that a drawing is a social contract. In some respects, we have to agree on what the drawing means and what the graphic standards, to coin a term, mean for that drawing. And so as you move into rule-based creation of drawings, which is what you were sort of showing up on your presentation, how are you writing those standards for the social contract, for what constitutes a good drawing?
I think the one thing I think about, and this might be me reading into the hype, but when we have conversations with a lot of smart people and you look at how do you generate buildings, it is, do you have enough data? Do you have data models to back this up? And one of my thoughts is that we have 100 years worth of drawings to teach a computer how to dimension something. And there may be variances on that from the East Coast to the West Coast or how you might do it in China, but it's all pretty close. A section mark, a tick mark are very similar. And then there's, I think, rules that we can teach a computer to say, you should not have a bust. You don't dimension all the way across a room. You want to leave something open for this reason or that. And I think that that's something that we can begin to program or teach the machines to do. And like I said, I think that when I talk to project architects, they all do it a little bit differently. So I think maybe that's where the options come in. There's 3 options. So if you've used PowerPoint recently, it gives you various options. And select one and then finish the task. So it gets you to 80%. And then the 20% of completing that task is also checking, to Matt's point. As professionals, we need to check that work before we send it out the door.
Oh, we have a question here in the back.
Can everyone hear me? Yep, great. Christopher Connick from Karen Timberlake. I'm going to ask the same question, maybe for a third time, in terms of automation. So Nick, I think you mentioned that time was one benefit, right? Expedited completion of tasks. But do you see any other benefits, like quality, perhaps? And then, so this is where the kind of same question comes in. How do you ensure the quality of automated tasks? What kind of processes do you have in place as a practice, as a group, as a mini group within a practice to actually do that? Software developers, maybe it's like a difference between software programming and engineering. Software engineers, maybe like at Sidewalk Labs, might write tests, so code that actually tests their code, right? Is that something you're doing? Is it purely a kind of eyes on the drawing, as you mentioned? So basically, how are you wrangling QA/QC for automated tasks? And especially considering that as you go down later phase, that's where a lot of the liability incurs, right? When you start to hit code compliance, et cetera. There's things that might be kind of unwieldy or take a long time. Actually, there's a reason why we get paid for those tasks too. Mm-hmm. So basically, how are you encoding that wisdom? How are you interacting with other people in your firm to kind of test scripts that you write that you may not be an expert about the content that you're actually writing the script, if that makes sense?
So I think that the goal will be, yes, we have more time. We can check the work and be perhaps more thorough. I think also a lot of stuff just happens in a black box, and we finish projects not because they're done, but because the deadline's there. So we may be able to also harness, I think this is another benefit, percent complete. How far along are we based against some other rules or similar projects that we've been able to compare to? And that will help the teams understand what the effort is, or if the design is moving forward. We don't have any in it, and I haven't thought about it too much. I'm just right now thinking how we would check that. I think one way is if the software is smart enough to show us what has changed, what has moved. So if on a Monday I check some things and kind of give it the go, the kind of go ahead, by Friday, if nothing's changed, I know it's still good, which today doesn't really happen. I guess we can do like sheet compares and things like that, but it's not running us some type of report to show us what's actually changed. Not that we use anyway. So I think that's maybe something that we would want to be doing in the future.
Quick follow-up would be, and maybe even for Matt, to an early stage when you're doing takeoffs and you're writing scripts that are doing takeoffs. And okay, I'll put my hand up. I've done it. I've written code that has given incorrect results. So have you ever run into that problem where you write a script that doesn't give you the result that you're anticipating? It might even be wrong. And what kind of procedures do you have in place as a team, as a firm, to kind of course correct and learn from those mistakes?
Yeah, that part is kind of scary. That I've seen major errors that use something for years, and then you look back and there's an error in there. I think that's one thing our data scientists are really good at, is constantly reviewing the data. But yeah, I guess that's where the rigor is, because it's not like writing these automation scripts is like a fast thing. Automating the document process is extremely difficult. It's one thing. There's a lot less variables involved earlier on when you're programming and planning, and the stakes are a lot lower because you can be off and you still have time to correct it. Mm-hmm. But when you're doing those types of scripts on the construction document phase, the stakes are a lot higher in terms of money loss and possible errors. So I don't know if I have an answer other than you got to have really smart people.
Yeah, I think it has to be more than one smart person, so there's a check and balance. And also, if you think about the larger team, so if you're working with a CM or a contractor, that you can work back and forth and check your numbers, because it might be two separate processes that are happening. But I don't think that's something new. A friend of mine built a parking garage in Baltimore probably 30 years ago, and the match line with the XREF was off, so they skipped a floor. So, you know, just one less floor of parking.
Good insight, thank you. So our next question is from someone online. Brad?
Yep. We've got 2 questions from our folks participating online. The first question is from Paul. To Nick, what tools like VisiSpecs by Chalkline are being used to integrate specifications or the project manual within AutoCAD, BIM, Revit, etc.?
Sounds more like a test question.
Yeah, I know that we use VisiSpec somewhere in Perkins & Will because I see the bill, but I honestly don't know much more about it than that.
All right, we can go to the next online question, and that's from Jonathan. Jonathan Meadows from Durham, North Carolina. The presenters have shown portions of the architectural practice which are quantifiable and good for computers to handle. Site planning, cost estimation, square footages, and adjacencies. What do you see as the next steps in automation? Are there items which computers are not currently good at testing, but with machine learning or AI could be broken into in the next few years?
I think that was what I was trying to outline in some of my timelines, is that, you know, for example, some of the research papers that have come out in AI, like some of the reinforced learning, you know, those have only come out in the last couple of years. So it's completely unclear as to how that's going to impact architecture. And compared to, you know, that first timeline, it's like it could be, you know, another, 10 years before we figure out how to integrate that into architecture. Because like I was also mentioning is like, what I also think I'm interested in with these tools is like getting beyond automation. So I feel like in some ways we've sort of accepted that automation is coming in some capacity, whether that's automating simple tasks or automating the entire construction documents. But it's like what, these recent technology advancements, it's like, what are we getting from these that's beyond just automating our tasks? I don't know yet.
I think what I'd like to see and where I'd like to see more focus is on the construction document side. I think that we've been chasing really shiny objects because they seem more fun, but we should be looking more at the mundane, the things that are repetitive and are a pretty big part of our business.
Bob?
Hi, Bob Iori from EDSL. Thanks to you both for great presentations. I'm wondering how, as these tools are proliferating throughout your practices, how have you observed that the use of those has impacted the way junior team members are mentored? Are they used as tools for that mentorship? And then I guess maybe as a follow-up question, are you mentoring in the use of these tools and being judicious, looking for those errors that might occur, or learning how to keep basic principles in mind while still using these tools and gaining the benefits from them?
One thought that comes to mind is a design team in Seattle that rely heavily on computational tools, and there's this very interesting dynamic between the design principal and the junior team, And there's not very many people in between because they're working back and forth in creating these scripts and algorithms. And he's passing along the rules of thumb of core, sizing, optimal sizing of curtain wall, and so on and so forth. And it's a direct relationship, and then they're producing the work. So I think we do see that and want to see more of that. And that's where we try to have some other folks in the organization act as catalysts to reassure maybe the project manager who doesn't want to do something different, that we can get it done. It's not going to cost their project any more money. It should save time and produce a better product.
Yeah, I mean, this question's hard just because I feel like I've tried so many different things personally, but ultimately you need, you need mechanisms in place that people can just build this stuff on the fly, which is like, say, like Dynamo. Beyond that, then you need, all this. I mean, this is like, I guess it's sort of like the conversation of like BIM standards and stuff, where like, how do you get people to abide by BIM standards? It's kind of the office culture, and then it also goes towards, being able to have staff that can just quickly pick this stuff up. If learning some of these tools is really difficult, then it's probably not going to work out that well. So I guess it's just some sort of combination of like the staff and then how fast we can build custom tools for everyone to use in-house.
This is where I think, if you look beyond the big software developers, we as a group can work with these smaller startups and give them the funding that they need, the projects that they need to accelerate what they have on their roadmaps. And I'm pretty sure we're all trying to do essentially the same thing. And making the tools easier, predictive, just smarter, malleable would benefit all of us. And that's why, this year we're planning to work with these groups to make sure that they're here next year and can continue to build on the amazing ideas that they have. And, again, we can fail fast and move on to the next thing.
I do imagine in a time in the future where, maybe there's a competitor to Revit or something that is much more, because the way Revit was developed is still, related to how we used to hand draft, like the tools and the graphics and just how they work. But I can imagine in the near future a set of tools that are not thought about how we hand draft and completely thought about, automation tasks or, other ways that we generate, the components for a building.
Mm-hmm. Agreed.
Great insights, thank you. I think we maybe have time for one or two more questions, and then we'll make a break. Ryan, do you have a?
I'll ask a question and run over there. So when I think about augmentation, to me it's the computers helping us get to somewhere we wouldn't have gotten. And are there examples from where you have truly had a result that was mind-blowing or no one thought of because you made these thousands of options?
No.
Simple and short. I believe Brad has another question from someone online.
All right. This is from Russ online, and it's just more of a comment to the group. Regarding QA/QC, a comment. Solibri, I don't know how to pronounce it, Solibri, thank you, can help. Rules-based checking, verify model integrity prior to checking quantities, align checking to solve specific problems, scriptable auto-run can be happening in the background.
Sounds like a Nick question.
Is that a copy and paste from the website? It's like a plug. Yeah, I think there's a lot of great tools out there. I think they can all get better.
The Building Quality Index. Why should we focus on automating construction documents if BIM models are going to be the future deliverable?
Gotcha.
So we've been saying that for a really long time. And I thought about putting a slide in there in my deck. And I kind of went halfway. Maybe I should have went all the way. But it was, I would make a wager with anyone in this room that in 10 years, you're going to see more construction documents like I showed than HoloLenses on a building site. I just don't think we can move that quick. And I think that by augmenting or automating construction documents is the bridge to a model as a deliverable. Because whenever we're asked to deliver models, which we like to do, and want to do it all the time, because we get more fee, because it takes more time. We have to do more in the software, but also produce construction documents. So I think this will be the bridge to model as a deliverable. And there's been like very interesting conversations with a lot of people in this room that I've had over the years, kind of thinking about this and coming to, I don't know if it's conclusions, but today's conclusion.
So you think in 10 years we'll still be delivering documents? Okay.
Yes.
I'll take that bet.
You take that? Okay, great. All right. Yes, 2030, yes.
Great. Question in the back?
Yeah, I just want to say I agree. I'll take that bet. Also, my personal hope is that in 10 years we'll have augmented reality. To go back to the word that's driving your guys' conversation with augmented, what I see is instead of handing out stacks of paper of drawings to people on construction site, you'll be handing out glasses, and they'll be able to turn on what the building should look like in perspective. They'll basically be able to see the building before they build it on the site. And when we're designing it, we'll have augmented reality like in the conference room, as opposed to even having a 3D printed building. And that's always been my personal pet thing. So I'm kind of curious whether either of you see that happening within 10 years or ever.
I thought, I'll take the bet. I don't think the hardware will be there in 10 years. If you used HoloLens anytime recently, it's hard to build something when you can only see this much, and you have to keep moving around. So I don't think it's in 10 years, unless there's a breakthrough. I could be totally wrong. I do think that people will get instructions on mobile devices, because they all have them, and it will be contextual to the work that they need to do. If I'm a painter, it knows what room I'm in and tells me what color to paint the wall. If I'm setting up casework, what are the numbers? Where does it go? What are the dimensions to the wall? As a designer, I want things in a very specific place. I think those will be on devices. So when I say construction documents, what I mean is views. You might view it on an iPad or a screen and onto a phone, but I don't think that's going away. I think it'll be very contextual, very much like Google Maps is today.
All right. Well, I think unless, we have one more question. And we'll,
David Stone with HIT Contracting. It's interesting because the point you made about, the technology, or actually the hardware being the obstacle. My guess is that the technology will be there in 10 years. I think that's not so much the question. I think it's more, contractual or cultural, one of those two. Yeah. I don't know if you have anything to add to that, though.
No, I think there's a lot. I think there's a lot of barriers. I think financially, residential people, a big part of architecture, and I don't know the specific number, but my wife is a sole practitioner, and I meet a lot of the contractors that she works with. You know, they use battery-powered tools. That's how advanced they are, which is great, but they're not using Revit models to kind of lay out joists and rafters and things like that. That's a huge part of this industry.
Yeah, I mean, we're on the commercial side, but I mean, residential contractors, they come on the site with like a truck and they have everything pre-assembled. I mean, and that's coming from somewhere. It's not just the battery operated tools. I think there's a lot more to it.
That is all great feedback. Thank you both. Remember, this is not only just questions, but also the opportunities to offer comments as well are very much welcomed. All right, so that brings us to the conclusion of our second set of presenters. Thank you very much, gentlemen. All right, so a little bit of structure here for the lunch hour. We will return here back at 1 o'clock. We'll be moving into the notion of analysis. And to give us some comment on that will be Andrea Love and Z. Smith. Thank you for your time. Looking forward to that presentation. So gives you about a little bit more than an hour and a half to share your thoughts from today. The AIA staff has helped us organize this. That's another unsung hero in this particular event that I'd like to take a moment to acknowledge. Is Isabella Rossi available? She's at the desk. Okay. Well, we'll give her a welcome when she returns, and Melissa as well is here. Thank you. And so please enjoy yourselves, and we'll be back here at 1 o'clock. Thank you.
Good afternoon, everybody, and thank you for coming back. I hope you had a good lunch and a chance to speak with each other and network a little bit. I'm always so happy to have this group of people here because it is really truly a brain trust that we rarely get to see in person. So I hope you had a chance to catch up with old friends and new. Welcome back, and we're ready for this afternoon's portion. I'm going to introduce both speakers together so they can just go one after the other because I think they have a lot of related speaking to each other that I don't want to get in the middle of. This afternoon session is really talking about analytics as compared to computational design. And while I didn't set the agenda, I'm really intrigued by the idea that the first thing that we talk about analytics, we went straight to sustainable design, where you could talk about analysis in many, many different ways. But I think it speaks to what is so critical and important to us right now, that's the first place we went to. Our two speakers are Andrea Love, who's the principal of building design at Payet. And I think it's really interesting that she's sort of fusing the idea of design and building performance, which is really what we're all trying to do. But I think she's been more successful than most. And our second speaker is Z Smith, who's the Director of Sustainability and Building Performance at SQ Dumez Ripple. I got that right. And he has a really long bio that I'm not going to read, but I think it's fascinating. We can all read, but I think it's fascinating that he's an inventor on 10 patents. So I think we should all ask him questions about that in our half-an-hour session. I spoke to them briefly before they come up here, and they explained that for their sort of yin and yang, they were going to talk about embracing complexity versus embracing simplicity. So I'm really excited to hear what they have to say.
Okay, so I'm going to take the standpoint of more embracing the complexity in high-performance design, and I think has already been discussed. Really, the fundamental thing that it all starts with is what is the question we're asking so we can figure out the best approach, because quite often someone will come to me and say, I need to do an energy model, or I need to do a daylight study. And I'm like, okay, fine, maybe, probably, but what is it that you're actually trying to get to? And so I think we are at... we're at an interesting point where we really have a lot of tools that we can really start to understand these questions at a very kind of detailed level, right? So if we want to understand how can we make a site, for example, more comfortable, we can look at it like the kind of climate data and whether we're in the sun or not in the sun, or is there wind or not in the wind. And then you can start to map these onto a site to understand where the windier parts in the site throughout the year, where the shadier parts. This is a very warm climate, so pretty much the sun's always bad. And then how, as we start to make different architectural moves, can we quantify that? How much are we increasing that area? And so it really allows us to kind of take these tools and leverage them and bring them to a new level. And really trying to understand what is the design space that we have that we're trying to answer this within, right? So we may want to understand how we can improve the performance of our facade, but what is the playground of that box that still exists as we kind of move forward with the design? And then how can we start to tie together multiple different tools to kind of get to one solution? So understanding things like daylight and glare, but also energy usage and peak loads conditions, which relate a lot to cost. And so I feel like historically in the building performance world, it was all about having this tool that could solve all of your problems, right? Like, let's do an energy model and this will make everything perfect. And that worked really well when you had a problem that was suited well for that tool. Like, what is the energy use intensity of my building? The challenge becomes when you have a problem that is not quite that. How can you then leverage that tool to get to the answer that you want? And what I would say in sort of the pro-complexity side of trying to embrace the complexity of these tools is that architecture is very inherently messy and complex, and we need a kind of complex set of tools to help us solve and understand these problems. So rather than having a tool like an energy model, it's about a toolbox. And it's really about having this kind of toolkit, this array and this ecosystem of different tools that can give us different information that we assemble in different ways, just like if we wanted to build a table. There's a series of operations, an order in which we use those tools to try to get to that ultimate result that we want. And so I think, in the building performance sphere, it's the same way where we utilize now many different tools, whether it be energy modeling, a daylight simulation, or whatever it may be, all together to try to get at answering these questions. And so for some examples of things like, this was a project where we were trying to understand comfort in two different ways. One was for radiant floors, and the other was for this naturally ventilated atrium. So you end up developing these kind of, these complex series of tools and orders of operations that are really designed to only answer those specific questions. They may not work to answer the next question, but they were perfectly aligned to kind of answer this particular question. And we can start to leverage tools for things that they weren't even designed to do. So this is THERM, which was really developed originally to understand the heat flow through windows. We've taken it as an industry and start to use it to understand heat flow through envelopes in general. But it can also kind of start to tell us, well, how is our radiant floor system going to really perform? And the thing that mattered most as a kind of the architectural designer is, what is the heat load capacity, the solar flux that can fall on it? And how does that relate then to my design, right? So now I can take that information, and that informs my peak load studies to understand, well, do I have too much solar radiation and do I not? And it's an iterative process, right? Like, it's not, you don't do it once and get to the right solution. You figure out, well, maybe it's not quite perfect. Is there ways we can modify other things? And so it's kind of this constant looping. But what allows us to do is actually ultimately arrive at solutions that we wouldn't have had otherwise, where we ended up, we couldn't really get the design solely through reducing, fritting and shading and other things to basically get the loads to work, but coming up with this kind of pocket that we could develop using the shades to kind of directly ventilate the space. And so kind of through this iterative process back and forth, you can really try to end up arriving at unique solutions. In this project, we also have an atrium. It's basically a really, really big airlock because this is in a floodplain, so the building is actually all raised. The first floor is actually all empty, just breakaway panels. And so you need some way to get people up into the building. And one of the goals was we don't want to ventilate it. It's a big space. It's glassier than I would have made it. So there's a lot of heat gain. And we spent a lot of time trying to figure out how can we kind of utilize this, how can we kind of get rid of them. We wanted to try to see if we could get it to be comfortable without any mechanical system. And so there's a lot of iterations back and forth of trying to understand, well, what is actually comfort? That was actually the question that we were most trying to answer, is when is it comfortable? Because this is not a space where people need to sit and spend a lot of time. They need to walk in from the outside, which is hot and across a plaza with no shade, so they're going to be fairly warm, and into a building. And we have certain kind of psychological expectations of what happens when we open that door, but then we also have kind of the experience that we're bringing with us. And so trying to understand really not just from kind of the air temperature, but kind of that operative temperature, and how does it feel? Will it feel, our goal was basically to not feel warmer than walking in from the outside, right? So just kind of not feeling worse, and trying to kind of understand that. And then this is the ultimate design. And sometimes some of the challenges that we have that I think lead to kind of complex solutions is that our tools are not always perfectly aligned for where we are in the design phase. So one of the things that we've been struggling with is that trying to get kind of LCA information at the point when it could be most influential. So for example, if we're trying to understand what should be the materiality of a building, we make that decision very early on. We don't have a Revit model. We don't have a detail drawn. So it makes it challenging to kind of run a full LCA. So we've been trying to kind of empower designers with this information. So what we did was we looked at a lot of the past enclosures in our office and kind of came up with what were the most prototypical details. We had a parametric therm model so that we could get them all to have the same R value. So we've taken out the kind of operational side of the equation when looking at the LCA and just kind of focusing on the embodied carbon. And then developing these calibrated models. So we can have things like simple and easy. So even though it is a complex process, the output is kind of a simple and easy tool and resources that people can start to understand, well, if I'm choosing between masonry veneers and rain screens, there's actually a pretty big carbon impact difference for that. I think embracing the complexity has also allowed us to start to embed things in when we have a lot of uncertainty. So we've started to do a lot of early energy modeling in like planning and programming staging, kind of master planning, to understand as we play with these variables and we have this big design space, you kind of running those parametric simulations, how can we play out different scenarios, and then how does that impact different performance aspects? Whether it be in this one, they were trying to understand, if we wanted to get into net zero, what would that mean in terms of the energy use intensity, how much PVs we'd need, et cetera, of playing out, these different scenarios. And so you can start to very quickly in real time by leveraging these tools, have this as a way to kind of facilitate conversations. And also can start to inform things like, well, what really matters, right? So where's the sensitivity? What are those big slopes? In this case, it was a lot of buildings, so it's mostly in the mechanical systems. But because I can never show a room of architects something and say that the facades don't matter, that leads into detailed design studies that really are all about actually not trying to understand the reduction in energy usage, but how does it stay below that peak load so that you can do those radiant systems that were actually what was driving a lot of the driving the kind of reduction in energy usage and understanding those connections. And so I think the thing that's most important to understand for me is that it's really about trying to influence design and leading to better buildings. And so how do we use these kind of computational tools and simulations to really enhance the design and make it better? So this was a project that we'd won a design competition for. It was a hospital in China. And it was really centered around this idea of a patient, this window box for a patient room. And so we started, we started off wanting to understand, well, if we wanted to naturally ventilate this hospital, which was one of the goals that the client actually had, which was nice, how can we eliminate natural ventilation? And starting to look at it through a number of different ways that we could utilize these strategies to start to really drive down, through different kind of arrangements, we could really drive down the mechanical energy usage. And so we had this big shroud that kind of was going around as part of the shading study and trying to understand, we did our optimization, as was discussed earlier, of, pulling the depths in and out and trying to understand what we could do. We looked at it for daylight as well as views. So they're really nice views. And so how can we kind of get to the optimal views? And came up with this sort of optimal solution that actually kind of pitched some of the windows a little, some of the shrouds a little bit to kind of give better views. And then the client came back and they said, that's great, but these seem really expensive. There's like literally 11,000 of them. And they're these big shrouds. And so we said, okay, how can we do this? How can we kind of utilize what we've done to really make it the most effective? And so what we went back is we then mapped, well, where are we actually getting the most performance benefit from that shroud? So we kind of had this universally kind of even depth of shroud, but the north side does not need as much shade as the south side. So how can we kind of take these tools and understand how we can, really where do we need it? Right, and then mapping that across the facade to understand where can it be most effective, so that we're able to arrive at a solution that used about a third of the less material, so reducing both its carbon impact, but also the cost, while still getting the same comfort and HVAC energy performance from that shroud. And this is just a mock-up of that in our office. And so ultimately that is now what's being constructed, is by kind of using this integrated back and forth modeling, we were able to kind of not only protect the design intent, but really enhance the design, making it an integral part of the performance. Thank you.
This should be on. Great. So Andrea and I have known each other, worked together, collaborated, swapped tools for about 8-9 years now. But Ryan, who's secretly he's a button-down guy, but he's secretly a troublemaker, said, can't you take opposite positions on some things? So I wanted to talk about having been to the mountaintop and done incredibly complex and sophisticated levels of analysis. I want to argue in favor of not doing that, or argue in favor of using those to develop abstractions that we can then apply to general practice. Because what in the end matters is not what we do on a few exceptional projects, but what matters is what happens with our entire portfolios. So just to introduce, I think, I'm not sure if I represent the smallest firm here. We have I'm at SQ Dumas Ripple. We're in New Orleans. We have the best food. We have about 50, a staff of about 50. And we won the Firm Award back in 2014 and have a reputation for doing really nice design for clients who don't have very much money or actually very much interest in design. And also, I guess we've called it sneaky sustainability through the application of leading edge technologies for trailing edge clients. we work all over. About half our work is in our beloved Louisiana, but the other half is all over the country, and now a little bit international. We have our first project up in Vancouver now. And one thing that makes that's become a distinguishing element in our firm is many of these firms are in cities with huge numbers of great universities and so on that you can just pick through, and you get that kind of flow through of the fresh water of great academics plugging into all your firms. We have a few universities in New Orleans, but what we've done is now for about 6 years sponsored a research fellowship inside our firm where we pick a theme, something we wish we understood better, and we basically hire people full-time at real salaries to come in, and we just say, we'd like to know more about this. Please read 100 books, tell us which 3 we should read a few hundred articles, tell us which 20 we should read, do a little bit of original research, plug into projects if you want. You have no deliverables other than that. And so we pick themes from building performance, resilience, community engagement, health, the integration of civil engineering and landscape into a civil environment, building envelopes, sound, human biological perception and sound, its impact in sound and vision. And then this, if I can do this, yes, this year's theme we call Deep Impact Paths to Carbon Zero, because there is no one path, there are many paths towards getting to zero carbon. And so what we're doing is 12 real-world case studies on projects and sharing all this, what we find on real costs of what it takes, with some projects that are actually achieving it, some projects that could have, but in all cases we're working with contractors and so on to establish the actual costs and the actual pathways. And then our goal is, you know it's research when you give it away. So our goal is to give it away. So why does that matter? Well, as we all know, the science is settled. I heard somebody say recently that we probably know more now about climate science than we have higher confidence in our climate science than we have in the second law of thermodynamics, which is amazing if true. But we can pretty much model what's happening with the rise in temperature and the other impacts now in a way that we couldn't have done years ago. And what's interesting is the political activism that we're moving into now is one where people aren't prescribing, they don't prescribe specific policies. What Greta Thunberg says is, just listen to the scientists. The scientists have got it. And it's not my job to tell you how to put out the fire. I'm just telling you your house is on fire. And so we also know that there is a carbon budget that we have for maintaining any given amount of temperature rise within the world. It's been calculated well what that carbon budget is to stay within 1.5 degrees centigrade rise, 2 degrees, and so on. We know right now that we have basically 9% left. We have 9 years left at the current rate at which we're adding carbon to the atmosphere. But we also know that there's lots of other benefits. I have a friend who is a commissioning agent. He says, I love my job because in 25 years, I have never worked on a building whereby making people more comfortable, I've made the energy use go up. The energy use always goes down when we make the buildings more comfortable. And we're finding increasingly what clients care about, even if they don't care about climate change, is an environment that helps occupants be healthier and more productive. And that is a tremendously powerful sell where energy savings is often has very small payback. So we're finding we can connect with clients in that way, and being climate responsive becomes part of the act. So the neat thing is, compared with many other professions, we are powerful in architecture, meaning most folks in their execution of their daily careers have very little impact on what's going to happen in climate change. But architects are directly responsible for 39% of the carbon emissions through building operations or the materials that go into construction, and indirectly through the energy that gets used in people getting to your buildings. I was on a tour at a National Renewable Energy Lab of their net zero office facility and their super sustainable parking structure. And the reason they needed that was that everyone had to commute to their office. And the WAG who was walking along next to me did a quick calculation and pointed out that the carbon emissions of NREL would be even lower if they had just built a standard office building in downtown Denver where people could walk or bike or bus to work rather than all the emissions necessary to get there. So transportation matters, building materials matter, and so on. So I'll try to go through how a mid-sized firm approaches that. Again, we see astonishing tools being developed for firms of 1,500, 2,600 employees. The challenge is, let's remember that half of all firms in the AIA are less than 50 employees. And so how do we find tools that those kinds of people can be using and apply to every project? So that science, those insights resulted in, at the last AIA conference, the membership challenging the AIA to take a much more explicit set of initiatives on climate change that was debated through a set of proposed policy changes within the AIA, and that passed with 93% vote. And what does that resolution now require us to do? Well, adopting what used to be called the Code Top 10 Framework for Design Excellence as the new AIA Framework for Excellence in Design. It builds in and equates design excellence with beauty and performance, as Andrea's firm uses as their slogan, the integration of those two things, and to spread the adoption of the 2030 commitment. And so it's hard to find on the AIA website. I think that they claim they're making it easier, but I encourage everyone to go take a look at the Framework for Design Excellence, because what it's trying to do is, without the complexity and high annoyance factor of, say, the LEED rating system, how do we just organize all the things that if architects were paying attention, they would be doing in their buildings? And how do we develop simple metrics to know if we're getting better? So I'm going to talk, though, about this portfolio-wide approach and why it's absolutely vital. 20 years ago, it was really important that we produce a few exceptional buildings to show what was possible. But given that bucket, we only have a few years left to implement things at scale, at every building size, to radically reduce the carbon footprint of buildings and make them radically better for people to be in. So the 2030 commitment shows an approach for doing that, where you basically have to enter every project in your design portfolio that year and its projected energy use and compare that with the baseline of existing buildings back in 2003, with this aggressive target that the portfolio savings should be 60% or 70% and so on. Very few firms, except those with very highly curated client bases, are achieving that. But it doesn't matter. What matters is that, I call this the pencil diet. You can eat whatever you want so long as you write it down, and that the act of writing it down will help influence your actions. So we find it very, very useful when we started taking this seriously, was that every project manager started to be able to know what the EUI of their project was. I couldn't spell EUI when we started, and now everyone's tracking that energy use intensity. Just as important, as we get past just talking about what the computer model said and start calling up clients and saying, do you mind sending me your energy bills? And learning how the buildings are really performing, because you learn a ton that way. You set up this amazing feedback loop. So I just want to give an example of what's happened in our own firm in this last year, 2019, looking at both operational carbon and embodied carbon and what that implies for the tools that we're using. So we're a pretty typically sized firm. About half our work is new construction, half our work is major renovation. We work in a broad set of facility types, from offices, multifamily, labs, museums. So as I said in that one diagram, what are the things we can do? Well, if we're going to do new construction, we can do new construction as long as we're densifying sites and reinforcing walkability and transit use. So this is in Charlottesville. It's a project, new construction, 200,000 square foot office incubator space. It's got an energy use intensity of 26, where a typical office building might be 60, 70, 80, 90. And provides what we hope is a nice environment for workers. Everybody has daylight views and so on. Just as interesting, it's just as important that we go after the dogs. This is a really sad 1980s office building in Baton Rouge, where they hired us just because they were so uncomfortable. And they said, we need to replace the heating and cooling system, and while you're at it, could you do something so we don't hate this place so much? And so we've done this radical set of interventions where it's a 7-story building and people will walk up all the way through it, through a series of double height spaces we've carved into it. You'll notice that its energy use intensity is the same as that new construction building, highly optimized facade and all kinds of other things. So we can achieve essentially the same level of great energy performance, 70% reduction or better compared to baseline buildings, in existing buildings at tremendous carbon savings. And so really important that we tell people that story, that matters as well. this is the third example I'd give is new construction, densifying a site, and low carbon construction and net zero energy. This is a 50-unit apartment building aimed for veterans with children at low incomes, so it's like fully buzzword compliant, and building it for $146 a square foot. And then for, on that $6.4 million, we did a thought experiment saying, you know, for an extra $1 million, we could take this thing, we could cut the energy use in half, offset it with rooftop solar, and provide the ability to island the facility off the grid when we had one of our very frequent power outages in New Orleans. And strangely, the local utility funded that. And so this building is just opening right now for $164 a square foot. We're building net zero affordable housing with the ability to island, so resilience and so on. So this is all in our grasp, and it's a matter of just sort of applying all these tools. So now in that portfolio, having given those examples, this is new construction. These are the carbon emissions of all the projects in our 2019 design portfolio. This is the carbon emissions associated with building those buildings. This is how much the emissions we're anticipating during the first year of operation. Obviously, this one just builds up year by year by year. But what this is telling us is that if you're doing new construction, let's reinforce the painfully obvious, architects in the next 10 years we will use up the carbon budget available to us just from the carbon of the embodied carbon of building the buildings. It doesn't matter if they're all net zero, unless we start paying attention to this number. Compare that with the major renovations, where we're doing the carbon accounting on that. Obviously, the upfront emissions are much lower because the structure, most of the envelope and so on are still there. In this case, most of our portfolio of renovation projects is dominated by some academic lab buildings, which tend to have a much higher energy use intensity too. So obviously we have to pay attention to both, but we have to start talking about them in almost equal power. Now, we have the fancy integrated tool flow model that Andrea has laid out, and in our best projects and when we're on our best behavior, we're applying all of them, modeling daylight, energy, carbon, land use, and so on all the way through a project. That's great, and then we try to find ways to communicate those with clients in really simple ways that they can wrap their heads around. But what we find is going to be important to pick up our whole portfolio is sort of an approach that combines, it uses those experiences to inform everyday practice. So it's pretty simple. We set goals using the Zero tool, which is sort of the follow-on to Target Finder as developed by the Architecture 2030 people. We just pick a relatively recent energy code, and it doesn't matter where our buildings are being built. You just pick the most recent energy code that's really in force anywhere as your starting point, and you'll do okay. Get that one, and then you can optimize and tune, explore particular questions during design. But again, you don't have to do whole building energy modeling at all stages to get a good result. And so often the whole building simulations will come later. So the Zero code for review just says, pick 2016, use that as your starting point, and then model things up, optimize things when you can, use some on-site renewables and some off-site renewables. So I want to talk about this notion of using simple, stupid tools early and then optimizing for whole building later. So we have a tool in-house developed originally as part of teaching a class called the Way Too Simple Energy Model. It's a spreadsheet. And what we found is that we can use that to get remarkably close. So this was this is part of a project for Georgia Tech, where they wanted to do a living building at Georgia Tech, but it was going to have more classrooms and labs in it and so on. So we said, we can model with that simple spreadsheet, the Bullitt Center, the famous very low energy use intensity office building in Seattle. We can pretend it moved to Atlanta by just shifting the simple climate characteristics. And then we can tweak the inputs for classrooms and labs. And then we can weight them by program area, and we can say, we think your project ought to be able to achieve an EUI of 22. Then the industrial strength energy modelers get going as we're evolving the design, and when we're all done, they said you should be able to get to about 20.4. Now, the amazing thing was getting from 80 or 90 to the low 20s, getting between 22 and 20.4. That was nice, and we have a higher degree of confidence. But it's really important to do this early to convince yourself that it's possible. As Oppenheimer said, the secret of the atomic bomb was that you could build one. Because once you know it's possible, that that thing is achievable, then you'll figure out the pathways. The thing that's holding designers back is the sneaking suspicion that an aggressive goal is not achievable. So this notion of picking a very simple energy code as your starting point, these are the progression of energy codes through time. We're getting to this point of diminishing returns. So let's just settle on one of these things and then go through and optimize. As an example of that, Michael Pollan in his book, The Omnivore's Dilemma, it's 800 pages of lovely writing and great storytelling, and in the end he said, if you want to understand what I'm trying to tell you, it's eat food, not too much, mostly plants. So when it comes to glazing, use glass, not too much, mostly south or north. So when we're very hot climates, we actually want to optimize for north glass. So this is a project where the site told us that the building needed to mostly face west. But we can't have most of the glass facing west, but we want good daylighting and ventilation. And so we were able to manipulate all those forms and end up with a very high spatial daylight autonomy of a building that actually only had a 14% window-to-wall ratio. And we did that through optimizing that office and that public space as simple shoeboxes. So again, at the end, this beautiful simulation was done at the end of the process because we picked the anchor spaces and followed those through. Carbon intensity, though, let's flip back to that to wrap up. There are these tools out there, Athena, Tally, and so on, for simulating the carbon footprint of buildings in which you can enter the doorknobs if you want to. So there's this data set you can download from the Carbon Leadership Forum, over 1,000 buildings that have been simulated. And then you can, I just thought I would plot up the carbon intensity of construction of the 1,100 buildings that are in that data set. And for the statisticians in the crowd, that's a Rayleigh distribution. So it's a random walk when you can't go negative, right? So the median building has a carbon emissions intensity of about 67 pounds per square foot of construction. Now, if you think quietly, you'll remember that's kind of how much buildings weigh. And so a really neat thing to remember is that the carbon intensity of buildings tends to kind of correlate with how heavy they are. So when we were working on this project for Georgia Tech, we simulated making this 3-story building with concrete slabs, steel, or mass timber, and then we calculated the carbon intensity of the structure and the cost per square foot of those structures. Now the challenge is, again, to pick on Michael Pollan again, use structure, not too much, mostly wood, might be a path forward. But the world has gotten more subtle, so it turns out that there's a big distinction between good wood and bad wood, meaning if you're using clear-cut wood, not sustainably harvested, because what matters isn't what happened to the forest when you got the wood. What matters is afterwards, right? Because the carbon sequestration only keeps happening afterwards if that land is locked into a sort of renewable form. And the other distinction we've had is we've gotten lazy, thinking we can always get fly ash for our concrete or slag for our concrete to lower the carbon footprint of our concrete. Well, this just in, coal plants are closing around the country. So we blithely put out the bids for our Charlottesville project and found that we couldn't get any fly ash for that project because the Department of Transportation has locked in all of the fly ash for the state of Virginia because it's needed for waterproofing in concrete, and they have it all on consignment. And so we need to start thinking about easier and better ways to get low-carbon concrete. Oh, this was my point here. Famously, the documentary about Buckminster Fuller, how much does your building weigh, Mr. Foster? Or it's about Foster, but it's the question that Bucky Fuller asked at Norman Foster. This is just showing that if I take that huge data set and reanalyze it, it says the best predictor of the carbon footprint of a building is how heavy it is. The other thing, finally, is just to say, again, this notion of how much analysis to do when. There's a tool called buildcarbonneutral.org, and it basically just asks you, what are you doing to your site? Are you cutting down trees or not? And is the main structural system steel, concrete, or wood? And it gives you an answer, and it takes about under 5 minutes. And it gives you an answer. And then there's Tally, which takes, you have to build the whole Revit model, you have to tag everything, run the analysis, double check it, all that kind of thing. It takes sort of 10, 20, 30 hours to get a number you're really confident of. I'm not criticizing, I'm just saying that's to get a good number. It's just like a good energy model. And then we just picked the 5 most abundant components the steel, the insulation, the concrete slab, and so on, and just got the environmental product declarations, the EPDs, for those 5 things, and just got a spreadsheet out. And so this one took under an hour, this took 20. So there's this notion of a very quick analysis getting you 90% of the way to an answer that tells you what you ought to do. So in closing, what I want to say is it's essential that we do this level of sophistication of analysis so that we know that the simple tools are valid. But it's the simple tools and the portfolio-wide tracking that will actually have an impact that we want to have. Thank you. Come on down.
I have a quick question before we sit here and there. On the live stream, can you focus on them when they're sitting down there? Awesome. Thank you. They decided to sit up here so that you could all see them and see their expressions and know if they're lying to you, being honest. But I have a series of questions which I thought was amazing, but I want to open it up to the group first and see if they're, I'm sure there's tons of conversation we want to have around this. So anybody want to go first?
Oh, it was worth sitting up here. Right, I'm Praddy with David M. Schwartz Architects. We do a lot of traditional construction. There's a lot of brick and stone. And that really, on your point at the end, got me really thinking about the building weight. And we are making really heavy buildings like this one versus the one across the street and so on. So how is and there has been, I'm also an urban designer, so we are talking about how the public space feels, how timeless it is, and how do these factor in with carbon emissions and long-term, and should we stop building brick buildings? And
I mean, the most sustainable building is the building that is loved, and because the building that is loved, people will fight to not tear it down. So it's important first that we make loved buildings. And if brick is part of getting you to a loved building, that's fine. Now the question is, that brick, let me give you an example. I worked on a project, I am a Perkins and Will refugee. When I was at Perkins and Will, Vancouver, we were working on a project where, for historic reasons, they wanted this brick, they had glazed brick with this salt and pepper appearance. That glazed brick in the 50s was the dominant use in the campus. It was used in order to emulate a form of granite that was found locally 40 years before, which that granite quarry was no longer in business. So then they went to using this glazed brick. By that point, glazed brick had fallen out of fashion. The only place you could get it from was Georgia. And so we said, we want this kind of salt and pepper appearing brick, but we want it to be locally produced. And so we found a local maker of fireplace mantles who did architectural concrete castings. And what they did was they took this concrete with fly ash, so it was lower carbon, and then they add a local pumice stone so that they could, from a black sand beach, to get the salt and pepper effect. So we ended up with this form of brick that was much lower carbon intensity than buying brick from where brick normally comes from in Canada, which is Quebec, a lot lower than bringing it from Georgia. It was actually locally produced and low carbon and had this aesthetic effect of tying it into the rest of the campus. So I think in every building form there are ways to do this. It's just obviously took a lot of weird hacking on the telephone to find somebody willing to do this with us.
While we're waiting for people to think of questions, I had a question for you, Andrea. You sort of talk a lot about measuring, ability to measure things, and I was thinking about it based on the conversations we had this morning too. Do you have methods you use to measure social interaction as well?
It's a really good question. I mean, I think it depends a bit on what we're looking, like what exactly we're looking at. So we do primarily research labs and hospitals. And so we have done projects where we'll go and follow researchers, both before the design to understand kind of how they use space, but then also after the design to understand if they're using it the way that our design intent, and we'll, kind of measure and track things, kind of old school on a piece of paper, marking up a floor plan of, how often are they using a shared piece of equipment and how many different people are using it, what are the paths that they're traveling, is that what was anticipated, are these kind of collaborations occurring? And so I wouldn't say there's like one way that we measure it, but it kind of depends on the question that's being asked. We've been trying to look at like social spaces. In a lot of our buildings, we say, collaboration will happen here. And, magically it does, right? And of course, some are more successful than others, just like everyone's projects. And so we've been trying to go back and start to understand, like, is there a formula, or not even a formula, but is there kind of a series of things that you need together, whether it's proximity to coffee or access to daylight, or, it needs to be close to your office or by the hallway, or like, are there things where you can start to see trends? And I would say so far, there's not really like one or two things that are standing out, but we have admittedly a small data set. But trying to start to understand like what really starts to make a successful collaboration space. So I'd say that the metrics are kind of different for each problem that we're looking at.
We did a project where we intervened in it was a company that they bought the building next door, which was an old windowless data center. And all the other firms that competed for the project proposed ripping off the facade and giving it an all-glass box. And we said, what is it Luke Skywalker says, every single thing you said was wrong. So we said, no, actually, leave the facade as it is. We're going to drill holes in it and make this, because all you would see from the outside of this building is parking lots of Baton Rouge. So instead, we're going to create this kind of interior world that's daylit and has greenery and so on. And then what we did was we surveyed, we have a lot of kind of unconscious way to survey people through their phones, tracking things about them and so on. But what we talked about was, what if we just asked them? Now, people are famously, unreliable narrators of our own lives. That said, we just did a series of surveys with SurveyMonkey while they were in their old building, documenting how often they did various things. And in the middle, we slipped questions about how often they had conversations or collaborations with coworkers. It was like question 17, so they wouldn't notice. And then we administered the same survey after they moved next door into their new space. And so we're able to document an increase in collaboration that way. And I think this notion of just asking people things often is very revealing. In thermal comfort, we have this problem that the standards on thermal comfort were designed based on Fanger in Kansas, a bunch of college students in the 70s, 60s, there you go. Those pictures, the hairdos were really great in the photos. They found, for example, that there's no map, thermal comfort is independent of gender, which we now know to be completely false, but it's cast into the standard that way, things like that. And people are on average cold, and women are on average colder. And the more recent research is that, in fact, cognitive function gets affected differentially according to gender on average. And so these standards about what constitutes thermal comfort are built around all kinds of interesting biases, prejudices, and so on, reinforced by our standards. We have our office there, top floor of a uncharacteristically tall building in the middle of New Orleans, built in the height of 1978 technology. There was one air handling unit for the whole floor. Everyone's at nominally one temperature, and it was always cold. And we kept asking the facilities manager to raise the temperature. He said, it's not technically possible due to the engineering of the system. And so then we did a SurveyMonkey where we got 100% participation, because it turned out that the people who were complaining were generally the office managers, who were generally women, and therefore he discounted whatever they said. Those are just the complainers. And so when we showed a spatial map that there were 2 people who were comfortable and 50 people who were either cold or extremely cold, he said, and he went into the room and found that actually you technically could raise the temperature. And so that's an example of, we have all this data and we have all this technology, but we also have, the problem is our technology that's inside our skulls that's limiting our ability to see what's there. And so using surveys, I like to say that the most sophisticated building management system ever invented is the humans who are already in the building. And that if we could find better ways to listen to them, we'd know a lot more.
I find it fascinating that almost everything we've been hearing about really springs from what Emily's been talking about this morning, right? Talk about assumptions and where you're starting from. You talk about, everything that we've been talking about sort of feeds off that method. So I'm glad you spoke first, Emily. Any other questions? Okay.
So hi, Gustavo from FX Collaborative again. Piggybacking on that, I was actually thinking the same thing, going back to this morning's conversation when you were saying, Emily, what are the things that data can help us answer, and what are the things that we don't need data for? Seems like in your talk, Z, I'm assuming you go by Z. Awesome, one-letter name. You're saying to rely on your intuition and the kind of the basics to push you forward as opposed to wait for the technology to get all worked out, and by the time you're done, you're in CDs, and it's like, oh yeah, the energy model came in. So I guess my question to you and to both of you, since you're working at kind of different ends from that point of view, is how do you know when to switch from the intuition to the analytical? And why, when, how, and why does that happen in your case? Because in your example in Payet, you started very much analytical, but when does intuition come in? And the opposite.
I would say, well, for us, I would say it very much, the analytical part comes in when I don't have a good intuition, right? And so if I have done 3 projects like that or 4 projects like that in a similar climate with a similar issue and we're in early design, I'm going to start there with my kind of intuition of where I think we are and then check more as I go. And so for me, it is, what is the quickest way to get to kind of the 80% confidence answer, right? And so if I can get you most of the way there with intuition or with a quick calculation in a spreadsheet, I start there. And it's when you get to kind of the complex ones or the ones that are, we don't really have a good intuition right away, and we need to understand how kind of different variables relate to each other or things like that. And then it's a lot about, I think Z, did a good job talking about this, is we very rarely actually do like a whole building model. It's a lot of little shoebox, like how can I spend a day and get a pretty good way to that answer. And so for us, it's all about what is the quickest and easiest way to kind of get to that. And so if I have a good intuition, I start there. If I have a quick and calculation or something back of the envelope way, we'll kind of take that step. And then it's for me, it's really dictated by the answers that we may have at our disposal.
Yeah, I think Al Gore in Inconvenient Truth quotes Mark Twain. I've never found the original quote, but he says, it's not what we don't know that gets us, it's what we know that just ain't so. And so the challenge with going on, I think we're both actually arguing for a kind of a continual loop of fact-based rules that inform those early steps and those big moves, tuned through simulation when that's called for. And so I think the danger trap is when people design intuitively in ways that are contrary to what we know to be the basis of obvious good design. Like, I can make an all-glass box, and I'm sure the mechanical engineer can save my ass. People still say it, because unfortunately there have been enough examples in the past where things have gotten pulled out and at least they managed to meet code. And yet, where were the adults in the room when we started making all-glass buildings in deserts? So I think what's important is to not believe, not to view the kind of technical fixes as this deus ex machina that will come in and save you at the end. That, if we start from reasonable fundamentals, you can deviate and do some interesting and unexpected things. I think the challenge is when we just, dismiss it.
And I think it's understanding the level of depth that you're at, right? Your level of understanding of the problem. And so if you're in schematic design or even concept design, right, and you don't have a great level of detail on that, and you're just trying to understand quick, should I go left or should I go right, turns in the road, then it's a very quick and dirty model. And as you get kind of your understanding of the problem and the issues, I think the level of analysis and detail needs to, like intuition is harder. You rely less on intuition as the design process goes on, because you need to kind of understand it at that finer level of detail. And so I think understanding where you are in the design process and sort of what are the decisions being made, I think is also an important part of that equation when deciding what is the right path forward.
Andrea, do you find yourself, or both of you, do you find yourselves doing some of these quick and dirty models just to prove to other people that your intuition is right? Namely clients, I would imagine.
Yes. I mean, I would say yes and no. There's often things that I might still learn from it, even if I think I have a good intuition. But there are many, many models where, and I'm sure Z has similar things where, percent glazing is one of the variables that we're looking at. And I can tell you that it is never more helpful when you're above 30%. But we will always have an option that may go above that. Sometimes it's to prove to the client or someone else on why we shouldn't kind of go that far. But there are lots of times where we model things that I know what the answer is going to be, but you got to show someone.
Yeah, I think the challenge, to everyone here is to develop tools that can give you answers in under an hour. And because that's when the design process is moving with the greatest leverage, is in those early stages where if you come back, you say, can I have a week, to explore that massing or whatever it was, it's too late. It's all moved in. They already showed it to the client, whatever happened. And so, there is the time for more thoughtful, deep exploration, and that time sometimes happens at the end of the project, and you hope to carry that forward into the next project. But in this project, we just need a slew of tools that work in under an hour, that get us kind of 90% of the way there. Because any effect that's less than 10% impact on building performance, we probably actually don't care about, because buildings work or don't work within factors of 2 in terms of things like energy performance or daylighting. We sit there and we optimize down to the 1 and 2%, but no building's ever built that well. And just the variations in how the building's operated have swamp out effects from that. So let's go after the big stuff. I think this was, again, our statistician talked about what is the delta at which you care.
Yeah, I would say probably for me, for in our office, and maybe we just operate at a slightly different model, but it's about a day. That's about our turnaround time. If I can get an answer in about a day, it's usually perfectly reasonable time to kind of still influence the design, but much more than that, it's moving pretty fast, and now you're kind of trying to realign things. But the sentiment, I agree with. Yeah.
Hi, I'm Melissa Stewart from HDR. I was wondering, since you have this wealth of data and all of this analysis, do you find that it helps kind of your younger staff, especially with something like sustainability, get that intuition faster? I think there is a big gap between folks like yourself who have an intuition of, yeah, this is going to work, and then somebody who's very junior out of school and has access to all of these tools where they can punch in the numbers very quickly.
Yeah, so I think I spend a lot of time actually trying to, as does Z, of trying to figure out how we build that intuition. Because, ultimately, when you have a firm of 170 people like we do at Payette, I can't be in every meeting and be part of every, everyone needs their own intuition. And I think the thing, it's actually not the tools that necessarily give them that intuition, though that definitely informs the intuition. I actually think it's just having the data, right? So, Z talked about the 2030 commitment and having the energy use intensity of all their projects. And when people start to understand, well, we did these series of things and the energy use intensity went down here. We did these series of things and it made this difference. It's less about the tools and more about just tying the outcomes with the kind of design decisions that you're making. And so whether it's a quick calculation on the back of an envelope or a full energy model or a shoebox model, I don't think it's, personally for me, I don't think it's necessarily quite as tied to that. It's just about kind of having a measurable outcome that people can then tie to understanding the difference between those things.
I was just saying the biggest challenge with younger staff isn't interest in sustainability or computer literacy. It's the issue that the what we used to call the architectural press, which is really just the architectural web stream, is still focused entirely on the visual and not the experience of the occupants nor the performance of the buildings. And so I was talking with someone here who talked about that they developed net zero K-12 schools. And then the same client went and hired a very famous name-brand architect who did a big, swoopy, probably not very good performing building. And so the client, I said, there's nothing wrong with making big, swoopy buildings, as long as they're held to the same performance standard and so on. And so the challenge is we kind of give those things a pass, rather than just saying, we don't allow, for the most part, buildings to not fall. We don't say, it's okay if that building falls down because it was really cool while it was standing up, right? And yet we allow architects to continue to get away with buildings that don't perform, either in terms of comfort for the occupant, the experience of the occupant, or energy and carbon performance, all in service of it. It was a really cool thing on my Arc Daily feed. And so the biggest challenge is to kind of, if we can somehow raise the standards so that everyone has to deal with in that level playing field, then it'll take care of itself, and we can still have really cool, swoopy things.
Any questions from online? Sorry, go ahead, Greg.
Greg Schleusner, HOK. So given that these two choices exist, I mean, I think people, I don't do any of these things, but people operate in this world all over the place. I guess the question is, are there things that are clearly missing from like either side of the approach, like more technical tools or tools for certain problems, or and if the question is scaling them more than can they be done, maybe is the way to phrase that question.
I think it's probably a bit of all of it, right? So there's a lot of tools. We have a lot at our disposal. I mean, I had that little ecosystem right there, like lots and lots of building performance simulation tools that all do different things. And a lot of them, with the kind of the power of parametric design, you can link in different ways and get different outputs. And so you can leverage it, although it takes, I think, which was the sort of thesis of this kind of debate, is that it takes a certain amount of skill. So that's a challenge. And sometimes that skill often does not exist with the people that have the building performance skill, right? The people who are good at parametric design are not always the same. And so there's a challenge of having to get those two together and become better friends. But I do think that a lot of the tools were developed to do very detailed analysis. And energy modeling has been around longer. And so I think there was an effort to make simplified energy modeling tools. But the challenge with simplified energy modeling tools is that they don't give very good answers, right? They work if you have this very specific problem, a lot of them. But they don't give very good answers because there's very few inputs. But what I think has happened a lot is, how do you kind of get those more robust energy modeling programs earlier in the design to inform design? And I think with LCA, which is much newer in the kind of being part of the design process in general and in terms of tool sets, one of the things we struggle with is how do we kind of leverage and do that now with some of those tools. And so I don't know if it's a combination of kind of inventing new early tools or just figuring out ways to use these kind of more robust tools in an earlier method. But that, for us, at least in our office, has been a bit of where we've been trying to kind of understand, like, what is the right kind of set of tools. I would say the other one that is a bit of a challenge, back to the kind of you only have an hour to answer the question, or a day, or whatever it may be, is things like computational fluid dynamics, which are sometimes needed to answer specific questions. But if you really want to do a robust CFD model, it takes weeks. And there's no design process, rarely, where you really have the luxury of running iterations that take weeks to run each simulation. And so we've been trying to explore different ways of getting, again, to that kind of, like, it's not perfect, but the 80, that 80-20 rule of how can I get 80% of the answer for 20% of the effort, so that I can do it in, like, real time with the design process. And that's where, so there's room, I would say, in my kind of long rambling answer, I think there's room for growth probably in the tools that might be needed, but we have a pretty good ecosystem to work with, and I think more it's giving people the knowledge and skill sets to utilize them.
So in the spirit of the session that happened just before ours, where there was this discussion about using tools at the front end, exploring massing versus using tools at the back end, if you will, towards automating the CD process. I think there's an astonishing thing for construction and post-occupancy where we don't have good tools, where we don't know how to feed that information back to architects in a way that informs design. So let me take a banal example. I told the example of you can't get low fly ash carbon, you can't get high fly ash concrete in certain parts of the country anymore. So there's this initiative in California called Buy Clean California. It's nominally it went into effect in January 1st. And what it says is, it's like Energy Star. They've done an inventory of all of the kinds of steel that are on the market, and they've said that if you want to build a state-funded project, your carbon footprint has to be in the low 25%, the 25th percentile or less. And the challenge is that you can make all these great design choices, say, I'm going to use this, I'm going to use steel, I'm going to do that, and so on. And then you get to the time of construction, it goes out to bid, and in fact, it turns out that the glass that you've lovingly designed with the special frit pattern, I had a project where the glass got It's coating in Vancouver. It was sent to Belgium for its fritting and then assembled into an insulated glazing unit in China and then came back to Vancouver. So it had a round-the-world journey. And there was no knowledge during the design process when I was making those design choices that were all about the optimization of the building, that would be true. And so one wonders in the future about how to, in a data-rich world with supply streams, supply channels, and so on, how do we link these things through? So if I'm specifying a building in California, I don't even know how to do it, really, in a way that I can warranty that we're going to achieve the Buy Clean California target. The genius of this, right, is we think, what is the premier intellectual achievement in the 19th century? Evolution, right? Darwin. He says, the big idea is that there's variation and there's selection pressure because of overproduction that will select preferentially that the thing that gets to reproduce is at this end of the distribution. And so if we apply that notion of learning to, say, the embodied carbon, if there's a distribution of carbon intensities of steel, and we just say you have to be in the top 25% to get in these projects, and then 3 years later, all the vendors move in that direction, so now to be in the top 25%, you have to move here, and so on. There's a great opportunity for a very tight feedback loop in the market to get us to much better carbon intensity, whether it's brick, whether it's steel, whatever it is. I don't think our tools are set up to be able to track that through the construction process, through the bidding process. Then the second area is how we understand how buildings perform. Your question about did collaboration occur, were people comfortable, and so on. There's a gazillion data points in building management systems, and a couple of interesting little startups out there all trying to munge through all the data that Johnson Controls has logged. I haven't seen a convincing solution for it in a way that gives usable answers. The most frequently, we had a high-performing building that started to go south, and we said, well, this is really weird because there's no alarms going off at all. And we found that the building manager had developed enough programming competency to break into the building management system and silence all alarms because they were annoying him. So what we need is systems that get past that, because those were all things that were warning people that things were out of kilter.
I think we have time for one last question.
Yeah, you touched on it a bit. This is Greg Seaton from CSI. You touched on it a bit when you're talking about your supply chain and your round the world trip for your glass. A lot of times, and this is with CSI, we work with a lot of building product manufacturers. A lot of times, that information is actually unavailable to the building product manufacturers at any point in the supply chain definition. So we've got a real difficult problem if we're going to try to tie that into embodied carbon, because they change that process constantly. There's a ton of different teams involved in acquiring and processing the products, and more complex products like the one you described, it just multiplies. Even something as simple as, say, like paint or insulation can vary from part of the country to part of the country over time with contracts. So yeah, I'm just wondering if you've got any thoughts on that end of it, because we do have to answer the question about embodied carbon.
Yeah, I think the thing about embodied carbon is it's really, really complex, even more so than kind of some of the other sustainability topics. But it's about understanding what's really driving it. Back to Z's thing about what really matters. When you look at embodied carbon of a lot of the materials, the transportation is actually pretty insignificant. And so if you're trying to get to the part that makes the biggest impact, let's not spend our time trying to figure, not to say we shouldn't think about it when we can, but if it's really hard to figure that part of the equation out, okay, let's focus on the most of it, which is actually the material, the manufacturing, the extraction, and the things that the manufacturer can control and we can understand better. And if we don't have, kind of regional data, let's use national data so we can at least start to understand the difference between a brick and an aluminum panel for the side of our, let's start at the level of which we have data, and then as we develop our sophistication, we can make better decisions, but starting with kind of what we have, because you can make decisions that make pretty big impacts with the data we have right now, even with the big holes that exist.
No, Andrew's right. I like telling the story of the round-the-world trip for the glass, but it turns out it takes very little energy to move that glass in a freighter ship around the world. That's why everything you're touching right now is probably made in China. There is a lot of interesting progress on this, and it comes from the world of VAT, of value-added taxation, right? Where the tax gets applied at every stage of the supply chain in manufacturing. You can imagine, if you will, a VAT carbon tax, right? That simply tracked for every product how much carbon was added, how much carbon emissions happened at that stage of the process, including both. And then it would just take care of itself, because the tax attorneys are great at this shit. And so I think that there is a mechanism for that, for doing that, and I think that it'll probably follow from that. And it won't start, lamentably, it won't start here in the States, but it'll start in the countries that are ahead on this.
Yeah, there's a quote from, I think he's a statistician, George Box, that says, all models are wrong, but some are useful. And so our embodied carbon, like our life cycle assessments are going to be wrong, but we need to make them useful so we can make informed decisions.
On that note, I think we have to end this afternoon's session. Please feel free to follow up with them. I'm volunteering you for questions in person. But we meet back at 2:30, so you have about 25 minutes before the next session starts. Thank you, and another round of applause for our fantastic speakers. Thank you. Good afternoon, everybody, and welcome back. Thank you for sticking around so long. We're so glad to have you. We're starting the automation and computational design section of the afternoon, which is by far my favorite piece, just because it's so triggering for everybody in the room. So I'm looking forward to some great conversations. There were a lot of questions that we had earlier this morning that I think could apply to this afternoon session as well. So hold on to your questions and be prepared. Again, I'm going to introduce both speakers here and then let them take the stage. The first one is Alyssa Haas, who's coming to us from Vancouver, which I highly appreciate. She's also my sister in arms because we are both architects in engineering-heavy firms trying to make a change. So hang in there. No, she's doing some fantastic stuff, and I'm dying to hear what the kind of example she's going to talk about. And then after that, Dane Stokes from ZGS, who's also coming from Seattle, so not too far, is going to talk about it. Again, his resume and his bio is up there, but I find it interesting that based on what Nick said this morning and talking about Ferraris, that you're coming from the opposite direction. You're coming from high-performance automobiles to buildings. And I think the question should be why?
It's not as glamorous as that seems.
Well, I'll let them start, and we'll look forward to hearing what they have to say. Thank you.
All right, thank you everybody, and thanks for inviting me. It's a pleasure to be here. I'm going to be chatting a bit about automation in computational design, which is kind of a hot topic, and I think there's kind of a lot of ways that that people are implementing automation and thinking about it right now. So to start, I'm with a company called Stantec. We're a little bit on the larger side. There's 22,000 of us, and we're kind of spread all over the globe. So we have kind of an interesting, we have some interesting kind of benefits in terms of having that sort of reach. The specific team I work on is the practice technology team, and we're an interdisciplinary team. We tackle a few different areas. So the area that I work in is, of course, computational design. We have advanced visualization folks. We do some data analytics work. We've got guys doing geospatial technology, and we have developers as well working on digital solutions. And I'd like to give a shout out to Holly, who is the lead for practice technology at Stantec. She's sitting right there. So today I'll be chatting a bit about how we could maybe increase engagement and impact of computational automation, identifying through some examples of where to incorporate automation in our workflows, some lessons learned. So as I go through the examples, kind of chat about what I've found in those experiences. And then we're going to try, as a group maybe, and I'm sure through the discussion we'll assess the value of knowledge being automated and talk a little bit about risk, because a lot of the time when we get pushback from folks, I think it's this risk discussion that's really kind of getting us there. And then automation, it's kind of a fun, great topic, because what I can do is sort of tap into everybody else's topics a little bit as well. But you can use automation for a number of different things in your workflow. So we're talking about coordination, documentation, interoperability, design metrics, process, and you know what, the list probably goes on. So I'll be organizing my presentation in terms of these different categories. So when I think about automation, I like to kind of plot it on a spectrum. So there are automation that you can do for tasks. So these are these little piecemeal guys that are really kind of discrete. They're the low-hanging fruit often. They could be these tasks that people aren't really that interested in doing. And they're typically a little bit lower investment and typically, a decent return, but they're these little kind of tiny low-hanging fruit. And then you can push all the way into methodology, and this is where you take an entire problem, you unpack it, you set all of your constraints up, and then you can run out your entire program computationally. And this often takes quite a lot more investment, but the payoff can be kind of massive. So I think when we talk about automation, I like to kind of think about where I am on the spectrum, and that can maybe help me decide whether it's a good problem to tackle from an investment and return perspective. So for coordination, so it's one of the areas that you can potentially look at. And I want to use this as an opportunity as well to talk about how we collaborate with our partners. So I was working with a fellow named Justin Barron inside of the Plano office at Stantec, and he's, dealing with a lot of ductwork going through walls, which is something that, happens in every building. So he put together a bit of a script in Dynamo to start to, automate some of the coordination aspects. So basically, we're just punching holes through walls. And I kind of took it a little bit further, but we're taking this linked model and kind of, using Dynamo to build a Dynamo player app that's actually quite user-friendly. And then we can just pick out little chunks of this model and then push them through the walls and then set an offset as a parameter. So this really helps him kind of do his work more quickly. And again, it's one of these dumb, easy tasks, sort of, just get it done. Documentation, that's a big piece. We still do drawings. We're probably going to be doing drawings for a while yet. So it's one of these areas where the innovation has kind of a direct potential return. And on the topic of notes, which I think was mentioned before, there are definitely some opportunities to take this, again, really grindy task and just take a little bit of the pain out. So we take an Excel spreadsheet, and kind of template out a building typology in terms of the annotations you might have on that building. And then we pull that all in to Revit via Dynamo. Then we're able to place these. It might be nice if you have junior staff to have kind of this templated note database so that they can look for things that are similar and they're not having to generate the wording for the notes right off the bat. And then we can use the tool to clean up all of the notes that we haven't used and then renumber them. So the idea is not that we're, computationally annotating an entire plan, which, maybe we can get to one day, but we're taking kind of a painful, arduous task, low value, and automating it. And actually, by going through the process of automating it, hopefully giving somebody their day back so that they can spend it doing something a little bit more inspirational. I work a lot with infrastructure designers. And we've been looking at doing parametric bridges, which is a really awesome problem space. Something that we've been working on right now is figuring out how to relate different structural elements to the roadway geometry, which is often kind of on the complex side. So you might have a super elevation, and that's where your roadway is tilting, perhaps along a curve, so it can be a doubly curved surface even, potentially. And what we can do here is as we place these components in plan, we can read that roadway geometry, and then we kind of suck all of the girders up into the correct location with respect to the roadway. This is, I guess I put this in the automation of documentation section because in order to really document this stuff, sometimes you have to model it. So by building a modeling tool that just automatically does this, it gets us closer to what we need from our drawings, basically. And then also in terms of kind of doing it this way, when you have new input data from your civil engineers, for example, your coordination time goes way down because they're just able to give you that new information, and you have your process already set up so you can press the play button again, and all of those girders are going to reorient in space and snap to the roadway surface. So interoperability is another big one. Nobody likes taking design models and remodeling them in Revit. And this is something that people have been tackling for a long time. There's some really interesting technology out now called Rhino Inside, which I've only been able to play with a little bit, but I think it's quite exciting, so that's why I'm putting it up here. But the idea of taking these polyline models, running them right through Revit inside of Rhino, so basically linking those applications together on the inside. It's really neat to see the potential here for a schematic design model moving into a documentation model with zero model drop. So all of these walls are unique, clean items that can be used for your documentation model, and you're still able to edit it kind of on the schematic side in Rhino. So design metrics. And part of the reason why we want to look at automating design metrics is because doing these calculations in sort of a traditional fashion can be quite time-consuming, and getting the input really quickly, as has been discussed already today, can help us get to our design decisions faster, and it gives us better design output in the long run. So again, kind of on that collaboration topic, was working with a young designer in the Vancouver office, and this fellow works on airport design, which is a really interesting problem space. So when we're doing airport design, we need to consider what the folks in the air traffic control tower can see. And we need to make sure that any specific geometry on site isn't being blocked by our building massing. It's a really dumb problem, guys. This took like an afternoon to put together. This is why I'm talking about low-hanging fruit. But basically, working with Adam, this fellow, we just developed a quick dynamo solution where we just create a surface that kind of sweeps along that road and intersects his massing model. So he used to draw a section through the site from the building to the control tower, which took some time. But now as he's massing, he can run this thing and take a look at how he's doing in terms of blocking the view. And the thing is if you miss this and you miss it for long enough, you're really gonna torque the client when they find out that they actually can't make their plan as large as they might want. So it's really good sometimes just to get this really dumb information nailed down early on, and tools can help us get there a little bit more quickly. Glazing ratios. This is another really, really silly one. So when we have all this lovely information in our Revit model, we should just use it, right? So my coworkers put together a nice script just to take these ratios right out of the Revit model. But I do want to say, when we're doing these sorts of analysis, we have to be careful about the quality of the models that we're using to drive this information and making sure that we understand where our kind of information is coming from. So, for example, if this wasn't set up correctly, and they're maybe pulling information from other parts of the building that they don't need to be, it could potentially be problematic. So there is always a level of rigor that the person potentially using the tool needs to employ to ensure that what they're doing is sort of being calculated correctly. And there's always a bit of a back checking that needs to be done, or at least, kind of a litmus test or a gut test to say, hey, do these results make sense? Are we getting what we want? So this is using Flow UI. And this is a project that I've been working on with some students from Simon Fraser University. So because designers really like making massing models, I thought, well, maybe we'll just let them do that. And then we'll take the calculation off their hands. So this project it basically allows designers to work in Rhino how they might anyways. And then we're just going to slice and dice this guy and get some metrics out onto a dashboard. And we can kind of change this dashboard if we need to, depending on what we want to see. But it really allows people to kind of get in there, get their hands dirty, work how they're familiar with, and then get some output really quickly. So they're able to mask this thing up, get quick numbers out. Again, really dumb. We're just intersecting planes through boxes. That's all we're doing. But it's getting us metrics, and it's getting us to our design more quickly. And then we can also drill down into the model as well. So you can kind of bake a little bit more information sort of on the building scale. And then this way, you could potentially use this in a client meeting, and they could say, okay, well, building X, how are we doing in terms of floor plate? You could kind of go in there and give them a sense. So process. So this is kind of on the methodology end of the spectrum. This can often take a little bit more horsepower to get you to a solution, but can really tackle kind of an amazing amount of work. So this is a slab detailing project that my coworker Chinthia has been really mired in for quite some time, and she's doing a fantastic job. And what she's been able to kind of accomplish here is kind of doing a proof of concept with a visual programming tool, so Dynamo again. So she took this tool, she went to engineers, she began to understand deeply what the slab detailing problem was. So they drew a lot of diagrams, and they really kind of unpacked what the engineering sort of methodology was behind this. And then she started to encode this in a series of scripts. And then then you can run this thing, and what it'll do is it'll work on this methodology, and it'll get you to an answer. So this guy's running, and then it starts to populate this slab with the rebar information, and then also apply Revit families. So what you can do is you can really kind of build out this model, and this is happening, the click of a button. This is something that would really take an engineer, potentially half a day to do one slab, and we're able to rip through these slabs in about 30 seconds. Yeah, so not too bad. Again, high kind of a value output. The thing that's a little bit trickier about it is because it's a methodology, the engineer whose process was encoded is kind of deeply embedded in that tool. So if a different engineer had a different methodology, they might not be as interested in taking on that specific tool. So right now we're working on ways of kind of breaking this thing out and allowing those separate engineers to sort of bake in their methodologies. And we're just kind of seeing how it goes. But the intention here is that we can get a tool that folks are comfortable with using, that they understand enough about how it works. And another piece in terms of getting that understanding built up is actually providing different checking steps throughout the process. So you can actually export the data and evaluate it so an engineer can kind of back check and look at the entire process so that they can feel comfortable with the results that they're getting. So the issue of the black box, I think, really speaks to that risk problem. So when you approach someone with an automation task, it's something that they may feel a little bit threatened even that you're even kind of going there, because you might be challenging their methodology, and they might not understand what it is you're even really trying to propose, because the process that you've created might seem kind of alien to the way they work or the way they understand a design process. So I find that when you're collaborating one-on-one with folks who are bringing you their problems, if you're able to work on those problems together with them, this issue of the black box kind of goes away. And another nice added benefit of that is that they actually learn how to do it themselves. So whenever I can collaborate directly with somebody who's interested in actually picking up the tool, I think that's when I found the most success. So increasing engagement and impact. It kind of starts with education. So what we do at Stantec is we have webinar series, and we kind of just reach out to the company. I reach out to collaborators who have interesting projects that they're working on, interesting stuff that our team has been working on, and then we just do a little bit of a session where we present the work basically and just show them kind of what's available and what's out there internally. We also bring in presenters from outside as well, and that's been quite successful. Yammer, it's like Facebook for work, sort of. And what this is really useful for is kind of reaching out to that network. So let's say you have a successful collaboration with a number of people. What you're actually doing is you're building a network of computational design experts within the company, and these folks can all start riffing off of one another. And Yammer is sort of the platform that we do that on, and we kind of envision getting a little bit more participation in Yammer. And in a perfect world, I could see Yammer really being kind of a hub for folks to start talking about these topics together. We've also been testing out the innovation marketplace. So Stantec being so large, multidisciplinary, and with a lot of large companies, we also struggle with different areas being siloed. What we're trying to do is bring all of this information, all of this kind of horsepower together into one space, where folks can kind of query this space if they have a problem that they're interested in solving. And potentially they can take something that another team has already developed, or maybe they just get some ideas, or maybe they can take a prototype of somebody else and develop it in a slightly different direction. So we're excited to see where this goes, and we hope that it provides a lot of cross-pollination across the organization and allows us to sort of leverage and skill up folks and get more people using automation at the organization. And that's all I have. Thank you.
Everyone, thanks for having me. My name is Dane Stokes. I'm a design technology specialist with ZGF Architects. And the brunt of the work I've been doing for probably the last 5 or 6 years has focused on using computational design tools to build automated tasks and to expand our capabilities as an architecture firm. I'm glad you went ahead of me because I think we saw a lot of great uses for automation. And I'd say at ZGF we kind of have a similar toolbox of tools. And my job really revolves around creating and managing computational design tools and trying to get architects to use them. And we have about 600 or 700 design staff. And it's an interesting feedback mechanism to be the salesperson and see what sells and what doesn't. And I've noticed that I can get people to renumber doors automatically all day long. But when it comes to more complex tasks, we start to see kind of a commonality in a lack of adoption. And I'm not gonna really show you a lot of our work today. I'm gonna kind of look at the industry and the current state of affairs when it comes to automating complex tasks. But first, let's start with some history. For about 4,000 years, and well, 6, 10, however many thousand years, on the far left, you see the first plan in the fossil record of architecture that we still have. And it's a piece of clay with a plan manually scribed into it. And we can go all the way through until, you know, the 80s and the end of the last century, where while the tools may have changed, the act of manually creating something really didn't. And we talk about automation a lot as a future conceptual thing, but I'd argue for the last 20 years, a very large portion of our industry has been automated. So we can look back at the last 20 years and kind of see how that's changed, how architects interact with a product, and how the product itself has changed. I think we can agree that, you know, the act of building something is not the same as the act of receiving something. And what we see in an automated process is that architects are still doing things. And then there's all this knowledge, you know, these thousands of years of how to make a plan that is put into this box, and then a thing comes out. And there are a lot of advantages to that, and there are some disadvantages. So some advantages is that we expand the ability of people to have accessibility to a process that might be more complex. Typically with automated processes, we see a very limited amount of parameters that go into the process, for example, length and width. And all of the act of space planning in this example is done automatically. It's easy to use, you can do it really fast, computers are super fast at doing lots of stuff, so we get a lot of iteration. But the downside of it, since we've loaded all of this knowledge into a tool, we no longer have control over that process. We see reduced design flexibility, and that isn't a criticism on the tool, it's just the reality of that delegation of knowledge and process to a computer system rather than ourselves. And we see a lack of diversity because when we lock in a process, you know, you're not going to see a circle come out of this because it wasn't programmed to make one. And that's not a problem, but a lot of times when I'm trying to get people to take advantage of an automated process, they'll throw me a wild card at the 11th hour and they'll say, you know, they won't talk about something for a really long time and I'll have the tool all set and then they'll be like, oh, but can it make circles? Like, we didn't talk about circles. I spent all this time making the thing that makes the rectangles, and now we're talking about circles. So there's this, you know, I think, you know, we've all been there. And we see a reduced product quality. And I think that's kind of a loaded statement, so I'm going to dive into that a little more. If we ask the simple question, who's responsible for product quality, in 1898, it's that guy, because the plan is the thing that he's making. But if we look now, you know, who's responsible for product quality? If you asked every partner in our firm if they're happy with the quality of drawings we're creating right now, they'd say no. And if you asked every architect that's kind of responsible for those drawings, they'd say that Revit can't make good drawings, which I think is BS. Like, I've seen Revit make good drawings, but there's the process is somewhat clouded now that we have a middleman. So let's look at who might be to blame here. Maybe your architects that are coordinating on a building information model don't have the proper software training, where their behavior is not creating optimal results for the automated system. Or maybe, you know, they're hacking something together, or you don't have firm standards where they can create a desired effect, but that hasn't been distributed. The goal hasn't been distributed widely. But I think a lot of what we see is an unwillingness to modify a product that's been given you, or a lack of ownership over the product, where you could go in and fix it, but it's a lot easier to just say that Revit can't make drawings. And you also, the realities of an automated system is that you do have limited control. Maybe it is the fault of the software in some way. Maybe you can control it properly, but the tools with which to control the product are too hidden that it's not obvious to any user. Or maybe it's just optimized for efficiency. It's better to have something that a lot of people can use that creates a lot of things, but maybe the fidelity of that product suffers. Or maybe it is just straight up that it's coded wrong. These are all very viable reasons, and it's not one or the other, it's kind of all of them in different ways. So we see a muddied process and kind of a separation from ownership of a product. If we move on to automated iteration, we also kind of see a separation from the problem. When I started at ZGF, I actually started in our model shop. And I had a team come to me, and they asked me to build their study models for them. And I said, why? Because it was a study model, and they were supposed to learn from it. I would learn a lot of things, but I'm not on an architectural team, so why are we doing this? The point of iteration isn't to produce a lot of things, it's to solve a problem multiple ways. So not only do you get a lot of solutions, but you understand the problem better. The delegation of solution generation diminishes our ability to gauge product success. And again, our iterative variation is limited because we're focused, the process has been codified. You're not gonna say, oh, all of a sudden I want circles, because somebody spent a lot of time building a thing that makes rectangles. I'm gonna stop picking on other people and pick on myself. This is probably the most complex thing I've automated for ZGF, and it was an entire building. And somehow this thing's actually getting built right now. I think they're up to floor 7. And I'm proud of what we did here, but it showed a lot of faults in taking automation to this level. This is very clearly a complex problem, a complex process, and it's fair to question whether you're just trading one complex process for another one. And you're trading one complex process that a lot of people can do to a complex problem that, like, just I can do. Out of our 700 architecture, people, if I had been hit by a bus, this team would have kind of had to start over by hand. And that's a very large liability in process.
Job security.
Oh, tell me about it. And I think we see with a lot of automated tools, you might buy a tool and you can just blame, like, oh, they didn't build it right. But I was sitting with the team, and I could design in whatever we wanted into this automated system, but it was still, it still didn't have good design flexibility. You'd have our design principal come by and start throwing crazy ideas out, and I'd get scared because it's not just a matter of modeling it. It's a matter of, nudging the Rube Goldberg machine a little bit and see if it can take a new cog somewhere. And that's stressful, and it's legitimately dangerous sometimes. And I think there is a reason to question the time savings of this, because while we were able to create a lot of iterations, what was the real value
of creating more iterations. I'd argue the building doesn't look that much different than it would have if we'd done 2 iterations or 3 iterations. It was a fixed enough concept that we were able to automate it. Therefore, it really wasn't going out on a limb in either direction. And as we talk about time savings, I think a lot of you have probably seen this diagram floating around. I've certainly used it in my propaganda. And I don't think it's necessarily accurate because it gives the impression that everything you automate will take less time than the task you're automating, which all of my favorite tools are the ones that are 2 or 3 nodes because it's a dumb process and I can whip it out fast and it's, it's easy. I could rebuild that graph every single time someone wanted it and we'd still save time. But this is a very rare occurrence. A lot of times tool development takes a lot more time than the process does. So in order for it to be worthwhile, they have to be used repeatedly. And this is actually a significant problem because using something repeatedly means that I have to get 600 or 700 people to know that the thing exists, know how to use it, understand how it works, and to add to that, our firm doesn't have studios. So you could be on a hospital project, then go to high-rise residential. So we have a lot of staff moving all over the place. Our Expedia project, I think it's 1.2 million square feet. It was a 60-person architecture team. And just knowing that a tool exists was unbelievably difficult to convey to people, especially with them moving around. AI was brought up around here, and I think there's kind of an interesting, we're looking towards the future of AI as this magical thing, but and I think there is a lot of potential there, but these problems don't disappear. We still don't have control. There is still a black box logic. If you had a generative adversarial network that you trained on your own work, think of if we had GAN in the 1970s or 80s, and we put all of our knowledge into it. Think of how much longer wood paneling would have lasted in our industry, because we would have been fixed into this direction and we would have invested heavily in it, right? So there's a lack of flexibility and an unwillingness to be adaptive when we invest heavily in something. And finally, I think we should look to other industries. When we automate something that is very crucial to a task, I think the first thing humans are going to do is fall asleep and not care about the product itself. So we see, with Revit, people design, our architects are blaming Revit for an inferior product rather than working harder to make sure that it works better. Tesla drivers are not suddenly incredibly engaged in driving. They're falling asleep because they don't have to worry about it anymore. So I think as we move forward with the automation of our industry, it really is a balancing act. How much knowledge do we want to codify in exchange for flexibility? And when is it perfectly acceptable, and when is it a benefit? So thank you for letting me ramble at you, and it's been a pleasure to be here.
Thank you both. This is excellent. I think it's fascinating for the people who've been coming to Building Connections Congress for the last couple of years. We went through this whole cycle of automation is amazing, and now we're back to maybe everything shouldn't be automated, which is a really interesting perspective. So I appreciate that. I'll open it up to questions. Thoughts, comments?
So with Charlie Portelli, Thornton Tomasetti, so I've kind of relayed quite a bit to what you just mentioned, Dane. In one of the classes I teach, we have to go through an entire drawing set, have the students create an entire drawing set, and we forget first principle fundamentals. We just simply don't have time to go over them. So now within the professional environment, do you feel like we are we've gotten to a point where we, as you just mentioned, automate, and we've automated to a point where we've forgotten first principle fundamentals, and we actually forgotten intuition, which was the comment, the kind of focus of the previous talk, and that we're at this stage where like we actually need to, take a step back and remember what those fundamentals are so that they can still be instilled as part of the automation that goes forward?
Yeah, I mean, I think that's an interesting question. I think, again, if we look to history, we look at the arts and crafts movement, I'd argue that we've been here before. And there is a risk of isolating knowledge. It's not good for selling automated tools, but there is value to a lot of people knowing how to do a thing rather than being dependent on a process that you don't necessarily understand.
Paul?
Yes, oh, was it you? No, please. Okay.
Then Greg. Hi, Bob Uri from EDSL. So thanks to you both for your presentations. I guess, Alyssa, this thought came across my mind when you were presenting about sort of developing these tools and obviously sort of encoding specific knowledge, perhaps by an individual who likes to do things a particular way. I think the rebar example was what you were talking about. We've talked a lot about moving away from these monolithic tools to sort of these more toolbox-based approaches, which means there's a lot of glue that needs to happen. And I think computational design, there's a large part of that in certainly larger firms that embrace that approach. I do begin to wonder, though, if that means that the future of a computational designer is less sort of that computational hero who can't get hit by a bus, Dane. I begin to wonder if that means that the role of computational design will really just be developing custom tool sets for every single person in the office.
I mean, as in every single person would have their own kind of toolkit that they would use?
Well, I'm taking this to probably an absurd extreme, but, let's say you've got 10 engineers and each of them likes to do their rebar differently. What do you do?
I mean, maybe this isn't everyone's idea of a perfect world, but I sort of like the idea of a professional having the ability to automate their individual processes. And I really like the idea of folks having a deep understanding of what it is the automation is doing. I know there's a risk in terms of giving someone a tool. It'd be like giving me a structural analysis tool. Like, yeah, I could make it run. I could make the pretty colored diagrams, but we'd be in trouble if I was the one telling you, how big all of your members needed to be. So I think it's important for folks, and however we figure out how to do this, for them to really be ideally engaged in the development process and like really understand what the tool is doing. And maybe we do that through documentation. Maybe we make, learning how to do some of this stuff a little bit more mandatory. I think this is why visual programming as an approach, rather than just hard scripting everything, actually potentially offers us a little bit of help in this area because it is something that is more accessible. So your run-of-the-mill engineer or architect can likely get into it and learn it. Whereas if we bake everything into a hard-coded application, that can be really difficult to sort of poke at and understand.
Ideally, I think you'd see everyone being responsible for making their own automated tools so that there is still a responsibility and an ownership of the product. But even with visual scripting, the bar is still very high relative to a typical architectural staff member. I mean, adoption rates of 10% are astounding. So, yeah.
I would just make a comment. I come from working in a professional software company and at computer-aided design, and the ratio of quality assurance staff and documentation staff to programming staff, and so that's setting aside all the marketing guys and putting them over on one side, just forget it. But just the technical people, it's about 40 to 50%. So so take your engineering staff and then half again as many people for QA and for publications or technical documentation. And so that's kind of the professionalism piece, you know. So you have a choice. You can either write the documents and debug the software and make a product out of it, or you can train everybody to be a programmer. And they both have a social cost, and you get to choose.
Well, I have a question about that, because it seems to me that, sorry to say, I've lived long enough to see people who are using and doing analysis by hand with, you know, various different mathematical series of, you know, steps where that's all automated. It became automated when we ended up with calculators. Nobody's going through, you know, the charts and saying 6 times 7 equals such and such. You know, it's there. You're not trying to reinvent that wheel. And I suspect a part of what this reluctance to trust the computer computational is that you're dealing with highly professional people who have not used it in their professional lives to date. Whereas, you know, once the new crop of kids come through the education system, they're used to these tools being right. You're not telling people they can't use their iPhones in tests. I mean, you know, they do, and they give answers. So yes, it's important for people to know some of the basics, but, you know, you don't go back and have to redo all that stuff every single time. It just doesn't make sense to me if you look to the future.
I think the reason the calculator is an acceptable tool is because it gave the results that we wanted. If you had a calculator that gave you the value blue after you put numbers into it, people wouldn't use it. So there's a fidelity within the tools we do create, because essentially we're creating hundreds of individual calculators, and some of them are incredibly, you know, popular, and some of them have 1,000 buttons and produce only colors, and that was a problem for one time, and we're never going to do that again. So it depends on the product, I think.
And it depends on the problem too, you know, like if you're trying to automate something that is really dumb and really easy to sort of pull off and maybe just do it a bunch of times really fast, then you can feel fairly confident that that thing that you're doing that's like 3 or 4 nodes, that is working right. It's when you've got these large spaghetti projects where things start to get a little bit foggier and more interesting, but foggier potentially.
Okay, so me now. This is Greg Seaton from CSI. I thought this whole conversation actually was really interesting, and I wanted to ask about, more specifically in each of your firms, what steps have you taken or has the firm taken to begin the possible concept of this idea of a distributed tool set that would be individually personalized? Because, and the reason why I ask is not because I think coding is particularly difficult. I mean, it can be very complicated, obviously, but when I look at the audience out there for video games, and how many people can build environments and or macros in video games using very simple scripting language, and these are not programmers, these are just average kids, people, not even kids, adults too, even us old fogies. So, you know, I think there's a possibility, and the other thing that goes to the risk equation and the idea of the black box is the notion of you're automating a simple process where you have a certain set of expected outcomes, right? I mean, it's not a black box for you if you do the scripting, right? It's a clear box. And when you build the script and you get errors, you fix the script. And if you build the script and you get things on the drawing or on the model that are not supposed to be there, moves all the pipes the wrong direction, whatever, you say, did that one wrong, let's try that again. You know, so I think that there's a certain value both in terms of mitigating the risk question and acceptability of this by looking at the intuition and the spread knowledge around things that are not about the programming. But anyway, back to the question about distribution of this process throughout your firms? That was really the question.
Well, we're at a stage where we're really, I think one of our goals is really to empower people to feel like they can get into this stuff and ideally, leverage it in their own respective practice. So we are working on frameworks for how to do a larger scale tool distribution, but at such a large organization, that's a really different problem than at a small firm where you have a lot more control over what people are doing. So in my mind, it's really about giving people the opportunity to try stuff and to learn, and then we're kind of a backstop, so we let them get started, and then if they hit a roadblock and they can't really figure out what the next programming step is, we hop in and we help them out. But yeah, we're still figuring it out too.
I think there's a gradient of success. Obviously, training is important. We have a lot of staff that can build their own tools, and you see that you see the value of that. But the reality of it is a lot of people aren't interested, and they don't need to be interested in it. They went to school to be architects, not coders, and just give me a button to push. And that's valuable too, and I think we do both.
Anthony Houck from Hypar. First, if anybody's interested in this idea of the degradation of human skill when encountering automation, I'd recommend a book called The Glass Cage by Nicholas Carr. But my question is, given this idea that maybe professionals start either crafting from scratch or altering existing tools to capture some of their expertise, is it possible that we're just at the very beginning of a phenomenon where in the future, like I get my energy analysis and my structural program and I choose it, off some catalog, like I get a car or I buy a garlic press, and I'm basically putting together an assembly of things that either are recommended or come from my firm that come to a result? I mean, is that something with these kind of targeted tools you guys are starting to talk about that you would foresee, or do you think it's going to go in a different direction?
I think that there's a really interesting conversation to be had about liability. So if I'm an engineer or an architect and I'm offloading my liability onto a tool, but my stamp's still on it, it's like, I think that's an interesting tension. So if you're saying, well, I'm actually going to let this tool do the code analysis for my building, and then I'm going to put my stamp on it, well, like, who do we sue now if something isn't right? So I think that, just like with the construction drawings problem and the idea of like this contract and liability, I think there's also liability in terms of offloading certain architecture or engineering tasks onto a tool.
On the other hand, though, I think there's a lot of value to having the capability to tap into a lot of minds. It just depends on what kind of tools you leverage and how much liability is associated with the product, probably.
Next. Go ahead.
Oh, sorry.
That's on you.
It's green, it's red. Okay. Hi, Praddy from David & Schwartz. I had a quick question in terms of getting people to use it. How do you, like my firm and me are definitely quite young in the process that we are going for the low-hanging fruit, quick tasks, but how do you find which to automate? Does a request come to you? Do you walk around peeping over shoulders like, hey, you're doing that too many times? Or
yes.
Like, how do you identify?
Yeah, I mean, we hired someone that was working remotely to build computational tools. And we figured, whatever, we'll tell him what to do. And we fired him rather quickly because it wasn't that he wasn't qualified, it was that he wasn't talking to the people that would be using the tools every day. I will walk the halls of our office and I'll see someone doing something redundant and dumb and ask them if they're enjoying themselves. And they say, and they say no, and then I've got a new thing to build.
And so if they say yes?
And if they say, yeah, that's another question altogether, isn't it? But I do think you have to be you have to be close to the people you're building tools for to really understand the problem that you're solving for them. And then, yeah, at least your success rate will be higher. Sometimes I'll sit with a project for a week, so I can just kind of mess with something and just have a conversation about it rather than going back to my desk and building something in isolation. So I think communication is really important.
Yeah.
Violet? Sorry. So I think you all are provoking a really important conversation, or obviously it's coming up. One thing that you were mentioning, I think we're having this discussion, which is we're at this moment, are architects and computational designers and people in fields related, are we writing replicable products and software, or are we using tools to build custom scripts? And to what degree do we make things replicable? And I keep thinking about the microservices movement and the if this then that and the end user programming, where I don't know how Grasshopper works, I don't know how Python works, but I can make this kind of nice bucketed script. I can develop things that are shareable, but someone had to write the kind of engineering robust background program to accept that. And maybe that's also architects, but it seems like there's kind of you develop, on one side, someone that's developing the if this then that of architecture, or a suite of scripts, and then there's the kind of development of macros and microservices. So I'm just kind of curious with that analogy, how do you see things playing out over time? You know, do we continue to see this kind of ecosystem of macros, and should architects be, how do we think about replicability and sharing those kind of scripts?
It sounds like you might something to this. It sounds like you might be talking about sort of the logic and the design question, right? So the macros are sort of maybe design questions that you're answering, but there has to be a robust logic under it. Is that thoughts on that?
Yeah, I mean, I think that the architect or engineer ultimately is responsible for what the tool is trying to do, and hopefully can work with somebody to prototype out that logic kind of stream to get to some sort of result that is useful. And then ideally, if the thing that you made is really great and really robust and people are really into it, you can hand that to a developer and get them to really kind of run with it and build something really robust. So I think it would be really interesting to see where we are in a few years and how many, and firms are already starting to do this, but like pairing directly with folks who have real development chops, because you don't graduate from architecture school, even if you have an interest in computational design, being able to write software, like probably not, there are a few people out there that can do that, but it's not a very common sort of thing. So I'm interested in how architects might be able to collaborate with folks who do know how to write robust applications.
Yeah, you always see a separation between the people that are able to make the thing and the people that want the thing. I'm working in the same office as someone, and that separation alone, I'm trained as an architect. That doesn't matter. There's still a separation between the two of us. One thing I will say is we learned very quickly that while I do serve our 6 or 7 offices, it's important to have boots on the ground so that you're still having face-to-face communication with someone, so that you don't get that separation of problem and solution, no matter what the tool is.
See.
Ryan's opening presentation, he talked about the 10,000 hour rule. for good or ill, but the time on task it takes to develop a real facility or skill around a tool. There's some tools that, the calculator that we have now, it's well-bounded, the problems that you can put into it and the problems that can come out. I think about in the use of analytics, daylighting simulation, the frightening thing was exercises when I gave 4 staff members, after having them trained in daylight simulation, a set of plans and said, enter this room into Revit and run this daylight simulating tool, and we got 4 different answers for what that, because the subtleties of how the tools worked, the tools were not sufficiently bulletproof. Now, nobody died because they got, one of those 4 answers was pretty much right and field verifiable, but no one died because of that. When you start saying, here's where the rebar is going to go or not, it's going to be a different level. And so I think in general, the challenge with tool diffusion in a firm is that, A, they need to be motivated, so it needs to be, the Paulo Freire pedagogy of the oppressed. You need to have the strong desire to learn that thing, so you need that answer, because if you train them in it and they're not using it 2 days later, that will go away. And B, a lot of tools require a certain amount of time on task. And so the time on task to use a calculator, the training is minimal and I get the answers right away. When my wife, when her office went to an internet phone system and they scheduled a 2-hour training session for her to use that phone, that's when she stopped using the new office phone, right? And so when we talk about the tools and the level of training required to get at the capability and get a valid answer, how do you, I think you both have probably explored this in your firm, so I was just curious your sensibility about how do we get the right level of tools in the right people's hands so that they're getting meaningful results?
Yeah, there's certainly, you have to cover all your bases. I mean, we have a lot of tools that you just need to know it exists and know how to push the button. And there's certainly a place for that. And but you touched on an interesting thing with the analysis. We saw a really interesting thing happen when we started using more computational design tools. It was the assumption that the computer was right, when in reality it was just me behind the the Wizard of Oz curtain, just pulling strings. But I'm not right. But it went through the computer, so then it must be right. And I think that's a very dangerous thing that as you're spreading tools, you need to be cognizant of.
Yeah, it comes back to that assumptions kind of statement from this morning. It's really important that those assumptions are really clearly laid out. And ideally, whoever's using the tool kind of knows what that back end, is.
Time for one last question back there.
Karen Timberlake, again asking maybe the similar question to different people, but so we talked about I think a 1-hour time frame for answering questions and a day time frame for answering questions and building off of these. Oh, okay. So an hour and change. And that's to answer the question, not to build the tool to answer the question. So building off of Z's comment, and in particular, especially with a larger firm where design computation roles are starting to hopefully take on management aspects, how do you approach planning? So how do you, and I'll also kind of jamming on Violet's, I think, question about the generalizability or how you tools you actually use on more than one project or more than one question, right? So how do you plan, or are you afforded the opportunity to plan, and how do you work within your offices to kind of maybe preempt certain questions that are going to come up?
Half of it is knowing the architectural process enough to know what the low-hanging fruit is, and a lot of it is telling the project that asked for a tool that you won't help them, but the next project is going to thank them for it. So you have enough time for development, and you understand, it's something you wouldn't have found on your own. But there is a reality of development time, and if it's worthwhile, thanks. In a year, you'll thank yourself because we'll have something. Yeah.
Yeah, we like to give folks an opportunity when we're reaching out to them to have conversations with us. And typically before we even really start an initiative where we might start developing a tool, we'll be kind of trying to hash out a problem that they know would be repeatable in their specific problem space. So, and then what we say is like, we'd like to test it on your next project, but like maybe not even implement it, right? Like we just want to have an opportunity to sort of vet this thing. You know, so yeah, so it's kind of about nurturing those relationships with the people that you're working with, you know, especially when you're kind of separated out from practice a bit. It's about nurturing those relationships and having good conversations with them to get to those elements that they're interested in solving.
Well, thank you both. I wish we could continue the conversation, but we have some more great sessions coming up, so I don't want to shortchange them. Round of applause for them again. Thank you.
All right, so this podium is way too short. It's maxed out, all right. So we got basically 1.5 more sessions, we can do it. So this last session is kind of like a bonus session. I got an email from Brian Kraus, who's gonna speak, talking about how he's using computational design in construction. And I was like, really? Does he really even know what that means? So I talked to him, and turns out he really does. So he's crushing it. He's doing awesome work. He's the vice president of Clark Construction Group and also as a company, Coda. And the first speaker is Rob Otani. And if you don't know what he does, you may have used some of his tools. He's recently released Beacon, which is an embodied carbon tool. He's the CTO at Thornton Tomasetti, and they've created a lot of cool tools. And he founded the Core Studio, which is their kind of R&D group in his firm. So.
Thanks, Ryan. Is my slide deck up here? We'll have to find it. Okay, thank you. Thanks, Ryan. Thanks, AIA TAP, for having this event. These are topics, it's kind of really cool, actually, because these are topics that are sort of come up every single day for me, and I think for our industry more and more. And so today I'm going to talk about integration, and I was very specific in adding the C. Normally we talk about A and E, but I want to make sure that we add the C, which is why Brian and I are going to talk about today. And a little bit about myself. I've been a structural engineer since 1995. And so just to paint the picture, at 1995, we had 3 computers in the office for about 70 people. And so we would do a lot of calculations, hand calculations at our desk. We'd run to the computer, do some whatever programs we had, there's been before, write down the results or print it out, come back to our desk, give those results to mark up a drawing, give that drawing to a drafter, and then go back. So we've probably spent 90% engineering, probably 10%, let's say, documentation. I would argue that we probably do 50%, again, these are numbers that are coming out of my head, but 50-50, 50% engineering, 50% documentation. And the reason is because we do much, much more than that today. And so just a little about the company. We're a relatively big company, 1,500 people, many offices. We do a lot of complex projects. And another thing I should mention is I worked on the first Revit project. At the time, I was at Arup, and it was very painful. It was in 2006. And so, but it was also very powerful. So I got the combination of being very frustrated, but also very, so I had a promising outlook of what it could be. And we have a lot of practices. So the core, as Ryan had mentioned, we have to build a lot of these tools for various engineers and architects in the office for a variety of practices and workflows. And this is just the learning objectives I had in the presentation, so I want to get through that. But this is a good a graph that came out of McKinsey a few years ago, and you know, you can see the construction industry, of which we are all part of. We are the catalysts, the designers, myself, that sort of feed the construction industry and what they do. And you know, 95, as I mentioned, I started my career in 1995. We were doing hand drafting, some CAD, and you know, sort of very clear workflow and delivery of documentation to contractors. We issued 2D documents, that was it. And so there was sort of a known gray area of what needed to be interpolated from those drawings, but also figured out by the contractor as they start to do shop drawings, fabrication drawings, erection drawings, logistics, et cetera. And you know, in 2004, and Holly corrected me, it was probably earlier than that, and Anthony probably knows as well. It was probably earlier than 2004, but that's the first time it was introduced to me anyway. In 2008, Thornton Tomasetti went 100% BIM, which was probably an early adopter in 2008. But you can see it didn't help our industry. I mean, we have all this really you know, smart information that really didn't help us a whole lot. And so why hasn't our industry sort of leveraged the same technological prowess as the rest of manufacturing? And I believe that there's sort of misalignment of the technology that we have today versus the standards and protocols that we are still delivering to today. And so this is my, my analogy. You know, our standard of care was developed, you know, for 2D documentation. I'm going to say the early 1900s, you know, first building codes around 1900. But today, you know, we have way more than that. It's ridiculously more powerful. And this, there's no science in this information here that I put here, which I kind of compared hand drafting versus CAD versus BIM. This is sort of my own experience. But, you know, the time it takes to produce drawings per se, is way more today. I mean, I would say 3 times as much time. So the fact that, you know, there's a, you know, like a lot of the older folks in my office say, you guys are taking too much time. Well, we're doing like 3 times as much work, actually, right? But I also feel like, having seen the automation session before us, that we can deal with that. We are creating a bunch of tools. We're creating we're creating models much faster, and documentation. And you know, around that same time, you know, when CAD came along, even we produced many, many drawings. So my anecdote there is, the Hancock Building in Chicago has 25 structural drawings. When we, as Thornton Tomasetti, designed the New York Times building, and I don't know how many years ago it was, probably 10 years ago or so, maybe more, we had 150 structural drawings. So did we need all that information spread out across all these drawings? It actually just made the work of the contractor much harder, because they had to sort of figure out 150 drawings versus 25. But I will say, now that we have BIM, we're creating these really robust models. We have a lot of data that we're sort of hiding away right now in our models that are not getting portrayed to the contractors. So I actually think if we leverage that data in a smart way, that we will start to increase the bottom line of what contractors are doing. At the end of the day, as designers, what are we trying to do? You know, we're trying to convey the information of the design intent, and all the things that the contractors need to construct the building to the contractor. Yet we don't share that information until, like, CDs. We've been working on this project for years. We give contractors like 2 weeks to figure the project out, right? And so, you know, all the stuff that they have uncertainty in their minds, they sort of throw over the fence in terms of like allowances of dollars. And even when that happens, there's going to be change orders. So, and you know, so I think we can do a better job of that, way better. This is sort of also a graph, sort of personalized, I would say, of how different our industry has changed over the last, you know, 25 years. I mean, how much more, like, again, I had a telephone on my desk back then, not even email. So how much more, like, sort of distractions that do we get today from texts, from phone calls, from whatever, from internally between Skype, which are, by the way, not as good as just talking to somebody, right? Today, as in 1995, it's way more. Distractions are unbelievable. We're creating much more documentation, information on our models. We are doing way more analysis. I mean, daylighting stuff, that didn't exist back then. And so, including like, I used to do 2D models, and you had to use your inner engineering intuition, to sort of convey the 3D aspects of behavior. But now everyone just goes straight to 3D. And by the way, it just takes a lot longer. In terms of delivery, we're actually, some projects we are issuing 3D models, so we're actually doing more. We're actually creating models, but also 2D documentation. And I would also argue that designs have just become way more complex. And the amount of change and churn that goes in on a project, because it can be done in Revit and things, happens. So we have to deal with that. So I want to get back to this, this idea about the 2D drawings and why we shouldn't be issuing 2D drawings as the main reference documentation. So this is a project I worked on. It's Cornell Tech, not the one on the right, the one on the left. But the standard of care is what happens in the right. So this is a Cornell Tech project recently built. And we still deliver these types of documentation, but if you really think about it, what are we doing in 2D? We are showing just representations with a 3D model using symbols and annotations. And guess what? We have all of that. All of that is conveyed in the 3D model just by clicking on things. So this is just an example of a certain beam that I'm choosing there. It has the size of the beam, which is required, obviously. It has the forces, it has the elevation, it has the materials, and it has finishes, all embedded in the model. So this is a program that we had created. It's out there, it's publicly, it's construed, but this is just the viewer part. It's an interoperability platform, but this is the building. And imagine if we had shared this with a contractor early in the design. Again, they can't change anything, it's just a viewer. But they can start to understand the complexity of the model, quantities of the materials, the sort of logistics sort of being built in their minds. It takes the questions out of what's the interpretation of the 2D into the 3D immediately. I mean, you get more information spinning around a model like this. So I click on the member, all that information is there. They can't change it, they can't modify it, but it's there. So you get more information out of spinning around a 3D model like this with all the attributes there than if you spent probably a week looking through a set of 2D drawings. So that's sort of what I'm proposing. So let's look at the process. So this is sort of pretty conventional process of engineers and architects go away and work all the way through building up a certain amount of data that eventually gets passed to the contract. Now you can argue about percentages of how much information contractors create from our data, but just use it as a reference point. Again, I made these numbers up, but that's my sort of sense. So we create a lot of information, but the actual, for instance, let's take this podium. We may draw this box and tell its material, but contractor has to figure out, where it gets sourced, how it gets mitered, how it gets joined, all these things. That's the logistics of building this thing, which is potentially 2 to 3 times more information than we just showed the actual outline of this. So that's kind of what I'm getting there. And so you can see that spike in this sort of construction. There's a big chunk of information that they create just to get started. So as I mentioned, that 2 weeks, again, I'm dating myself a little bit, but there used to be a game called Find Waldo, and there was a person, Waldo, buried in this really complicated puzzle that you'd have to find. And it was very popular back, 80s, I guess, I don't know. But that's kind of what it is for contractors. We give them A, E, C, MEP drawings, and they have to find, the subcontractors did, their trade scope amongst all of those drawings in 2 weeks, and they could be spread across multiple drawing sets. So in a way, it's kind of not fair. So there's a huge risk when subcontractors bid drawings. So what I'm proposing is that we share digital data throughout design process. There are known things during the design, even at SD, that we know start to convey intent. Codes, certain geometries, certain building shapes, certain things that we just know are not going to change. And that will start to inform the contractor to get them comfortable with what they're getting into. As well as showing in terms of context, not just a set of drawings with all these different disciplines, but a single model with all the disciplines sort of embedded. And so they understand sort of the relational aspects of all those trades and how they go together, because I think that's also really critical in terms of collaboration and coordination. I also believe one thing that we don't issue today is geometric models. And I believe that the first 100 RFIs in a project is what's this dimension, what's that dimension, what's the relationship of this between that. And if we had just thought about it, because we actually have it in our models typically, is that becomes part of the deliverable. And again, I'm a proponent of actually having some contractors start to understand the project before we say, here's 1,000 drawings that you got to figure out. So this is what I propose. I'm proposing that instead of just like in pre-con, contractors are there just to price things, but actually to sort of be part of the process of informing the design. Not to change the design, because I know, our engineers, architects don't necessarily like someone poking at their design all the time, but at least informing them what's important, what's critical, what's sourceable, some of those embodied carbon aspects. And then that way, that information starts to be conveyed early on, and they have a jump start in a way. And what that does is that pulls the schedule forward. All that information that they need to figure out in that first chunk of time after the bid is now sort of pushed forward. And particularly with trades like structures and things, which is critical path, these are really important aspects. With all that, the risk goes down. And I'll just take this as an example. So today's standard of care, we issue drawings. All these things that I'm sort of mentioning, I bet you there's a lot more, but I'm just putting there as an example. And if we do the 3D version with all these aspects that I'm talking about, 3D model with the, again, uneditable, you can't change it, all the metadata, good geometry, coordinated models, visibly coordinated models, you start to take away some of those things that the contractor has to figure out. And therefore, you're going to have much more likelihood of having a successful project. And so there's something that we coined actually, but regardless, it's the process. I'm going to use this as an example. This is one Vanderbilt, New York City. We call it Advanced Project Delivery. And we're doing, just to give you a sense, Severed Engineers is the structural engineer of record. We're doing the connection design. And we got involved as a connection design engineers for the steel fabricator at DD, just to start to understand the project, get some of those data points that I was mentioning. And what that does is it pulls all this information forward. Again, if they tell us that something is a little bit gray, fine, we'll lay off it. But as things start to become firm, sort of set, then we start to build into the sort of fabrication. And so this actually de-risks the project and shortens the schedule substantially. So on this particular project, again, it's 1.7 million square foot project, really, really complicated in the middle of New York City. This project saved 8 months from the bottom line of the schedule. We didn't change anything in terms of what the engineer delivered at the end in terms of CDs, but we sort of got in their mind of, as it relates to steel fabrication. Just that saved 8 months, which is huge, obviously, for a commercial developer, right? And that's just one trade. So this is what I'm a huge proponent of, and I've seen it work on many other types of projects, and I think we just need to change that. Now, there are, and then the discussion has to come up. I was talking to some people over there about jurisdictional issues, and that's where I believe drawings will still likely be necessary, at least for the short term. But I do think that as it relates to direct communication between designers and contractors, we can we have the ability now to do digital delivery. So we can't keep doing this model, which is the really complex BIM modeling, delivering 2D documentation. Thank you.
So first, I just wanted to say thank you to Ryan and you guys for having a contractor here to bring it home with the last presentation. So my name is Brian Krause, Vice President at Clark Construction. Clark, we're based here in the DC area in Bethesda, do about $5 billion worth of work a year annually. And also lead a company that we recently started middle of last year called CODA, which is focused on construction data and the use of construction data for different purposes. And one of the pieces of that is our computational team. So what I'm going to show today, we actually haven't really shared publicly, but when I saw the conference come up, it's here in DC, I live in DC, and thought I'd really like to hear some of your feedback, and I think it would feed to the conversation. So I'm going to talk about three things today, starting with our computational workflow, then getting into scripts that we're writing, and I'm going to get a little bit into the weeds with some of those scripts, and then how are we sharing this information across the organization, which I think items 1 and 3 have come up a lot here with design firms, so I'll give you a construction firm perspective. So a lot of tools out there that we all know, and I'd say this is a very important slide to us of this is the foundation of how this works for us. So our building data workflow is not focused on having someone that knows how to use all of this on each product, on each project. It's more about just teaching the fundamentals to our project engineers to consume that data. And it's more than having our computational team do the setup and automation and the development to feed our project engineers. And this is a shift in how teams are set up on the construction side. So traditionally on the construction side, you would have a VDC manager or a BIM manager that does all of this. But our model's a little bit different. Our model is having that computational team consuming all the models that we get for every job, so architectural, structural, MEP, as well as getting them from all the different design firms, all of you guys that are in the room. So that central brain, as we call it, is then feeding the project engineers, and it's more of a distributed analysis model. So the engineers are the analyzers of the data that's coming out of the computational team. And our computational team's doing things like organizing, supplementing, augment came up a lot today, code checking, design QC, and turning that into building data that then we use for enterprise architecture purposes at our firms. So this is core because I think this is what makes our system work. It's less about the scripts that we're writing. It's more about this workflow. And we have 5 computational folks working on the left-hand side of this that just compute all the models that we get from our design and subcontractor teams. So that's our organization of how we're working with computational work right now. So these are the scripts and how we've organized them. So I'd say there's 6 different types of scripts that we're writing, and they're really in 3 different buckets. So the first bucket is project setup. So project setup is just some automated workflows, and they're very simple workflows, just exporting PDFs from the model, exporting DWGs from the model, exporting NWCs from the model, just simple workflows that help us. And then there's the supplement BIM, which is kind of the augmentation that's been talked about today, which I'll talk and give some examples about that. I'd say the second bucket is what we just call design risk identification. So it's looking for some code compliance items, and it's also just doing some quality control checking of the model. And then the third bucket is what we call enterprise data architecture. So it's now organizing that model for estimating purposes and organizing the scope, as well as organizing it spatially for linking to our schedule. So first, project setup, and going to give just a couple of examples. So one, and we have several in this bucket for project setup, and this is probably what we're doing the most of right now. Very simple one, but something from a project setup standpoint. And actually, let me talk a little bit about formatting here. So every script that we write, we do some documentation around. We say, what's the input and what's the output? We give a visual of this is what it looks like. And then we also track and say, if we were to manually do this, how long would it take? And then how long does it take us now? So we do this for each script. So that's some of what you're going to see on the screen for some of these examples. But this is just part of that project setup. It's importing a DWG by level. Every time we get a model, we normally sign a waiver that says that model doesn't match the PDFs necessarily. So we check that. So we'll normally there's a script before this that'll turn the PDFs to DWGs just through AutoCAD, and then this brings in those DWGs into the model environment, and then we can check to see if the contract documents are aligning with the model. So this is one of the first just project setup things that we do on every one of our jobs to check the 2D documents against the model. This is part of that augmentation or the supplement BIM thing that we do. So it's this is just a simple king stud generator. So we could, in our project execution plan, if it's a design build, talk with the design team and say, hey, could you build into your family a way for modeling king studs in a certain way? Or we could buy with our drywall subcontractor king studs, or we could automatically model those king studs based on a series of rules. And that's what we've chosen to do here. So it's, and all of these scripts are based on getting lots of data from different firms. So SOM may model one way, and Perkins & Will another way, and HOK another way, and HDR another way. And so we don't really trust the script until we have, a dozen or so models from different design firms to test it and make sure that it works right. So this one just generates king studs that helps us in the coordination process. So moving over to the next bucket, design risk identification. These are some of the things that we've written. You may look at this list and say, hey, some of these are commercially available through other tools. I think, one of the presentations earlier in the morning was, some of them are commercially available, but sometimes when we run them, we get false positives or false negatives. So we have written some of them ourselves to trust our own logic behind those to get the answers that we think are the right answers. So, one of the things that we're looking at, this is just a very simple one, looking at toilet clearances and toilet clearances from the center line of the toilet to the wall. And you may wonder, why is a contractor checking this? And honestly, a lot of these are driven by real world problems of, we're about to turn over either a hotel or a residential building with 100 units in it, and if this wasn't accounted for, and the inspector comes out there right before substantial completion, and you got to move everything, that's a big problem. So us doing a little check like this can just help us down the line. So this is just checking toilet clearances, meeting code. This is one that we've recently been working on, and it's checking coordinates. Everyone hates model alignment when you get tons and tons of models, as do we. And so we've just done some digging into the kind of the internal origin, the shared origin, the base point, the survey point. And the reason this is so important to us is we're doing a lot of laser scanning and tying into building control. So we need those models to be aligned so that as we're pulling in laser scans, it's easier. This doesn't align the models. This just tells you where the models are with all those different points and kind of gives you clues as to where to go with it. So the third bucket then is enterprise data architecture. So this is now feeding a bigger, I'd say, machine. And so one of the things we're doing, like I said, we're getting models from, dozens of design firms every year. This one organizes the 2D models the models by really quantification. So I'm trying to think how to explain this. So for example, if one designer may name glass, another designer may name it glazing, another one may call it storefront, another one might just say GL. So we write into our script, look for glass and glazing and GL and GLAZ and storefront, and put that into the Clark Uniformat B20 code, and put that into the Clark Big Package 088100 glazing code, and put that into the glazing bucket, so that now the quantities, regardless of who's modeling it, goes into the bucket that our estimator knows how to consume it. So again, thinking about our model, our computational team is writing the scripts and writing the codes to organize it so that then our engineers and project managers can just consume it in an organized way. So this is a way to organize cost, and I've just got a short video here that kind of ties into that. So there's the cost side of it, but then there's also just rapid quantity takeoff. So what you're going to see here is us just writing a script. We still manually take off everything. This is just a double check right now. But what you're seeing is a script that pulls all the finishes into a finish matrix that our estimators like to see, which you might say this is just a simple schedule in Revit. But what it's giving us is also the area and the perimeter based on the quantities that how we want to count it, with the correct finishes, and then that can then tie to those cost objects that we're doing. So those are some of the scripts and how what we're doing with the scripts. And the final piece here that I have before we open up for questions is how are we sharing this information? So we just have an internal website that we share all of these scripts. So what you're going to see here is this is just what I was showing. These first set of scripts are all of our setup and augmentation scripts, our design trust scripts, our enterprise architecture scripts. We've got a list of what progress are we with the scripts. Are they developmental, or can we say, hey, we can run this on every project and feel good about it? This just shows, it's kind of our value to how long will it take us to build the script so we can prioritize what are we building. And then this internal website, you just click on it, and then this pulls up those sheets that I was talking about. So the end user who's looking at these scripts can now say, okay, what does this script do? And it's not a spaghetti chart of dynamo. It's this is what it does in normal terms. This is input and output. This is the value, how long this would take. This one's just creating a viewpoint in every room so that when we take a model out onto an iPad, you can just have a viewpoint created like at the center point of the room, or this one might be in the doorway. So this is the way we share it so that our folks know how to consume it and understand what they can run. I think the one that I'm pulling up here from the spatial coding side, this is a script where we're chopping up the building mass by zones and areas because this is important when we're linking it to a schedule. So it's great if it's level by level, but sometimes you want an entire mass because you want schedule objects within that mass to tie to the schedule. So this is us linking that to more of a mass to tie into our schedule information. So that's what we're doing, and time for questions. Yeah. We'll take this.
All right. Anybody have questions?
Thank you so much for all you guys shared. Brian, a lot of what you were talking about is like data cleanup from really, I'm not going to say it's bad data, it's just everybody's unique data that you're taking and you're standardizing. From your standpoint, what would you like to see as far as data standardization before it comes to you?
Yeah, and actually that was one of the early discussions as we were getting into this from one of my bosses was, hey, if we're in a design build job, shouldn't we just be asking this of our designers and specifying it in our project execution plan? And we still do that. And we'd love to get that, but we also recognize the challenges of getting that in a clean way. So, we can say, hey, build this, using the example I used in there, build this toilet clearance into your family or your model, or do we just write it and say, don't even worry about it, we got it. So we still write in stuff into our project execution plans to try and get to those standards, but we also recognize designers don't like having contractors tell them how to model.
Yeah, I mean, that's really hard, right? A large company struggles with standardizing data just within their own company of how things are going to be named, let alone an industry-wide standardization, so.
Yeah.
Yeah, hi, Greg Seaton from CSI again. I wanted to ask Robert about his presentation regarding really that sort of earlier turnover, big room type philosophy for sharing information earlier so that you can avoid mistakes later, all that stuff. That makes a lot of sense, but my concern immediately was, how does this work on like a traditional design bid build where you haven't even selected the contractor at that point in the project?
No, that's a good point. I would say that, again, most of the projects that I've worked on are private projects. Most of the projects that I've worked on, the CMs, like Clark, have 4 or 5 subcontractors that they use on every single project.
Sure.
And so if those 4 or 5 contractors were, pre-qualified to have a portal into the project, they should be allowed to. Everyone sees the same thing. It's a level playing field. There's nothing that, you don't want to hide things. I mean, designers tend to hide things because they know things are in flux. But I'm saying the things that we know are not in flux, those are the things that we share.
Sure, sure. Well, and I'm sorry, just to follow up on that, I think that makes a lot of sense. But how would you adopt it for something like a public project or something like that? You really couldn't, could you? I mean, I don't know.
Change the rules around public bidding. Look, I mean, I work on public projects too. I mean, DDC projects in New York City, GSA projects, they're the most expensive projects. They're the most expensive project on a per square foot basis than any other projects, and the reason why is their procurement strategies. So they need to change. I mean, I don't know how that works. I mean, I'm not in the government, but if the taxpayers want to save money, they got to change that process.
Well, to that point, the Smithsonian Institution, as many of you may know, has been renovating their Air and Space Museum here on the Mall. And when we were talking to them earlier about how they were doing that, they have pre-qualified 5 or 6 general contractors that have 5-year contracts with them. They have found a way to do this. There is a perception in government that the only true value added to an owner is through design bid build, and I think that is a paradigm that's been sort of baked in over many, many years, and it's just the traditional method, which is not a good one anymore.
Yeah. Look, New York.
It's like your illustration, your final illustration. It's a really bad delivery method with a nice Ferrari sitting on the top. It's really not good anymore.
Again, I'm speaking specifically for New York, but Governor Cuomo he's now like the biggest cheerleader for design build projects. Because it kind of takes away some of that bureaucracy that exists in government contracts.
Stone with HIT Contracting. Thanks for your presentation, guys. So Robert, I have a question. You said that we should look at the standard of care differently. I mean, would you take it a step further and say that you could have right of reliance on the model to build from?
Yeah, I think so. Yeah, I mean, look, I think if the day that we start, again, 10 years ago, I would say that would be a little risky. Everyone's sort of learning the software. Things were not weren't very stable in the software. They're pretty stable now. I would say that if you were to tell me that this was the deliverable, we would make sure that the geometry is right, that the standards of care were correct in terms of BIM modeling, that is. And so as long as, engineers and architects are pretty good at modeling now. So I think we could do it. Yeah.
Robert Anderson with Matrix, and I have a question for you, Robert. Actually, it's two. One is one of your slides suggested that that shop drawings were going away. You sort of had a red dash through shop drawings. Do you think that's really true? I mean, it seems to me that's a little extreme.
No, I don't. My point of doing that was not to say that shop drawings are going away. That we, again, this is after many years of reviewing shop drawings. We, as designers, don't do a very good job of standardizing what we expect from shop drawings.
Yes, okay.
And so if we can have templates, let's just say, of this is what I want to see back, just like regurgitate or reinterpret what's in my drawings or models back into the shop drawing in a very curated way. First of all, it makes my review time way easier, but also there are things that contractors need from our models to create shop drawings that we already have.
Right.
That's the point of that.
Okay.
Yeah.
The second question is, and I think I thought your presentation was really provocative. With greater reliance on a well qualified model, do you think? And you said you think drawings aren't going to immediately go away. In any case.
Right.
But you talked about the history of like John Hancock versus more recent things and how much extra you had to draw.
Yeah.
Do you think it would be possible to reduce the amount of actual documentation if you're accompanying it with a well-qualified model?
Yes, and actually Nick Cameron had a really good slide up there that said that 40% of what they do is documentation.
Yeah.
And I guess my point is if we spent some of that time in creating a really clean model, standardized model, we can potentially save time, but also at least take some of that 40% and put it into the models as opposed to putting it into annotations.
Something that resembles more almost of a permit set rather than a true contract set, because the contract is a model.
Yes, and by the way, just bring up that permit set. I had a very good meeting maybe 3 months ago with the Deputy Commissioner of New York City, and he's like, I don't really care about the 2D drawings. He actually wants the 3D models. He wants to, because cities want that 3D information now. They realize that that's more important than a set of drawings that sits in a closet. And so that was very interesting for me because I know for many years, permit sets are kind of throwaway sets. I shouldn't say nothing. They only are representative of what the actual build project is. So yeah, I think we can be smarter about that as well.
Thank you.
Yeah.
Gordon White, HDR. I just wanted to throw on to what we were just talking about. I'm actually working on a project right now that the model is part of the deliverable. And one of the red lines on your list was that, for example, the on-site mechanical and plumbing coordination in the ceiling would no longer have to be done there, would be the model. And 2 points to that is, one, that means we have to do the work. So that is a lot more time to organize that. And now that the client is seeing the model, they will see every little problem and be able to say, well, that doesn't, that little thing that normally we ignore doesn't work anymore. And so, that expectation of perfection and that extra level of work we have to do you have any comment on what that means for us? And also how we present it to them? If we're not presenting it in drawings, how are we presenting it to them?
Yeah, well, I would argue we're supposed to coordinate those drawings. And I'm not saying necessarily to the degree that contractors do, but at least the first pass. I mean, I can't tell you the amount of projects that the first thing that happens is that the contractor redesigns the mechanical layout. And guess who that affects? Is me as a structural engineer. And I have to eat it. I got to eat all that stuff. I've already spent the time, or actually I shouldn't say that. A lot of MEPs, engineers have been late in adopting BIM. So, I would say the last few years has been pretty good, but prior to that, it wasn't. And so, I think we need to do that. We need to do that first pass coordination because, I'm sure you've seen it many, many times. The first thing that happens is we have to redesign things.
Yeah, so we've had this discussion, so this is an interesting one. One of the things on the last point, Craig Schloesner, again, is I would venture that you might say that the structural engineers probably get closer to designing everything than architects and mechanical engineers do right now, I think generally, because there's a design intent discussion, there's the insurance gap discussion, which is a whole separate one on the design build side of things. But there is that on the architecture side and the mechanical side, definitely there's this huge gap between designing everything and designing intent. And that hasn't been figured out when it comes to how you would possibly manifest all that into the model. I think it's a valuable discussion, but it's a huge gap that structure is simpler, I'll put it that way.
It's simpler, but I guess what I'm saying, I wouldn't say it's simpler, but I would say all architecture and MEP affects us directly. So, I think that first pass needs to happen. It's supposed to happen. I mean, M has to coordinate with E, with P, with architecture, and with structure. That's supposed to happen. And I would, again, if we had that sort of early delivery of that coordination model, that's not coordination model, the design delivery, then, those subcontractors would say, I wouldn't do it that way. I would do it a different way. And that conversation could be had, at least at then. And then it's easy to change for me as a designer to adjust then as opposed to post CDs.
Yeah, and I certainly understand that, and I think one of the things we've been on projects where we've tried this design assist model where you try to inform that process as quickly as possible, but it's not field conditions, there's not necessarily always the interest in solving it during design because it's a messy process. Flipping gears, the one question I did ask, and it came up a lot, was would you have done, David, is that your name? I'm blanking. Brian, sorry. Would you have done all the work you're doing if it were not design build projects that you're focusing on, or is that specific just because it's a?
Oh, yeah, absolutely, and because we own the risk on either way. So absolutely, yeah. I mean, we're doing it in all of our jobs. Yep.
Yeah. Okay.
Yeah, Brian Juge from MG. We're talking a lot about the design process, the construction process in here. We're spending a lot of time with that data and gathering that. Do you guys feel that we are moving towards a trend where we have a social responsibility or obligation to the building owner and the facilities for life cycle and for future things that will happen to that building, expansions and stuff?
Absolutely. Yeah, I mean, I didn't even touch that, and I think that was mentioned before. Maybe Z had mentioned it about facilities management. Is what happens after we give the keys to the owner. Yeah, I mean, I would say the only projects that, from my experience, that happens is like university type projects, where the facilities people have a voice at the table. Yeah. A lot of the private projects, don't. So we rarely think about those things, I would say.
Do you think that might be because of how we've handled things in the past? We have those drawings that are put in the basement, or we have that 3 1/4 floppy that we've put in the desk drawer that's no longer valid anymore, and maybe we need to look for a cloud solution or something that would keep that data pertinent for future?
That's a real complex question. I will say there is no standard for handing off a project from a data standpoint. It's not a Revit file. Revit files are useless after 4 or 5 years. So I can't tell you what that is, but that's a real issue. I mean, we're struggling just to get coordinated models as opposed to models that live forever. But yeah.
Well, and I can say from our standpoint, we've probably got 10 or 15 active jobs right now where we have some sort of digital deliverable. I can rattle off a bunch of them: Otay Mesa, P114, Kansas City Airport, BWI Airport, SeaTac Airport, a lot of airports. Yeah, I mean, so we have to right now. And, part of what you're seeing is, it's the computational side, but it's feeding into, hey, we have these requirements, and we need to deliver this data in a certain way. So let's cleanse the data so that we're meeting the deliverable. Mm-hmm.
Pratty from David M. Schwartz. I have more of an observation, not a direct question as such. I'm working on this amphitheater, and the end deadline is fixed. There has to be a concert on a particular day. So what Robert mentioned, we are sharing the models ahead. And we just finished an SD deadline where a PDF was just for some dimensions, and the main deliverable was a model which the structure and everyone could start working off of. But something that Brian told me really got me thinking that Revit is essentially a database of information, and there are just different ways of viewing it. And the way to pass that information is having keywords. And I feel there should be a conversation early on that if you're having to pass different forms of glazing, why not have families and everything with the CSI number already? And why is that not a building standard already? We are coordinating with our architect of record to import their finished schedule into our design early on so that they don't have to rematch things. So I think there needs to be more conversation about in what format the deliverable has to come out, and can we, as architects, can we give that information ahead of time, or can we incorporate that into our workflow, from the get-go?
I mean, honestly, we were talking about this at lunch today, right? We can do that today. It's pretty easy. It's actually really easy. We just tag Revit elements in their correct families with, whatever CSI number that is appropriate. And then, people can filter through a 3D BIM viewer of the different various trades. And look, that will solve 50% of all the problems of who's doing what and what scope is going to what subcontractor. We can do it today. Actually, GSA, to their credit, was one of the first to require that in detailing. So if you drew a section, you had to tag every single thing in the section to a certain spec section. So it was a known who was going to do what, who was responsible for what.
Violet, Columbia Sidewalk Labs. So we're at the AIA, and I'm wondering, what should the AIA and policy and what needs to happen on that front to get to where we need to be in the future?
It's a tricky question. I mean, the issues of standard of care, as I was mentioning, is a legal term. And I think it's going to take, people in our industry, firms in our industry, just to take that risk. Because, again, from our experience, by giving more information earlier, we're actually de-risking our liability. In terms of what AIA does, yes, they should start thinking about that. Like, what does the next 5 years mean in terms of issuing models, issuing data, not conventional times, let's just say that. But they need to. That's part of what AIA should do.
Yeah, and I think, earlier there were comments about, just how we track carbon and, some standards around that are, I hate using the word enforced, but similar data standards, because as the data gets requested by the owner for facilities management purposes, if it's not being created in the right format, then it's not being delivered in the right format either. So it's just some of those data standards as well.
My suggestion that, this is Ed Gavreau from Corps of Engineers, but also the Public Architects Knowledge Community. It sounds like the fact is if we're looking for AIA to come up with a standard of how, it probably might be a good idea if TAP would get with the project delivery knowledge community, because they would probably have the best background to assist on that. So just tossing it out as a suggestion.
Interesting provocation, and we're talking about, I think it's kind of an interesting combination of like Nick and Matt's talk, where instead of automating drawings, we're optimizing the creation of drawings and if we should even create them, et cetera. But drawings have, as we saw in a couple of presentations, a long history of convention and mutual, hopefully, understanding between different parties, and with the kind of the charts and the pseudoscience graphs, which I love, actually, you're kind of presupposing that, like, if we just have all the data before us in the form of a model and what? So I'm kind of curious about this responsibility of taking on the UX, or user experience design, of what the new format for conveying data or information will be for different audiences. So quick ABC to this would be maybe like, are you talking with your particular audiences? Like, are you getting feedback? Because one, I think, interesting ability here would be that, and you've made many web platforms, would be to understand who's looking at what for how long.
Yeah.
Usually we track like kind of failures in drawings by busts and kind of lessons learned like over longer periods of time. How do you envision the kind of the new user interface and metrics for?
Yeah, I mean, what I envision is a combination of, because it's possible today, is 2D drawings with 3D views, side by side. 2D views because it's conventional and it's how we work, actually, as design. We work on floor levels and right, we live on flat floors typically. With all the associated metadata that is required to understand a project. And, this actually is something that I've started to at least tease out to our QA/QC folks, in that I kind of tell them, okay, you can get a set of 2D drawings at the end of SD or DD, let's just say, that are basically trash because the next day the model has changed, or we can send you an up-to-date 3D view of the model with with all the appropriate sizes and everything else. It's a way more accessible, data-rich, information-rich model to view as opposed to 2D set that is probably no longer valid. It's going to take baby steps in terms of have people moving completely from 2D to 3D. But I think there's a transitionary period, and I think we're there now, where it's a combination of both, 2D and 3D.
Hi, thanks. Greg Seaton from CSI again, heard our name mentioned a couple times. It's worth noting that absolutely what you're describing, the old method of the GSA promoted it first, we're probably one of the earliest adopters, of using coding, the CSI codings from the different taxonomies we have to identify objects. CSI is currently ending about our 6th month of a beta test for a software deliverable digital delivery via XML and JSON of all of our standards, all of our taxonomies. It's being generated largely for use by software developers, but also large-scale owners and, of course, contracting firms that may have their own shops in-house. So if anybody is interested in participating in the final few months of the beta test and taking a look under the hood and playing with the, getting some GET Postman calls back and things like that and looking at the API, we would certainly appreciate it, and just come by and give me a card and I'll be happy to make sure you're on the list. So it will be commercially available sometime later this year.
Yeah, I wanted to, Tim and Hazel from Walter P. Moore, I wanted to go back to the 2D versus 3D conversation that was started earlier. I know you and I were talking about it a little bit, but I believe that it's very much going to have to be driven by the permitting when it actually gets jurisdictionally covered. I love the fact that there is a lot of exchange already between contractors and designers, even if legally it says, all those caveats. But we have AIA here, we have Autodesk here, we have startups here. What would you say to them about what we could do to supplement the permitting process? Because if jurisdictions have our models, they could use them in bigger ways, but that has to be marketed to each jurisdiction, and maybe it has to be driven by GSA or somebody else. But what would you say to those people? And I kind of want to almost open this up to other people who might contribute to that conversation. Because we're going to go 3D, but we have to kind of help make it happen.
Right. I think with any, sort of particularly software development, you have to understand what the needs of the end user are. And, when I spoke to the Deputy Commissioner of New York City, they were interested in mainly egress and fire safety issues. I've probably signed hundreds of drawings in New York City. I've had one comment over 25 years. One. So they're not really looking deeply into the structural drawings. So, maybe the fire egress, we detail the hell out of it and give them what they want in 3D. The rest, you know, we can give it, they are interested in the massing and the exits and all of those things. We can give that to them, not in just 2D, but 3D. So, you know, I haven't really started that process, and I don't know if anybody else has, but I think that's where it's going to start.
Nick, did you have a response to that? That we were, yeah.
Nick Cameron from Perkins Will. So whenever we talk about models deliverable, usually the first question I ask is, what model? Because I tried to open a model from our New York City office like 2 weeks ago, and it took a day. There were 12 models, about 2 gigabytes, and it was a horror show. So I don't know what we're sharing and how you would ever know that it's up to date. You kind of look at the sheets are half there. Oh, we didn't have the structural model, so we didn't have this in there. How does that become viable? And when we talk about like baby steps, that you're saying, Rob, I'll go back to, and there's a Twitter feud going on right now. It's like, is that in 10 years or not? And I think we're winning. We're like at 75% right now, that there will be 2D drawings. But the other thing I would say, and to both of you guys, is because we do partner, and I think that's the bigger kind of takeaway is, you know, we as Perkins and Will work with Clark, and we do, and with TT, and we do, and we need this level of trust to move things on, in that we understand that when we share data, it's in everyone's best interest as well as the clients. But that's tough to do with folks that aren't in this room or folks that we don't know, and we don't know their capabilities. I know Brian's team's capabilities because we've been working together for about a year and on other projects. And I think that's the kind of broader thing that we all have to take away from meetings like this is to kind of spread that gospel of let's try something if we want to get somewhere in 10 years of these baby steps. So that's the nice part. But I asked the question, like, what model are you sharing? What's the format? What is it that we're looking at?
And I think that that's a good question. And look, obviously, it needs a good model, whatever that model is. But it also, I would say that it starts with the subcontractor back. In other words, you know, the steel fabricator is going to need, you know, again, I'm a structural guy, so this is what I've been doing, is, you know, member center lines, and they don't care about the slab. They don't build the slab. So member center lines, materials, you know, things that we have in our models, and you know, very geometry specific. And again, BIM model. So the hard part is that right now that geometric model concept I haven't seen really exist. I mean, I think a lot of facade contractors interested in just geometry because we have to recreate a lot of that content. So I don't know the answer to that. I just know that we've done it in various ways. We usually, for steel fabricators, we give the Tekla, at least a starting point Tekla model, which is usually more accurate. And so that sort of has geometry embedded in all of that. But I think it starts with the sub, you know, if you're doing, you know, this table or stud walls, it's going to be different information for each of those people. Yeah, but I do think it would be worthwhile for people in the room to test it, like one trade on one project or one floor on one project, just to understand like what that means to the process, you know. We've done it on projects, and again, we have the same sort of, you know, CYA type verbiage of you can only use a model for reference. But then, you know, like firms like Clark are actually back-checking, right? Back-checking certain things. So I think there is that trust issue that we do need to, we don't want, because we've all had it done to us, sort of thrown back at us, and, you know, it becomes like some crazy change order or something. But
and one thing I would say to that is, I mean, even right now in the paper world, that's still messy. I mean, we'll have you know, an architectural set and a structural set, and one of them might be conformed, and, you know, but there's another RFI out there that changed something that's not in that set, and then there's a shop drawing that approved something, and I mean, we're dealing with all that data in different formats now. in the field as, the concrete pump truck is pumping concrete, and we got to say, which one do we pick and which one do we use? So it's happening now, and I think just making it digital, I mean, we're still going to have multiple things which is the right model and which is the right data to trust, but having those processes in place to say this one governs over this one, just more from a paper standpoint, it's now becoming more of a digital and data format.
All right, last question back here.
I want to piggyback on Nick's question about, what model do we deliver, and also pair it up with, something that Rob mentioned earlier, the 24 set of drawings versus, the hundreds. Are we creating more drawings because we have systems that allow us to create more drawings? Are we creating more drawings because there's a shortage of master craftsmen that are assembling these buildings together and understanding what these drawing sets are? Like, there's something wrong, right? What is the root of that problem, and is that what we should be fixing?
Yeah, I mean, again, this started with AutoCAD, so I would say the craft of being really precise and economical about drawing creation was thrown out of the door, because you could create drawings really, really easy, copy-paste, right, for each floor level. If you look at the really efficient, the older drawings from the 30s, or those are the ones that I'm used to anyway, like Rockefeller Center or something, they would say, floors 3 through 15 the same except for these little things, and they would draw, and the whole sheet would be covered with little details and notes and things. Now, if you look at our drawings, there's a lot of blank space, a lot of real estate there. Wasted space. Again, if you're printing on paper, in the digital world, it doesn't matter. So I think the first part, it was just that. We created drawings, additional drawings, because we could. And then, that sort of art of being super economical and efficient and clear with doing bare minimum to show the right design intent has been lost in the process.
All right, well, round of applause. Thanks, guys. So we got 20 minutes left. We can do this. This for the last session is just basically an open discussion that we'll use these the little worksheets you guys had to sort of guide the discussion. So I guess I'll just open it up and say, is there, was there something on this list that you can't see? You have it in front of you. Is there something on your list that really jumped out to you that we need to either keep, toss, reimagine, or, any of those? So does anybody have something that really jumped out at them they want to, so just say what it is and kind of talk about your revelation. Come on, I warned you at the beginning I was going to ask you this question, so.
I put down, Gordon White, HDR. I put down for automation, tossing. I put down wood paneling. And that was how I'm going to remember that you got to keep track of your automation and make sure you don't codify something that you don't actually necessarily want in the future. And keep an eye on your process of automation.
Robert Anderson with Matrix Design. I think a theme that came up multiple times today is what's the role of the drawing? And currently we think of drawings as static artifacts. They're things that are created from a model, but designers and architects beat their brains out, sort of annotating and sort of making an artifact out of this thing. And it seems to me that one of the things that one of the themes that people sort of would aspire to, and I see coming out of this, is the ability to think of a drawing as just a dynamic and on-the-fly view of a model that can be just created, called up as it's needed, and then, poof, gone away. And I wonder if that's not something that we could begin to look at as an actual theme for future treatment of this.
Hi, I'm Kate from Stillman. I actually can't decide whether to put this in keep or toss, but for practice, 2D deliverables. And the reason I say that is because it sparked an interesting discussion this morning. I actually put it on Twitter earlier today as a poll, and I only have about 30 votes so far. It'll be up for a little while longer. But so far, 80% of my respondents say that 2D is never going away. Only 20% think that 3D deliverables will outpace 2D in the next 10 years. So I don't know if we're more optimistic here than the crowd on Twitter, but that's was not how I expected that to go, actually. Kate M. Town. I tagged AIA TAP, so if you look for that.
Well, just bridging the discussions about drawing creation from Nick this morning and the discussion there. I mean, the way I look at the drawing automation, the automation discussion around drawings is to make space to spend more time in a model. And then at that point, once you can make a model more authoritative and drawings are automated, they become free. And so I think at the end of the day, it's a slightly circuitous path, the way I would describe it. I think we both share the view that's what we have to do right now, but I don't think it's, at that point you could produce as many or few as you wanted to, but we have to get past this point of producing drawings right now anyway, so.
Hi, Lily Smith from Autodesk. I put under create and practice a new definition of, a wider definition of multidiscipline, and including people like statisticians and data scientists, and the importance of combining a wide range of people in your team that's creating automation, and then thinking about human-machine collaboration within that as well.
And feel free if anyone has comments about any of the, this can be a discussion back and forth. So if anyone has comments on anything anyone said.
Something that stuck out to me today was just aligning incentives. It seems like, and maybe that's in the create bucket for a lot of these, but in general, it seems like the discussion between 2D and 3D, or even the idea of getting the right data to answer the right question, all comes back to this aligning incentives across these various disciplines. And right now we have a very fragmented industry. And so how do we start to, what are the different methods and mechanisms to align all of our incentives in the right way?
So in the create bucket, I had something that's maybe a subset of what Violet is saying, because I had, and it could really go across anywhere, but let's call it automation or analysis. The idea of design metrics and redefining or creating, I think it would be sort of reimagining design metrics and what we consider a metric that can be counted. Is it qualitative? Is it quantitative? And I think that helps towards aligning an incentive when you can describe that metric in a slightly different form than we currently do.
Yeah, I think we talked briefly earlier, I think when Brian talked about facility management, we talked about BIM and the data. I think this could be in create for data, or it could be also in practice.
Gustavo from FX Collaborative. I wrote this down in augmentation, but the more I think of it, I think it really applies to all five categories. For Keep, I had the joy of creating. Don't automate away our creative output. Don't automate out what we wanted to get into the profession to begin with. TOS, I think we can all agree the tedium of documentation. Everybody seems to be very excited about not having to spend our time diagramming, bubbling or dimensioning. Create, I think it was interesting when we talked about Deep Blue working with the chess master and the assisted creativity, and something that we have to really not think of it as an either or, but with. And to reimagine, I think the bottom line is that we really have to reimagine our process. We have a very antiquated process that we really need to rethink if we're going to really fully leverage all of these conversations.
Yeah, and building on that somewhat, I think it probably belongs in practice, but to reimagine would be the role of the architect, and even down to the way that you collect your fees for the project, because I don't think it's realistic anymore to talk about improving performance and automating your entire process and everything else, and then talk about getting a check cut at the end, hand over the keys, goodbye, maybe next project. It's really about a life cycle relationship with the building and with the building's owners and the people who take care of the building, and almost like design as a service. So it's not a one big check at the end of design, but rather you get more or less money per year, whatever, based around satisfaction of occupants, satisfaction of the community around the building, performance of the building, of course, and everything else that you can lump in there where you'd have metrics to meet. So it's really about reimagining the architect's relation to the building.
So polite. I got the mic, so I might as well go. Ryan Cameron with I'm helping pass it out, but Ryan Cameron with DLR Group. So reimagine process. Yeah, that's totally needs to happen. Create. So we talked a lot about training. So let me see if I get this right. Create a culture of training. Oh, good. Now I got all your attention because that sounds bad, right? Right. So what about if you were to create a culture of learning? Does that sound better? So if there's an idea that your whole firm can get behind like that, I think you're going to see a lot of change. And I don't think the 2D versus 3D is going to be that big a deal, because if we really wanted to push for 3D as a deliverable, we could do that tomorrow. We do that now to some degree, but we need to get our, how do I want to say this, our stuff in order to do that. And that's on us. That's on us. We're the ones helping the public, right? That's what our jobs are. So reimagine your culture and change it from a culture of training into a culture of learning. I think that's one of the takeaways. And then I hear the word data a lot. So here's how I'm going to try to boil this down. So I have something to prove that I was here and stuff. So the leaders will be movers of data that create enhanced architectural space that elevate the human experience. That's what I took away from this today. I think it was great. Everybody did a great job. So thank you, everyone.
All right, we have a contribution from Russ online under Reimagine. He says, broaden the toolkit, embrace the need for a unique set of interoperable tools to solve each unique architectural problem.
Melissa with HDR. I have one under practice, and we were talking about a little bit earlier, the master craftsman. I think that if you look at it over time, I think the master craftsman was responsible for a lot of disciplines, and you look at it now, I think that a lot of the digital practice folks in this space are considered master craftsmen. We have the ability to jump in and out of different tools, understand different data, develop scripts, and I think that that definition in terms of architecture is kind of evolving.
Hi, my name is Dave Kratzer. I'm the Director of the Architecture Programs at Thomas Jefferson University in Philadelphia, and I've really enjoyed the talks today. I was wondering if I might pose a question as to us backing up for a second and thinking about students entering the academic world as freshmen and the dilemma that we have relative to how we, and you had mentioned training versus learning environments, how do we begin to think about shaping students that are moving up through? I'm being a little selfish with this, by the way, you can tell. It's a dilemma for us right now. We have students coming out of high school who already know Revit. And so we bring them into the university, we say, don't work on Revit just yet. Can you draw by hand for us for a little while? Can you sketch a little bit? And then we'll add the Revit back in later. And we've kind of patted ourselves on the back by saying we're developing critical thinking skills, right? And then we sort of layer in the computer on top of this, and it changes the way we think and the critical thinking that happens on top of that. But we're now getting caught in this backlash where the students are coming in even as early as second year and saying, why am I dealing with Rhino? I can do all of this in Revit. Why am I having to back up and sort of start to rethink and relearn all this? It's an incredible dilemma. And again, I appreciate all of the conversation today. It's made me realize the gaps that are beginning to occur in critical thinking. There was someone who mentioned Nicholas Carr earlier on today about how one thinks within the computer and what it's doing, and also the internet adds on to that. So I'd love to hear some topics or some responses to put yourself in the place of some of these kids coming in, and we argue with them quite a bit about the computer, quite frankly. I'd love to hear some thoughts on that.
So I don't have a good answer for you, but I feel like I need to share this anecdote just for my own satisfaction. When I was in school a long, long time ago in India, we were told we weren't allowed to use computers for our drawings. So we would design on a computer, print them out, put a piece of paper on top of it, and draw over it. That's all I have to say about that.
I wanted to contribute to that also because I remember my mom was in education, and I remember her talking about how terrible it was that children were no longer able to hold a pencil. Their muscles were developing for a mouse. And it's interesting to look back at that and say, well, okay, well, was that really a problem? And it could be argued for or against. But I think it's interesting. I've seen education programs now, even at the middle school and younger levels, that are teaching what we would consider computational design. They're already they're playing games where they plug Legos together, and that like creates a workflow. And so I would definitely, my thoughts on education currently is that definitely in the workflow-based and computational design side and the way that is growing, I just see that as being, I really don't see it as being a question of if it or what does it look like. I really think it's going to be a part of everyone's toolkit in the next few years. And that's independent of what software using Revit, or it's more of a thinking style.
But also, I think we as a practice will rely on the academic training that they're going to get, where they're going to be getting, the same way that we're now getting students who know how to do Grasshopper and who know Rhino that we didn't do when we were in school. We're relying on kind of the training in the academia of those young professionals to learn all of these things that we'll need them to know and then come and teach us. So it's both relying on them to learn the new things, and but also we as a profession need to be much more receptive of the younger professionals who need to teach us the new ways.
Yeah, and to build off of all that, I sort of, especially what you just said, I want to question whether the tool that's used to create the drawing teaches critical thinking skills. I don't think it does. I think the critical thinking skills come into conceptualizing the drawing, understanding the problems you're going to face, things like that. And whether you draw it with Revit or you draw it with a pencil, you're still solving the same problem. So I think that is, you know, I wouldn't elevate the pencil, if you will, above its place. It's just another tool, and it's an earlier tool. And these folks aren't going to come into most firms and start drawing with a pencil.
Violet has a question.
I would just say that the industry is changing quite a bit, and just from what I've seen in Columbia and at various schools, I think that there's a lot of different directions that architecture and related fields are headed. There might be a place where Learning to design is thinking more conceptually, drawing. Maybe it's also using these tools, and we don't see that as being overly pragmatic. It's actually more thinking through a different set of processes. But there's also this new developing field, and I think that's one of the big struggles is we're all bucketed together. And when I had to think about getting my license, I just had to say, it doesn't make sense for me because I'm headed in this technology-driven path. And now it's really funny to be working with a lot of architects and urban designers in a graduate program, and I can only advise them to leave architecture. And this is the reality, because when I see WeWork, not anymore, okay. When I see many of these other technology companies working in the AEC industry, I have to say, where are the computational designers that are doing a lot of that types of thinking? It's actually a slightly different discipline. It's related, but I think we need to make more space for those various niches. And so we have to think about maybe more specific tracks or something. And I don't know how others feel on the AIA and others kind of starting to embrace that a bit more, because definitely in the grad program that I work in, that's top of mind for everything. Like many architects coming in decide to go into other types of STEM programs or are going into data science to do those things they want. And our program has so much of that. Like, we should be educating, because a lot of what we're doing already is that. So how do we kind of codify that a bit better in academia?
All right. Last question for Stephen.
I was just going to answer. Last year, my son came home in 3rd grade and said, "Dad, we got to use this thing called SketchUp today." He said, "Do you know what that is?" I said, "No, this is Rhino." And I sat him down, and that's what he uses. So.
All right. It's just about time. I don't know about you guys, but there's several things that I wrote down that actually people put in the same bucket, which is interesting. So we're going to collect all these and we'll scan them in and see, if there's these sort of repeating themes that are emerging, just to sort of, how we can kind of focus in and learn and share that back with you guys so you can have access to it. I just want to thank all the speakers that came and spoke. They volunteered their time for you, for the AIA. It's a big sacrifice that they did, and I think we had a bunch of great sessions, so if everyone could just give them another round of applause. I don't know, is Isabella in here from the AIA? Well, if you see her, you should thank her. She did all of the logistics of setting all this stuff up, so just want to give her a shout out. And a couple final little points. There's going to be a survey emailed out following this. And if you don't take the survey, which I learned that lesson one year, take the survey so you can put in your AIA number to get the CEUs, because otherwise you won't get them. And we're going to put the presentations, we'll post them somehow and share the presentations from the speakers so you can have access to that. And we're going to try to figure out how to disseminate the recordings to the larger audience. We'll have to figure out that process. This is new to us, so as soon as we know how you can get access to the recordings, we'll let you know for that as well. So yeah, thanks everyone for coming out, and looking forward to the conversations out in the lobby.